Have you ever imagined a world where machine can think, learn, and even create like humans? That world isn't the future. It's already here, and it's called artificial intelligence. Everything around you is being shaped by it, whether you realize it or not. Hey everyone, welcome to IntelliPart's Artificial Intelligence full course. Let me ask you something. How does your phone unlock just by looking at your face? Or how does Netflix know exactly what you will binge next? That's artificial intelligence, and it's already shaping the world around us. From healthcare to entertainment, from finance to everyday life, AI is changing how we work, live, and even think. And behind every smart system, there are people who build it. Right now, the world needs more of those people, and that's exactly what this course will help you become. Here you will start from the basics and move forward mastering real AI skills. You'll learn how machines actually learn, exploring deep learning and algorithms like ANN, CNN, RNN, and transformers, the same ones behind tools like ChatGPT. You'll also get hands-on with Python, TensorFlow, and real-world projects that prepare you for industry challenges. By the end of this course, you won't just know what AI is, you will know how to build it. So without any further ado, let's get started.
Artificial intelligence has revolutionized the way people think, learn, and work in various fields from finance to healthcare and mobile apps. What's more interesting is that AI plays more of a role in our daily lives than we can imagine. From Siri and OK Google to various virtual player games and social media apps, AI is everywhere. It sure is the most happening topic in every business right now. It is the most wanted and exciting career domain right now in the market. Artificial intelligence or AI uses intelligent machines that build in a way that they react like humans. The primary process involved in making these smart machines is to carry out decision making, which analyzes and uses data available in an enterprise. It is similar to the human mind absorbing and synthesizing information and providing the required decision. So how does an AI work? AI systems work by investigating large amounts of data labeled training data, analyzing the data for correlations and patterns, and using these patterns to make predictions about future states. In this way, a chatbot that is fed examples of text chats can learn to produce lifelike exchanges with people, or an image recognition tool can learn to identify and describe objects in images by reviewing millions of examples. AI programming focuses on three cognitive skills: learning, reasoning, and self-correction. Learning processes. This aspect of AI programming focuses on acquiring data and creating rules for how to turn the data into actionable information. Reasoning processes. In this aspect of AI programming focuses on choosing the right algorithm to reach a desired outcome. In self-correction processes, AI programming is designed to continually fine-tune algorithms and ensure they provide the most accurate results possible. So there are four types of artificial intelligence. First, we have reactive machines. These AI systems have no memory and are task-specific. An example is Deep Blue, the IBM chess program that beat Garry Kasparov in 1990s. Then we have limited memory. These AI systems have memory so that they can use past experiences to inform future decisions. Some of the decision-making functions in self-driving cars are designed this way. Theory of mind is the third thing. It means that the system would have the social intelligence to understand emotions. And finally, we have self-awareness. In this, AI systems have a sense of self, which gives them consciousness. Now let's see what are the applications of AI. One of the best known healthcare technologies is IBM Watson. It understands natural language and can respond to questions asked for it. AI can automate grading, giving educators more time. It can assess students and adapt to their needs, helping them to work at their own pace. AI tutors can provide additional support to students, ensuring they stay on track. Banks are successfully employing chatbots to make their customers aware of services and offerings and to handle transactions that don't require human intervention. AI technologies are used in transportation to manage traffic, predict flight delays, and make ocean shipping safer and more efficient.
Just a quick info, guys. Intellipath offers artificial intelligence course training, which will enable you to learn skills like neural networks, focusing on CNNs, RNNs, and their application in AI, natural language processing, computer vision, and generative AI. Through this course, you will also master deep learning concepts, AI model building with TensorFlow, transformers, BERT, GPT, LangChain, and NLP pipelines with advanced techniques like image recognition, chatbot development, and much more, all taught by top 1% experts and IIT faculty. And with this course, we have already helped thousands of professionals make successful career transitions in AI and data science. You can check out their testimonials on our Achievers channel. The link is in the description below. And without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take your first step towards the dream career growth in the field of artificial intelligence.
Let's start from here. So you will see that guys, that there are some handwritten digits. So this is a very famous data set coming from MNSIT data, right? It's a handwritten digits, and generally these are in what? 28 by 28 pixelated form. I'll show you the real data later in the course, but although the scale is not very obvious, but if you see this is 20, the last is 28. So basically imagine that every digit falls in like a grid, okay? Something like this. Since it's a pixelated form, right, it looks like 28 pixels by 28 pixels, okay? Every number, every digit, so suppose you say 3, it looks like that. So this is coming from real data. You will see this is a very nice image, although it only shows you till, can you guys see that? I know it's little tiny, but let me zoom in a bit, you will observe. So it's a matrix of, starting from 0 till 28. If you start from 0 to 27, how many rows, guys? Come on. This much array everybody has studied, 28 rows. And similarly, guys, if you observe 28, although I'm not able to show the whole picture, right? But if you guys focus here, you will realize that in each cell, there are zeros and there are numbers, right? And generally, this is 0 to 255 digits. 255. So if you do the pixelated, right, it will go from 0 to 255, as you can see here. So as you go higher and higher, the darker color will come. It can be black and white, depends on your setting, right? So generally it's a digit, right? It will be black and white, right? But there are also shades in black and white, grayish, dark, light, right? There are a lot of colors. But if you try to shade it, right, this particular pattern, can you see wherever the numbers, if you try to shade it, right, and where it is, so if you try to do it, you will see some edges are coming out. If you are able to pay attention, I know it is little tricky because you see that, so you will see that there is a pattern is forming, right? And if you are able to understand the pattern, right, it is hinting like a S, because since I'm trying to do it, but if you go little clearly, right, guys, cool. So this is what this image is telling you, okay? So now, although you can see here, wherever it is 0, it is dark black, right, in this particular pattern, right? So wherever it is 0, right, it is a dark black. So I'll tell you, if I make this image a tiny image, because I have this power to do it, you will see that now you will thank me. You will get the goosebumps. Why you'll get the goosebumps, guys? Because now you can see there is a pattern, very clear pattern coming out. Are you feeling it? Nobody will tell you this. Let me tell you very promptly here. So now I'm going to add a pen. It seems that I've already taken all the pens in the world. So I need to make this guy a bigger guy. Hold on. Right? So it seems that I start, now I'm going to become MF Hussain. Don't kill me for this. Okay? But you will realize, right? You'll realize that obviously the colors are not going to be all same. You know what I mean by that? So whenever the digits are like, 0 means black. This is very clear. 0 means black. So you don't need to hesitate. So all these zeros are there. I already know that. So I'll do it. Why I'm doing this much of effort? To make you feel something intuitively. Obviously, I'll code, I'll show in the hands-on, but feeling is very important, guys. Okay? which people don't do this, which I pity them. There are two different colors here. It seems so. I don't want to have different colors. You will start missing the pattern, right? You will realize that you have to be very careful to do this pattern thing. So you realize that this pattern somehow will turn to what? Observe this, and there will be slight color coming on the border as well, right? Little colors here. So if you try to see the pattern, this is what it resembles to, right? Obviously, I'm not the champion of it, but what I'm trying to say, it definitely looks like a number S. Are you guys feeling it or not? Come on. Letter S. So if you try to fill it, if I try to fill it, you will realize that, yeah, you're right, Akash. You'll say that yourself. So see, if I start feeling the pattern, since that is looking like a digits, right? You're not getting it. But if I start filling it up, there'll be some corners cutting out, right? Because this is how it is, right? So you realize that, yeah, it is coming out like a pattern. Hold on. And guys, since this is not the full image, by the way. This is not the full image because you remember you had that missing data on 19 was here, right? So you will be seeing that there will be some zeros coming, and trust me, it will be there. So some zeros will be coming where? On this side. So it will be black. That's why I'm making it black from my side. Guys, okay, observe. So I know it doesn't look like that, oh, this is number 5. It looks very ugly. But if I try to give you the character here, does it look like 5? See, I'm fitting something in between, right? And I have the image also. Don't worry about it. So I've already populated it today. I should have it somewhere in the model. Although it is done differently, guys. Why? Because I plotted the black, but you observe they are very close. Are you feeling it, guys? I have swapped the color in the printing, so don't kill me for that. But are you feeling it? Right? Just the complementary. But are you feeling a similar kind of behavior I was trying to draw? Since our image stops at 19, you're not able to visualize it fully. Okay, makes sense? Good. You can say that, guys. Did you understand the nuance here, right? So how do we get it? So the whole idea of identifying any image, it works on 2-3 things. Basically, there are 2 words always you have to keep in mind, and that is what? Edges and patterns. So the question is very simple question. How do we identify any image? That's the question, guys. Answer is pretty simple. Don't think about any neural network. Think about any image you see on the page, right? So for example, if I show you this image of cat or a dog, right? You try to identify what? How do you say that it is a cat or a dog? You look at the eyes, you look at the nose, you look at the lips, right? If it's a cat, you will also look at the overall body, right? Understand the design and the pattern, right? So basically, it's all about how do you identify it? Very simple. Depending on the edges, that's the first word. Depending on the edges, okay? Patterns, texture, shape, etc. There are a lot of things you actually look at. Images are unique in nature. Trust me on that. Okay. So these are some very straightforward attributes, guys, right? These are your edges, patterns, texture, color, a lot of things are there. But in Digit, color doesn't matter. Depends on the images, right? So generally, color has not a big role here. So if I am writing 9 with a black or with a blue, end of the day, it is 9 only, no? It doesn't change, okay? So colors don't play a big role. The kind of algorithm we are going to do, it's all same. That's right. But edges and pattern makes a lot of things. So you might be thinking, what do you mean by edges, right? So if you see, observe this image which I put here, right? Or maybe I'll show you my favorite image, which is sequence of 3s, right? If you observe 3, you will realize that it has a pattern, you like it or not. And it has also edges. So what are the edges? If I have to show you guys, it's very simple. If you want to see the edges, see, you know that in 3, this is something you will always find. Doesn't matter how they have written. Guys, agree or no? So edges is like outer side, right? Pattern is like this. So if I show you the border is like edges, so this is an edge, right? But overall, when I combine things together, it becomes a pattern. Do you see the pattern in three, guys? So basically, I put it nicely. It will look like this, this, an opposite of sigma, right? So know that people will try to write three, and even kids learn to write three like this, right? So different people write threes differently, number three differently, but they follow a simple pattern. Nobody writes three like this, right? Come on, guys. Agree or not? Similarly, for nine, if I talk about nine, right, you will realize that nine also has a pattern. See, what is the pattern in nine? Basically, you will see a loop without fail. You will see a loop. So it can be like this, it can be like this. What rotation? Not a problem, but you see we loop like this and simple this, right? This is how our nine looks like. Okay, you do whatever you want to do. So there are patterns, right? If someone says eight, eight is having a pattern. So whenever there are two loops, it's an eight. It can be like this, 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 but there is a pattern. Okay. So what just like our brain tries to process this information of edges, pattern, shape, sizes, texture, color, right? They recognize it, right? That's why you're able to quickly recognize. Look at that. If I ask you, even somebody has written one like this, but you know that what he has written, guys. Come on. You know that it's one. There's nothing else looks like similar to it, right? Guys, what is this digit? Come on, you tell me. One only, na? Although nobody writes one like this, huh? Very few people would do it. Everybody writes one like this, okay, or this. But yeah, this is very clear. Yeah, why not? People write that. Some will like write one, two, okay. So slanting line come in any direction. Now, guys, let's talk about the detailed idea of neural network structure, right? So I'll again, because I think I had just shown you guys that structure. So let's talk about a little bit more in on this. The same structure I'm going to talk about. Okay. So there are, if you observe, there are three layers in terms of difference, right? One is input layer, one is hidden layer, but hidden layer can be a lot in number. See, 1, 2, 3. And then the finally is you get output layer, right? So what happens, you're trying to do things, right? The input will go through input layer to the next, then next, and then next, and then finally it spits out. So let's also keep talking and write. So I think I did not explain each of these layers, right, guys? That's correct now. Before I jump to weights and biases, I did not give you any textbook definition, right? Okay. So what is input layer? Input layer is helps you to input the data features. Input the data features. So in this case, in our case of digit, pixel value or pixel values of an image. Now, if you were thinking about pixel values, but before we go there, a lot of people don't understand data feature. What do you mean by data features? Are input variables, predictors, whatever you name. So if you take our image, how many by how many we have? Why I'm drawing when I have it here. Okay, take this guy. How many by how many we have? Come on, tell me. See, if I take the example of our digit 3, 28 by 28, take this one. No? So take any of it, right? So take this guy. Huh? So there are 28 pixels here and 28 pixel here. Do a quick math, guys. Come on. So 28 into 28, how much it is? I know it even in sleep, 784. 784 are going to get connected to the first layer. Although don't go with this diagram, there are just 10 neurons, okay? But in reality, there will be 784 guys getting flattened and connected in terms of neurons, okay? So this becomes your number of neurons in the input layer. Number of input or features, basically neurons connecting to hidden layer. I'm talking about which use case, which I'll do it later. That is coming from your MNSIT data set. Okay. So to show you this, you will see this later in your course. Just focus on this. So when I'll do this, I'll show you this, that we are going to connect how many input to So if you look at that, how many layers are getting connected to it? It is next connected to 784. Neurons are getting connected to, how many are those? 784 connected to how many? 128. Clear? In this particular example, which I'll do it in the hands-on. Okay. This is, I have assumed that in this input layer, in my hands-on, in this input layer, there are 28 by 28. So if you do the math, it becomes 784. And this is my first hidden layer. I'm saying that I'll keep how many neurons? Come on. I'm saying that I'll keep 128. Okay. Right? So it's a matrix. Listen to me, guys. It's a matrix of order what? 128 by 128, right? So basically, if I flatten this, it's a matrix, right? Of 128 by 128, which basically means, sorry, what I'm saying, 28 by 28, which basically means that there are 28 rows and 28 columns. So what is this array, my dear? This array is what array? It is a 2D array. If it is a 2D array and I want to convert into an 1D array, right? How will I do it? What is the concept, array concept? You know it. You can read about it in case you are not aware of it. And the function is, right, array flatten, right? Which is np dot flatten, if I recall correctly. So that's what I mean by that, right? That's how you come like a more like a one line. Okay. Now the question can be like, why 28, right? Why 128 in the next layer? Who is telling you this? These are all questions you should ask when you already know about what is the neural network and all, right? Understand now my feelings? It's like suddenly why sun is moving around, why we are flattening it. You should ask what is the meaning of flattening. But let me tell the structure. Let me tell the structure first. Because if I don't tell you, you'll always be confused, right? Perfect. Okay, input layer, I think I'm done. One thing you need to understand that once you have the, pixelated view of it, right, you will realize that images has a lot of things. So let's talk about pixels. What do you mean by pixel? Because this is something I'll keep using. What do you mean by pixel? Let me ask some baby question. Now, this is a question to debate. Huh? What do you mean by pixel? And how is it related to image? Related to camera and camera size. So camera to, right, it is resolution of your camera, right? How does it relate to your image size? Let's see how good are you. Everybody will open their computer. You know how to see the resolution of your computer? Because I don't know. What is the resolution of your computer? Yes. So my display is saying my resolution is this 1920 by 1080. What do you mean by that? So if you do a matrix formation, 1920 rows by 1080 columns. Okay. So that's how it looks like. So every image of mine will have how many cells, guys? You know that, right? 1920, 1080. So total how many? Look at my image size. 1920 into 1080 equal. So if you're good with this, you know that it will be what? If I do a simple maths, it is how many pixels? 2 megapixels. Yes, come on, yes or no? You know that? Approximately, my dear. Approximately. Why? Because see, it is 10 to the power 6. Right? Agree? So don't think your resolution is bigger than 2 megapixels. There's a reason for it. Let's not go there. Okay. So just imagine those who are using, so let's say our phone has a 12 megapixel. So 12 means what? 12 into 10 to the power 6. Right? Megapixel means this is only, no? So you can think like that, more like 4 by 3. So 4 million here, 4,000 by 3,000, right? Then you will get, approximately I'm saying, making a grid out of it, guys. Come on. Which is a lot. How many these are? 4,000 by 3,000, right? Just imagine that the number of neurons you will see here, you're just looking at 784 in this example. Here you're coming in millions of neurons. So what is a pixel? Pixel is, by the way, what is the full form of pixel? Pixel means picture element. So let me give a pointer here. It means picture element, pixel. So if you bifurcate pixel, pix, L. Pix means pix, right? Image. So L is what? Your element, and pix is your picture. So it's a picture element, right? Which is the smallest unit. So those who wrote smallest unit, they are 100% right, which is the smallest unit of a digital image or display. It doesn't need to be an image, it can be a display also. Okay. Now, question comes that how it is related to the image size, right? So just imagine image size is definitely they are measured in pixels only, right? If you observe. So you might have heard about pixels per inches, or when you're doing the fax. So there you say, right? DPM or printing. DPM, you know what? DPI, sorry. DPI, you guys know in fax or in scanning, dots per inch. Yes. So generally, if you take a 4:3 image or 8:7, right, dots per inch. So there are different types of printer. That's how you define the quality of the image there, right? So I'll not go there, but you know that in terms of this is about your printing. But if you do a similar kind of analysis here, it is called PPI. What is PPI? Pixel density or pixel per inch, right? So if you talk about pixels per inch, so what is the interpretation of it? If you take an image, right? If you take an image more like as a unit dimension, if it is an inch of, all right. So generally an inch is a very small unit. How many pixels you are putting there, right? So higher the PPI, you tell me, higher the PPI implies more details and sharpness of the image. Basically, you talk in terms of good image, qualitative image, more details and sharpness in the image. Okay, that's what you mean by that. Basically, you say you have a better resolution of the image, right? And if your image is better, generally your image size will be also higher. Agree or not? Come on. So if I talk about a 12 megapixel camera, I'll not go to our school days when I used to use 1.3 megapixel camera. So 12 megapixel camera, right? If I just say, listen to me, the same thing I'll call it here, guys. It is 4,000 pixels here and 3,000 pixels here, right? So that's the reason it is called 12 megapixel. You must have been, so don't be now uneducated, right? So now since you are sitting in my class, you should be aware of these things. So 12 megapixel camera releases every time, right? 12 million pixels for each images. Now, if I give you a simple example that if your image is like, a simple image of, let's say 10, 6-inch wide, and let's say it's a portrait one and 10-inch height. Okay. So generally, if you see these kind of standard photo size, right, how it is being framed, understand this. If I go with a standard 300 PPI, which basically means 300 pixels per inch. Remember that, guys? Come on. Listen to me, and this is very important. Doing ChatGPT will not help, right? For a 12 megapixel, what is the image size in inches it will come? Let's say this is A and this is B. What is the length of A and what is the B? What is the image size you'll get it if I go with this assumption? Let us assume the pixels per inch is 300. If I say 400 pixel, sorry, 4,000 pixels and 1 inch, you're putting how many? 300 pixels, right? So basically, it's very easy. It's not a rocket science. So you can do this math, 4,000 by 300. How much it is? 13.33. So this is your 13.33 and this will be what? 10. So it's not 14, it's 13.33. And this is going to be 10 inch, right? So if you get this PPI and divide it, you should get an image, and that is an image which will not be, it will not get stretched or anything, right? It's a natural fit for it. But you know that image can be scaled, it can be, stretched. Sometimes people say, right, image is looking all, blurred, or image is not looking as sharp as it should be. Okay. बोलते हैं ना अपन image फट गया है, right? That's the word. Image doesn't look nice because you have overstretched in a very bad manner, right? Image looks stretched. So this is the image size you should get. Make sense? Clear? Now, why I'm telling you this? Because we are going to discuss with image, right? So if you see, this is not a image is not something, you can escape. You have to be aware of pixel. You should be knowing about what you mean by a 12 megapixel camera will spit it out. And I'm just talking about a simple idea here. If you have a 12 megapixel camera and you know that the pixels are designed in this manner, 4,000 pixels on the rows and 3,000 in the columns, right? Now you know that every inch takes how much? So if you take, so see, it's a 2D image, right? So you have both the directions, right? A and B. Don't miss that. It's a 2D image. So you have to do it separately. So every inch takes 300 pixels. What do you mean by 300 ppi part? Tell me. Pixels per inch. So 1 inch will have how many pixels? Come on. 300 pixels. Now on the rows, if you see, buddy, how many pixels are there? Already 400. So this will be aptly fit on what size of the image. So I just divided by 400 by 4000 by 300. It gives me 13.33 inch. So if you take an image and just go and put it on a this much of the image of paper size of the camera. Sorry, suppose you want to get the print out of this image, whatever you have clicked, and you do this paper size, your image will come 100% perfectly fit. No scaling is done, right? Correct. But if I take the same image and I put it on a big poster like this, what will happen? Come on. First of all, look at that. Our image is more like a portrait one, slightly. I'm putting into this format. What is this format? Landscape. Let's say I'm putting it into 24 inch by 20 inch. Now what will happen? So what will happen, since your pixels are not that rich, you need a better, bigger camera. That's why the DSLR comes into the picture again. Make sense? So it will look distorted, right? And let me show you. I'm trying to find the, not distorted is not the right word. I would say stretched. So I'm not able to find the right word for it, but you can do it. Okay. It's not going to be a fit, a proper fit. Okay. So for example, I have an image which I can show you, which looks like stretched. Okay. But you will realize what I mean by that. Or maybe I can take an image and make you show you here, guys. Okay. Why I'm thinking too much about it. Okay. So hold on. Let me take a kid image. Suppose I take this image. Guys, please pay attention. You will realize, right? This is a very simple image, guys. Come on. Now, if I start making stretching like this, can you see this? This is what I'm telling. So it's not blurry, to be honest. The right word is stretched, but you can find some technical word for it. But I know it's not blurry, it's stretched. But if you get a right fit for this image, the right fit was this one. Huh? Observe this. So this is the right fit. That's why people always tell you, right, in corporate, that always do in the aspect ratio, right? Don't try to stretch in the by one. Always do diagonally. Diagonally is still better. But if you keep increasing it, then the quality of image is gone. Can you see that? This is called pixelated. So when you print it, it will look like image fat gaya. That's another word. So means it will be more pixelated. Your face will not look that better. So image size and image resolution they go in hand by they go in hand by in hands and right. They go in hands. You can't have different things for the same thing. Make sense? This is all about image, but there's beyond it. If I change the same question by giving RGB, right, then you have to do it differently, but I'll not go in. Okay. RGB is like red, green, blue. So these are your channels for color, but I'll come back on that. So this is all related to this neural network I started. I talked about input layer. Let's move to the next layer. What is the next layer? That is called hidden layer. Hidden layer, generally trainers say it's a black box. I'm not the guy. Generally trainers say it's a black box because they don't want to get into. But I am going to do the postmortem. So hidden layer, it can be one and it can be multiple. Huh? So hidden layer, generally people say it's a black box. It is a black box. That's true. But at the same time, we will open it. It's going to be an overwhelming exercise, but I think if you ask me honestly, should I do it or not? We should do it here. Then what kind of deep learning scientists will become, right? We should do it. This is not that tough. Okay. So guys, hidden layer is known as intermediate layer. This is the intermediate layer. between input and output layers. So these layers are very important for us because these are the layers known to extract the features, which is intelligence, from your input data. Okay. So a lot of time people say, what is the deep learning? This is the main component of a deep learning. Hidden layers are called hidden because it is so deep to understand, because it goes on, it can have multiple layers, 5 layers, 10 layers, right? It tries to find the edges, patterns, texture sequentially from the images you have given. And that's where the calculation of weights and the biases happen, and they keep getting updated through an optimizer. Generally, the optimizer is going to be gradient descent algorithm flavors, right? So you keep updating the weights and the biases. That's what you have done in some of the machine learning algorithms. If not, I'll teach you. And that's the most important piece, or I'd say the heart of the deep learning thing, right? So let me write this line. These layers, when I say these layers means hidden layers, these hidden layers perform computation, extract the features from the input data. Okay. So these are the features which we are going to extract from the input data. And the deep learning term, let me write the deep learning term, if someone asks, what do you mean by deep learning? You can say deep learning term refers to the network with multiple hidden layers. So the whole point of deep learning is to have hidden layers, trust me. Deep, right? You have to go and get the depth. I'll also show you one baby example where I'll take no hidden layers, and that is called single layer perceptron, right? So it will just this connecting to the output, right? With one hidden layer, but that is not hidden layer. If it is hidden, then you have multiple in between, okay? That's what called depth. Tell me one thing, if I put two boxes, listen to me, and I want to give depth in between, then I need to increase the space, right? Think like that, top to bottom, right? So hidden means what? I'm trying to make you the word clear, deep learning. This deep is coming from multiple hidden layers. So you will put a lot of layers between. So you need some space, right? So you will make it bigger like this. And then you'll put a lot of layers. So that becomes deep if you observe. So you try to, jump from here, you jump, you will realize it is deep. Don't do this and blame on me. Huh? These guys, people are doing anything. Okay. It is just for understanding. Okay, clear? You got the concept of deep. The word deep, what do you mean by that? Pixel, you know, right, today? Pixel means picture element. Two terms you have learned. That shows your, experience when you go into the interview. So pixel is a picture element a lot of time. Deep means what? If I just have one layer of input, maybe one layer of hidden, and then one layer of output, what is deep? What is the depth here? Nothing new. It just gets connected and finally spits out. But if I say that I have one layer of input, and I need to put a lot of layers of hidden, then I need some space. So can you see that the depth increases? Try to feel that in physical sense, right? So that's what you mean by deep. Basically, you're trying to say you're making it more complicated and complex, adding more hidden number of layers. Obviously, every layer has some job to perform. There are a lot of existing deep learning architectures. You might have heard about Yellow, Resonate, right? A lot of CNNs ones, right? I'm talking about that. VZZ. So all those will make it more complicated, but that's in the future. Coming future, you will learn from me. But for the time, just focus on this. Okay. Now the final layer is what? Output layer. So output layer is your final layer, right? That is the layer that gets you the output. So suppose you are doing a digit classification problem. In the output layer, you need to find what? Whether this digit is what? Let's say suppose there are more and it comes 9. If this digit is coming as 3, then this neuron will get fired. It will, sparkle, right? White. And then the finally output will come like 3. Definitely when I do this, it looks like what, guys? Multi-class problem. Okay. And there are different types of activation function will come, but I am not getting into it yet. Right, Srini? Hold on. So output layer, what is this layer? It is the final layer, let me write, that produces the output of the network. Okay. Generally, if you're trying to do a binary classification, how many neurons you need? 1 neuron or 2 neurons. In single layer perceptron for binary classes, let me show you. And this is a jargon for you. So let me get the images. That is not your, classification problem. See this. This is very simple, which I am going to do the first thing coding. Binary means 2, right? And this is, I will teach the first basic neural network from the scratch. Single layer perceptron. This is for, binary output, right? It is 2 neurons. But if you think about it in detail, guys, if you think about it detail, right? It's not necessary that it has to be. It depends on how do you want to do it, right? Means I can still connect to one neuron and get the answer. Suppose, hold on, this is very tricky, and that's why I asked this question. It looks like I can put yes or no here, right? And whatever it goes. But if I say, if I take this guy and I say, no, I'll just connect to only one sort, something like this. Hold on. Don't worry about the image connections and all. If I just say that I'll put one neuron here, if it is getting fired, if it is on, I would say yes. If it is not getting fired off, I'll assume it is what, my dear? No. Guys, if I'm asking you, will you attend my class tomorrow, right? Who is going to attend tomorrow? Listen to me, the art of complementary theorem. You say yes, it means that those who have not said yes, can I agree that they are not going to attend? Art of complementary, right? Can I say that? Yes, to an extent it's correct, but someone can say, oh, I'll change my mind and all. I'm not assuming that if you're not saying yes, you're not going to come. With that assumption, it can still be connected to one neuron. So this is going to be redundant, right? Because one neuron, two neuron, right? You're not going to worry about too much. Because whether it is one neuron, two neuron, right? It is not going to matter much. But you know that minimum you need how many neurons? The right answer is one neuron in the output layer for binary classification. This is the minimum, but you can have 2. There is nothing more to stop. And I'll continue and write just below this. Multiple neurons in the output layer for what kind of? For multi-class classification. Here I'll use softmax, right? So these are some good jargons you might have been hearing about. Softmax, and I'll write here sigmoid. Sigmoid is used as an activation function for binary classification. Softmax is used for multi-class classification. Are we clear? So guys, neural network was developed by Mr. Warren McCulloch. So let me write. You should know the name. Warren, not Warren Buffett. Warren McCulloch. And there was one more guy, Walter Pitts. Walter Pitts. Correct the names if I do mistake. 1943, can you believe it? So a lot of people think neural network came in 2000. No, it came long back. It was an idea which was proposed long back. Don't think that. So this was proposed for the first time in 1943, before our independence. So these are the guys for the very first time proposed the mathematical model for neural network. Okay. So let me show you quickly. Suppose if I try to find the digit 9, guys, can you see this? Now there was a question that why does it comes like 784? Because you have to put every input layer in 1D array. That's the constraint. Someone asked me, right, why do you want to get into 784 like a flattened thing? Because this is the requirement that if you want to do a input layer, what is input layer, guys? I think you know, right? This is your input layer. Let me write very clearly. This is what, my dear? Output layer. Okay. And these guys are what? Hidden layers. Now the question can be why it is being connected to 128 or 5 or 10. Don't worry about it yet. Okay, please don't do it. Because then you will miss the fun. I'll tell you everything. What is the standard? So this is your black box, although everything is black here, it's a black background. And the credit goes to the guys who have prepared this nice images. It's very tough. So if you're trying to do what happens now, guys, you will try to extract the edges, patterns from input to the hidden layer, then it will fine tune in the next layer. And then finally, it will fire the right output neuron. So basically what I'm saying at a very high level, 10,000 feet, the moment you give the numbers, remember those numbers 0, 0, 2, 3, 250, right? Those numbers, it will come, right? So basically, higher the number, higher the neuron firing, right? So in this case, generally, when you say 0 to 225, what we do as the very first step, we normalize it. So what do you mean by normalization? So that we scale it properly. So you take each and every 784 values and divide by 255, it gets squeezed into 0 to 1. So basically, all these value will become 0 to 1. And if it is 0, it will be not firing, means it will look like black. And if it is 1, it will fire like angel white. So basically, if you take the input, it will get fired. And I'll show you in my nice images, it will be white. Some of these guys will be white. Not everything will be white. And then some of these guys will get white, depends on the pattern. Are you feeling, guys? Then finally it will be white. Not everything will be white. And there will be different shades of color, light white, more black, gray, dot black, dot white, right? And finally it will say, I am here, buddy. It identifies the input image as what, my dear? As digit 9. So colors are going to be in the gradient, and there are only two colors, the shades of black to grayish. Hold on. So there will be grayish also, and then finally becomes white. So let me show you the patch. Because in PowerPoint we have it, the gradients, gradient image of black to white. So if you are trying to see this image, I know you're not able to see the white because white is white, but it is here. Let me show you. Can you see that? Let me write in English, this is white. There will be more, depends on the range. So generally what I'm saying, if it is 0, it will be dot black, and it is white, means it go from white. Since the image in wrong direction, I can't do it. Okay. This will be the heart of it, so nothing to worry about it, even if you have missed it here. So this is how you put images in pixel forms, right? So generally when you do, shades, so it will come like this. 0 means black, 255 means white in our case, but it can be other way around also. So a lot of time people use 255 as the black and 0 as the white, depends on your setting. But this is how you get the different values to the different shades of the color. So basically 256 shades you are going to see, not only this much, by the way. So 256 shades, which will be very close. So basically 250 will be closer to 252 and 256. 0 will be closer to what? 25, 246, right? Guys, agree or not? In terms of color shading, just focus on this part. Okay. So this is related to pixel. So we saw those number, right? 0 to 255. Basically, that's a range in pixel. It's a range, right? 0 to 255. So basically, total how many it is? Total it is 256 values, isn't it? So generally, this is the most digital images will have this kind of format. So most digital images like what? JPEG, or you have heard PNG, right? Must have seen those image format, right? So JPEG, PNG, okay? So each pixel is going to have certain value to it, right? So if you saw that screenshot of mine, right? Listen to me. I was showing that, no? See. So this is like what? 256. In the values of 256, you find for each pixel. So if I pick any one number, my dear, please focus. Can you see there is a value we are tagging to it? 238. This is one pixel, by the way. So total 28 by 28, how many pixels? 784 pixels. In that, there is a value associated with each pixel, which is coming from the image breakdown. Now, what is the meaning of this 250, 253, 256, 100, right? Blah, blah, blah. So the meaning is, I'm writing here, the meaning is very simple. If you take any pixel and you give a value, right? 0 represents, as per the notation, but sometimes people reverse it, but 0 represents black. That is as per the notation. You can't change it. And I think I mentioned that also. And 255 represents what? White. Now I'm telling you guys that black will not be just black, right? It will be black, then light black, then it will go to the different shades. So total, how many shades are there? 256 shades of what? Black to white. Agree? And later I'll show you a lot of images showing this one. Make sense? So in this 127 value represents what? It's the middle value, guys. It represents medium gray, by the way. Just fun fact. And 256 represents already awakened. Sorry. Similarly, in the color images, you have a different set. But again, similar to this concept, but I'll not go there for now. Okay. So now I'm going to show you and you feel the beauty behind it, because the kind of stuff I'm going to show you, you will love it. Okay. So I was showing you this, that how does it understands, right? So to understand anything, right, the network needs to find the three things. It starts with an image, which is getting into pixelated form. Listen to me, guys. I'll also write. So the moment you give an input image to this network, when I say network means neural network, in the input you give the pixels. Pixels have values, and values are acting as activation. Then activation goes on to the next layer, and the next layer it activates, just like neurons does. So just like neurons do. If you remember that example of pain, right? The moment someone is pinching on your arm or stabbing your arm with a knife, these days it's happening a lot. You have to be careful. So then your brain quickly understands that you are getting stabbed, isn't it, guys? But you know what? The masses, it's not like, your neurons start traveling like a blood. No, no, no. So if this is your neuron, right? It doesn't start, like a Ferrari race and move to your brain. No. It fires another, it transmits the signal, then it activates another set of neurons, right? And not every neuron gets right. Why might this? Okay, let me tell you a very simple thing. Take your right hand, right, and try to pinch, right? You will feel the pain in the right hand. Do you feel the pain in the right leg? I'm trying to make a very rational analogy here, right? There are so many neurons. Do you think everybody will get fired equally? Some they will not even get fired. You agree or not? Come on. So even in your body, when you're trying to pinch, so similarity is there. Understand? If you try to pinch on your arm, does it pain or does the pain occur in your leg, right leg? No, only the right arm. Why? And even right arm, that special area, right? Suppose I pinch on my arm at a point, only that gets activated. And then the brain is getting the signal that this localized pinching is happening. You don't feel the pain anywhere else, right? Come on. Similarly, if I want to detect whether a number is 0, 1, 2, 3, or 4, 5, 6, 7, 9, it has different edges, patterns, and it identifies that through series of computation and only fire the ones which are required for it, right? Looking at the input image, okay? So let me show you this. This is how it looks like. Now you might be thinking, and if you're observing, guys, right, whenever you are trying to give, let's say I give a different type of thing. This is my image, right? It looks like a part of 4. It looks like a part of 9. Can you observe, guys? That's why the model is confused, right? I'm showing the confused behavior. So when you give an image like this, which is having a pattern, something like this, right? So you know that what it will do, it will try to find the, and if you observe, there are 784 input. Let me also write. So it is 28 by 28 pixels, which actually becomes 784 pixels in the input, right? Focus. Okay. Then it gets into the next one. What is this one? If you count on the finger, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I'm not keeping 128. It is 16 neurons. Don't get carried away. Huh? That 128, I took it from the hands-on. Then another 16 neurons in the next hidden layer, if you see, right? And then finally, how many? 10 neurons, right? We need 10 neurons for output, right? 0 to 9. 0 to 9 is 10. Are we clear, guys? So if you observe, you are doing a math of how many combinations? 784 into 16 into 16 into 10. It looks very easy, but I'll explain the maths behind it, how many weights and the biases will come when I come there. But what happens, this is the image, what will happen? The network will think whether it is a 4 or a 9, right? So you can clearly observe that looking at the output, right? It is firing some neurons here, there. Can you observe, guys? Let me highlight in case you're missing. So this is bright white. So that 0 to 255, right? Remember, I had done the normalization and this 0 to 255 is squeezed between 0 to 1. Remember that. Okay. So after normalization, so you can clearly see that if it is this, means it is white. It is perfectly white, means I know it's not easy to see here. I'll use some white color, right? Yeah. So this is white, but you also see some of the neurons are not getting fired in the hidden layer. Just observe. So these are like dark, means black, right, guys? Can you see that? Some grayish is also getting fired. So now we will realize that all these different shades have some values, right? So if I have to show you, and then you will feel the beauty of it in a moment. But ideally, it is what all these digits have some activation values, right? Even in the hidden layer, by the way. So generally, this is what we show, right? Although just this is for the sake of understanding, right? So let's see if I do this. This is my more like what, my dear? Activation scale. 0 means what? Can you see in the diagram? 0 means dark black. And 1 means white. And then there are different shades of it. You can clearly observe, looking at this, that as you go from 0 to 1, it turns white. It goes from black to white, right, guys? Black to white. Okay. So some of the neurons will get fired, and that's what you're saying, right? Neurons are getting fired or neurons are getting activated. It's the same thing. Okay. Some of them will get. So what do you mean by activated? So activation happens at the cost of input first. So you get the input, then the activation happens. I'll come to there. But at least on this image, can I write, guys, that here, can I say that the neural network, I'll write NN, neural network, is struggling, so that it is in the notes, struggling to decide whether the input image is 4 or a 9. Because if you do 9, it looks like this. If you do 4, it looks like this, right? But you might be thinking, how does it work? Means what is it doing? How those activations are being done? What is the calculation behind it, right? That's the whole topic for the day. So to get you the intuitive understanding, I'm getting into the heart of it. So now I'm digging it further, guys, as promised. So more in intuitive understanding, going one layer deep. So now understand, guys, how does training happens? How does those calculation happen? So the subtopic within this is how does the training work in neural network? How do you understand what is the digit is going? How does learning happens? So if you observe this diagram, you will understand what I'm saying. There's some really nice diagram put by some really good guys. Okay. If you observe, my dear, here, you will see that for 3 digits, why I've taken 3 digits, there is a reason for it. Can you see that there are some commonalities? And if you're paying attention, you'll know. 0, can you see this? 9 has a loop here, observe. 8 also has a loop here, observe. But if you break 9, you have 2 things, this, and then you have a stick, observe this. This stick can be also be here, right? Length, don't worry. Look at the edges. So you're picking the edges, right? These are all your edges. Let me write so that you don't miss. You're picking the edges, right? You're picking the edges. Edges make the pattern, and pattern makes the digit. So edges to pattern, and pattern gives you the digit. Now, if you observe, you have 8. 8 has, so you can say that this is this image. I don't know why I killed it. And this is this. Observe this. Then you have this big stick, and then you have this long stick. See. Okay. And then you also have this different one. Right? Maybe make the same color. Are you with me, guys? So are you able to break every digit into some edges? So what I'm telling you here, every digit has some edges which neural network identify. I'm writing why, because so that you don't miss on it. Clear? Now, if you try to understand, let's go back to our thing, 9. Again, because 9 is something I want to make you understand. So you know that it will go in sequence, right? So if you want to find 9 and let it identify, you realize that in the next layer, which is hidden layer, second hidden layer, let me write so that you don't miss it. So this is hidden layer 1. This is hidden layer 2. Now there are 16 neurons here, 16 here, 10 here, and 784 here. Don't miss on that. Neurons are connected to some lines, right? Those are known as weights. I'll come to that. But understand that if you even focus on one of the neurons, right? It is being connected to 784 combination. That's why it's called fully connected layer, right? So you're connecting to everything, right? All the inputs. Basis that, what it does, it tries to give you those shades of different color, and it activates the neuron in the first hidden layer, which eventually activates some neurons in the next layer. So what it does, it sees that, hey, hello, there is a loop. Come on, focus on this, guys. So suddenly you know that this particular neuron tags to this loop. So it gets bright white. Come on, understand this. I'm making it very simplified for your understanding, but are you able to follow, guys? If you focus on the box, let me zoom in a bit so that you can see that. Okay, everyone, can you see that? So you know that 9 has a pattern. What is the pattern? This is the pattern. There is a loop. You know that loop is going to come here. So you see this neuron gets activated. Bingo. Are we clear? Then you also see that there is another pattern, and that comes the stick, right? The vertical stick. And you see the vertical stick is tagged to this particular guy. So it says, hey, hello, I'll glow now. Let me glow. So he says, okay, I'll glow. So this is getting activated. Are you feeling the beauty, guys, at a zoom level? Now, you know that if I'm going to do this, then output layer is going to get combined, right? So everything is connected to everybody, but you know that this will combinedly, right, go and form a pattern. And pattern forms a digit. So you will say, I'll take this, and then I'll take this. I'm just showing you the beauty here, guys. And then you know that if I combine these edges, it becomes a pattern, and pattern matches what digit? 9. So then, since it is all connected to everybody, is connected to everybody, but finally identifies it digit as 9, right? Are you getting the goosebumps or not? See, let me tell you, obviously I have not done these images, but I have gone through all this, structure to understand it. Okay, so that I can explain you. Are you feeling it or not? It depends on your exposure, but okay. Why can't it be 6? You need to understand that 6 is what? Let me show you the pattern. 6 is like this, right? If you observe, first of all, there is a big difference between this loop and this loop. You understand? Look at the directions also. Huh? If you put it here, it's a very different thing. So I understand your point. It can be 6, but it also looks at whether it is like this loop or this loop. Rotation is also considered in this. That's why I need a lot of neurons. So it will identify differently. Now, if you understand this, guys, then you have to also think about one important aspect of when the moment the digit comes, right? Remember I showed you the 9, it looks like this. So that image, if I blown it up, remember I showed you 3, 6, 5, whatever digit. This is how it looks like in the pixelated manner, guys. Can you see this? Now, in the grid of 28 by 28, if you observe this, right, there are 28 in the columns, 28 in the rows. You can clearly see wherever there is a matching edges and patterns to number 3, it gets white. I'm just trying to show you this part of the image. So what happens when you put it into an array of like 784 pixels, right? Most of them are black, means 0. Only few of them are like 1 and closer to 1. Like if I zoom in, you will see that 0.7, 0.9, depends on the color and the value, right? That's what in the zoom in version they are showing you. But you can clearly identify the edges. Like suppose someone says, this is the edge. If you observe, this is the edge, right? To get this edge, no, this is not the output of the ReLU, okay? So if you observe, guys, this pattern is being captured very nicely here. Observe this. Sorry, not pattern, my bad, edges. So in 3, you have edges. I'm trying to show you that how does it detect edges, because you can clearly see that you have one in this diagonal, guys. Can you see that? Right? So this will come as like a edge, right? Similarly, we'll see that there is like a edge like this. There is another edge like this. Can you see that? There's another like a loop like this. So it identifies the different into bits and pieces. And when you put those bits and pieces like this, you realize that, oh, it comes like a three. Are you getting or not? I'm just trying to show you this. Okay. If you observe this, isn't it? This is what I talked. I took I took a number 9. Observe this, guys. I took a number 9, which is basically I'm talking about this guy. Then pixel becomes edges. What are the edges you found, right? Now I was showing as like a one loop, huh? But it can be possible that they are dividing into small components. Can you observe this multicolor thing? So all these can be small edges. Observe this. Then it gets into what? Edges become shapes. So small edges is making a one loop, right? Shapes become a pattern is there, right? This is a pattern, this is a pattern. So basically when I say shapes, it becomes your patterns in my language, and patterns gives you what, my dear? Digits. So the important learning or takeaway from here that in any image in the world or in the whole course, of deep learning, the complete course is about detecting, let me write, detecting edges and patterns and forming patterns to help us with the image recognition task. Who does it? Neural network does it. I don't do it. They are helping us now to do the image recognition task. So detecting edges and forming patterns. Obviously, edges will form the shape, which is basically I'm saying patterns. Forming patterns to help us with the image recognition task. So basically, edges becomes your patterns, pattern becomes your image, right? Now, if you observe this nice image, which I'm going to show you guys, okay? So I'm showing one image, guys. Can you identify it correctly? Come on. At least you know that it is Simba, lion, tiger, right? Your confusion, it's not a dog, right? So far, if you're not saying it's a dog, it's a lion. It's a lion. But when I show you this, how quickly you identify it, right? Okay, because you're looking at what? You're looking at the edges. See, these are the edges, right? Isn't it, guys? Come on. Are you feeling the beauty what I'm trying to show? Forget about everything. So this image was taken by Mr. Kevin Pluck. Okay. So I'm giving the credit to this guy. This is the image he took and then converted into, so we used the deep learning methods to get the Kevin Pluck. Now, if you compare these two images side by side, it looks like it's a negative of it, right, guys? Come on. So we applied the, edge detection thing, and you can see that it looks so nice. Guys, again, and those who are my peers and, those who are my peers older than me, they know that they must use Kodak camera with the flash, and they must have used negatives, handling the negatives carefully, going to the photo center and get those negatives developed for the pictures. Have you done it? Those who are Gen Z, they have no idea, but I have used Kodak 36 reels, right? When I was a kid. Okay. But are you feeling it, right? So the same principle what we do here, get back to here. Are you not doing the same principle to detect the edges of the digits? So on the same principle, you can detect anything, any image in the world, because you can find edges. Edges can help you understand the pattern or texture, right? Now I'm using the other words also, texture and the shape, right? Because if I just show you this part, it can look like a dog also to some, not because there is a big nose here, so you might not say dog, but golden retriever dogs have a similar kind of hair structure, right? So texture, structure, it helps you with a lot of details, right? Are you with me? So ideally what model does, model tries to dial these knobs. If you have seen the movie Imitation Game, if you have not seen a movie recommendation from your trainer, hardly I do it, but you must watch since you are studying deep learning with me. Imitation Game, right? If you watch this movie, you'll see this machine shown in that movie, right? It's a dummy one, but the story of Alan Turing. Alan Turing, he's the guy who single-handedly, right, defeated the Germans, right? They were in England and they developed this machine to decode. It was the first machine which became the inspiration for computers. So if you observe, so these are the knobs, right? Take these knobs and look at me. This is my creativity, copyright APC. I'm connecting these knobs as neurons here, right? So these neurons get fired accordingly what you give in the input and get you the output. So in the movie, they use the same principle, right? This position of the knobs were letting them know what is in the message. So they were it more like a decryptor, right? So whatever the encryption they were doing, they were breaking it using this machine in almost 2 minutes, right? And if you remember this movie, they needed some hint to initialize the machine so that it converges faster, which looks like our optimizer, right? So optimizer converges here and gets you the right values of these neurons, right? So that it gets fired and finally you realize that, oh, this is 9 or 6 or 7, right? Similarly, in the movie, if you observe, right, they use the word Hail Hitler as the initialization because they know that the first word in that document will be Hail Hitler. So they were able to set the few knobs in the machine. It starts with the right initiation and they were able to decrypt it faster. See, I'm not a computer science buff, so I'll stop my emotions here. Okay, are we clear, guys? Okay. So what it does, right, you can clearly see that it looks for the white patches. So forget about this small one. Let's focus on this part. So you know that this vertical or sorry horizontal stick is coming. Why? Because the values here, the model is able to understand this is all one. And if you see the proximity to it, right, is all getting almost black. So model understands the difference between these two and knows that where the edges come. Because you have the value tag to each and every digit shade, and that gives an input to the first layer and it understands that where is 1, where is 0, where is 0.8 because we are putting it into the model, right? So if you see this, the moment you run, right, it quickly identifies in the training that this digit, you can clearly see that this digit is what? This looks like 9, right? What it does, it tries to break into small components because of the neurons you have, right? So if you go to the structure, there are a lot of neurons, right? And it identifies it in the first layer itself here. So it activates it. We have the values, these values. Then it helps to find that, what are the possible edges it can detect looking at these values. So you can clearly see that when you are looking at the values, not everybody is white, right? But still it is being picked. This is your edge, by the way. This whole thing is your edge. If you observe this, let me clean this because then you will know. This whole thing they are considering at edge. What is not going to be in the edge is this part of the chart, right? Because they know that it is 0, but they understand that this is 1. So they'll give more white color, less color, and they know that. Okay. So that's how it works. The working is very simple. It will pick those edges and tell you. Okay. If I convert this image, right? So you're basically what you're doing. You are going to increase it. You can make it like this, or you can make it like this. That's what it's saying, right? In terms of shape. But if you flatten it out, right? So what will happen? That it all will come, one after the other, because it will be the similar data points, right? But you need to also understand the patterns will also change, and you have to take a simple example to show you. So let me show you since we are discussing. This is a very good question. So suppose, let's say this is my image, right? Which is, 4 by 4. Okay. The total is 16. So I put some pattern here, right? So I put a value 8, 0, 2, 6, 5, 3, 2, 1, 2, 5, 8, 0. I'm just randomly taking. Now I will reshape into, let's say, so you need 16, right? So you can do like 2 by 8, correct? By 2. Let's do something. So you can have, now, if you follow the pattern, right? So it doesn't matter, your image is getting like 2 is getting like this, or you stretch it like this. So there's a different concept. But I think as of now, if you do this, you fill it like sequentially, then there's no problem. You observe how I'm filling it. I have to go a little more down. It's sequentially, right? So now if you flatten it, it will be same. But if you fill it differently, for example, if I fill it, so 8, 0, some randomly I do like 8, 5, 1, 0, 6, 2, like this. So the pattern will go and shift. But if you fill the sequence and the sequence is not disturbed, your pattern will not change. The moment your pattern change, let's say you have changed the pattern intentionally, but in training, you're not going to give only one tree now. You'll also have different trees, right? So it will quickly identify this is a different pattern, and the model might give you a wrong answer, or it will, if you have an option that not sure, it will go there because it will not find any matching there. So training, that's the reason training is not something you will do it. But if you keep training, let's say I say, and I'll make your problem more interesting. Suppose you do this a lot of, you have, 1,000 data points. For 1,000, you have like, it's not imbalanced. You have 700, this pattern. Then, although you're trying to detect 6, but this pattern will become more obvious if there is no neuron which you're matching to it. Still you will find that this neuron is getting fired and tagged to one of it because the model will decide on its own. Don't think we are going and telling that in neural network that you have to detect 0 to 9. It's not like that. We know the problem, right? But if you give a different pattern, right? So you saw in my example, this example, it was showing both 4 and 9, right? So it will show similar like that. It will show a wrong thing. But if you have more data points similar to this pattern, when I say the pattern, the shape and size, it will start showing that more profound, in a more profound manner. But it's just one or off business, or one of it, it will not be able to, because even the number of data points will have the weights on learning, right? It's not like just one example you give off, then the whole model is going to auto. It's not like that Lego game. You plug out one marble, the whole structure falls down. It doesn't work like this. It can tolerate one. It will take it as a noise, to be precise, in machine learning language. Okay. So if you observe, right? So if you take any color which is like shade of black and white, observe this, guys. It will go from 0 to 255. Since RGB has 3 channels, okay, like he's saying. So if you take any of the color, right? So you'll get a hex code and you will get a value, right, between 255, 0 to 255 for all the 3 channels. So there are 3 channels, right? RGB. So you can make any color using RGB. I hope you understand that, right? So that's why these are the 3 channels. You can pick it up. But since we have not done any color images, you're not able to visualize that. But everything in color is always in the range of 0 to 255. Okay. How information passes between the layers. So, and this is something I'll show you with a lot of images so that you don't miss it. So on the similar structure, suppose I want to pass an edge. This is an edge, guys. It is trying to find edge. That edge is mostly showing your letter, digit 3, not letter. So your input is same, nothing changes. You have this pixelated image, 28 into 28. Let's say this is the 3, right? So you are going to have the flattened one. And if you observe, everything is connected to a lot of neurons, right? But if you try to understand every neuron functionality, it's similar to one neuron functionality. So that's the reason that I have taken only one neuron. So this is my first hidden layer, and this is only one neuron we are trying to understand. If you understand one neuron behavior, no, you can get any neuron and functioning. So this is my first hidden layer. Observe, guys. Tell me one thing, when you will get this number 3, you will get those values of activations. Hello, yes or no? These values will come in the array. Also the zeros, a lot of zeros, a lot of these values will be there in the array. Okay. So basically I'm saying the data will look like this. Okay. I showed you, one image where the data came. Like this. So imagine that my first digit is 3, right? Or I think I'm using 3 here, it is 5. You will see that this is how 28 by 28, if you flatten it, you will see some zeros, you will see some ones, you will see some value between 0 and 1. This data has still 255 because this is before normalization, okay? I'll go very slow, don't worry. Now, if you observe, this, these values are going to be there. So these are known as what? Activation values, right? What it is known as, guys? Activation values, okay? Now, on one neuron will have all the activation values. So I'm going to call this, guys, as what? A1, listen to me, A1, A2 up to A784. Listen to me. So these values are known as activation values. Did we created it? No. It came as the property of the image. Clear? I did not create this. The moment you give a digit, right, it will have the activation values, right, in the pixelated form. What are these lines coming to you? These are known as weights. That's where the weights are getting introduced. So every line connected to the neuron, there's a line, right? This is your weights. So just remember in linear regression, you were doing this beta naught plus beta x1, beta 2x2, so on. In this case, it will be beta 784 x 784, because how many variables you have, my dear? Why I'm relating with linear regression? Because you are champion of linear regression. 784 variables, because you have 7 input variables, 784 input variables. And what are those, guys? Those are known as coefficient. Remember that? You have a lot of it. Can you believe it? It's such a big model. Everybody, are you guys with me? Then you might be thinking, who is this guy? This is known as, in our language, so guys, all these are known as weights. In this case, also known as weights. Even in linear regression, your trainer must have taught you. And this is known as bias. If not, I can do it. So this is how I'm introducing the weights and the bias. Now you might be thinking, what is weight? What is bias? Right? Yes or no? Thinking about it? So bias and weight is very simple. Suppose, listen to me, I'll give you a very simple linear regression equation. Y equal to 20 plus 100x1 plus 10x2. Now, which variable is going to have a lot of impact on the price of tomato, my favorite example? You will yourself say, Akash, it's x1. How did you say that, my dear? Because you looked at the weight, wasn't. In Hindi, we call this weight, right? So the weight is higher, the impact of this on y is higher. Agreed or not? Come on, guys. Even these variables are off, means 0, still you go and have a ready to set constant value. That even nothing is there, though still I'll charge 20 rupees. Hello, listen to me. Guys, that's what we call bias, right? In linear regression, this concept is called intercept also, right? Yes or no? A line which has some. So intercept is what? Something like this. You start from somewhere, right? You don't start from 0. So bias is saying that even if you don't have any impact, this is like a very good world. Your tomatoes are not going to get free. If you think in mathematical form, it takes the form of y equal to mx plus c. I'm talking about c. Come on, guys. Yes or no? So similarly, if you bring this concept and come to the neurons, right? Now, combinedly, these guys, A1 into W1, A2 into W2, will decide what is the going to be the value for this guy. Which guy? This neuron. Whether it will be a white neuron or it will be a gray neuron, God knows, right? Or it will be a black neuron, God knows. Are you getting my point? This will control. These are the knobs which will decide. And these will decide the next. And not again, not only one. All the guys will decide the next and the next. That's how it works. Are you feeling it? So if you are feeling it, let's not wait. The way I'm showing the images and to show you that how does this work, and thanks to the guys who have put together, but if you understand that these are the weights, guys, I mentioned just now, let me highlight it. The lines are the weights. You are seeing two colors here. If it is a blue color, it is going to be, if it is a blue color, and if it is a red color. If it is a blue color, guys, it will means positive. Red color will be what? Negative. Are you guys with me? Observe this, no? All the blues are the positive, all the less than is negative. So now the weights can be positive or negative. Now understand, if something is negative, the price will not increase, price will go down because of the impact is reversed. I'm again bringing the same example. Yes or no? Suddenly, if I make this negative, then the price will go down. Agree or not, guys? Come on, right? So similarly, these weights are going to be decided by the optimizer. I don't decide it. I'll just initialize the weight, but the optimizer in this case But the basic is what? Have you heard about this optimizer? So what it does, it takes the cost function or the loss function, gradient descent algorithm, GDA, a lot of versions of GDA, but the one which is very famous is known as ADAM. So this is a jargon for now, but don't worry. ADAM is one of the famous optimizer people use in deep learning. Gradient descent algorithm finally runs a lot of iteration to get you the final values of the weights. Isn't it linear regression also does the same thing? I showed you a very nice example where the weights are getting decided, and to show that, suppose this is my distribution. I'm taking some balls, they're infinite balls. Now tell me one thing, if I try to fit a line, this is my line, right? See, this is simple linear regression, guys. Suppose I try to get a line, right? So see, if I show the error, residuals is error, if you draw the perpendicular, if you draw the vertical lines to the line, this is the error. A lot of error is there. You might say that, Akash, and observe also this part of the chart. So if you observe this part of the chart, you will see that this value keeps changing. These are the coefficient. This is your weight and this is your bias. Let me also write bias and this is your weight in our example. Okay. If you observe, right, if I increase this, you have a lot of residuals and you will see the residuals coming like here. A lot of errors is there. Squared sum of residue. Remember that? A lot of look at the blue line. It is a huge line. If I try to go up slightly, see the line is getting shorter. Focus on the sum. Are you guys observing? So you're getting in the middle of the distribution. You're also changing this. Look at the weights and the bias. It's like dial is getting twisted and engine is trying to find it, which is the right fit, the best fit for this linear regression line. You are still having errors. You see that, is it the error I have to go ahead with because I can't do better than this? You're doing it intuitively, right, guys? Observe this. Let's say this is the best fit line. You get the weights as 0.56. You might have started like 0, 0, right? Or minus 10, but you sliced and diced this knob, right? And got the optimal one. Now, this is like intuitively you're doing, right? This is the best fit line. But this is what you have done intuitively. But what is the algorithm will give you? In one shot, it will give you the answer. See that. Now, if you see that residue it is coming from this, obviously it is also having the residue, but if you observe closely, it is lower than what you are saying. But we also did a good job, right? Because it's a very simple one line 2D. But if it is like 784 dimension, can you handle it, guys? I don't think so. So the best fit line comes like the red line. Look at the coefficients, the weights and the bias. Here the weights and the bias is slightly closer to what you do, but optimizer will get you the best output here. Are you feeling it? Come on, right? Your residue is not that bad because we did it intuitively. But you understood the working of neural network. It works in the similar fashion, my dear. Trust me on that. So all these weights till 784 is going to be decided by whom? By the optimizer. Just like there's an optimizer working in here. So this best fit line is powered by what? An optimizer, which is doing the ordinary least square and it tries to minimize it, right? OLS, remember? Not ORS, OLS. Ordinary least square means least means minimize. Minimize what? Sum of squared residues. So similarly, we will also have our loss function or cost function and minimize it and get the weights after doing this for one neuron. Now, what is the concept of bias? Bias is what I am headstrong that I will not allow something, okay? But you can clearly see that the weights are going to be decided by the optimizer who decide the weights. In the beginning, you can make the weights as all 1 or 0. That's up to you, okay? Right? And mathematically, optimizer will keep changing this so that it gets the best fit line, which you saw here. It will try to understand what is the best loss function. Loss function has to be minimized. So it will try to keep changing this value and update the weights and the biases so that it gets the minimum value. Once it converges to the minimum value, the weights are going to be fixed and then it will move to the next and then it will move to the next. There's a concept of back propagation also. So that is what going to drive the updation of the weights and the biases. Don't worry about it. Okay, but that's a big concept. It will come later. Okay. I hope you like this example because this animation helps you to understand how does the weights and bias change, right? If you keep trying to move the line to get the best fit line. Similarly, to get the minimized lowest value of loss function, the weights and the biases are going to get updated. That's the reality. Okay. So when you will see the mathematical function, right, which I don't want to teach you now, but actually it will be what? It will be what? You will take each activation function, right? And you will do the sum. That's how you do. You'll go till what? A784, W784 plus B. This is you have done for one neuron, first neuron. You'll do it for how many neurons? 784 neurons. It will become like a matrix calculation, guys. Can you see that? I hope you are able to feel. So this part is known as language dot product because dot product gives you the sum product and then you are adding a bias. Understand? So this is just a teaser, but I'll get into the true maths going slowly into it and gently into it. Okay. So you will do it for 784 neurons, right? Convolution. So guys, this is the new word in the market for you, and that's convolution. Convolution has been derived from the word convolve, right? So I'll show you something and then you realize what's happening, okay? There is a value which you are putting it here by sliding this 3x3 filter. Can you see this? It's a 3x3 filter because you have 3 rows and the 3 columns. It's a 3x3 matrix, right? Observe this. So you'll keep sliding and keep moving and you will start capturing the feature. So what is this you are doing? With everything which you are moving around, the moment you are sliding something, you're trying to capture the complicated details of the image. Now, image can be colorful, image can be anything, to be honest. Means it doesn't mean to be like it has to be 2D image, it can be 3D, RGB channel, everything. Okay. Similar thing you are saying in a different way, and this is it. Let me show you. But observe this. So can you see that if you keep moving around, you will get the value, and also there's a multiplication happening to get the features of the images. That's the intuition behind convolution. So mathematically, those who are from electronics engineer and all, if you remember, and that's something I can show you here. Powerful intuition portal. I'm putting here both the links. Guys, you have to see it for yourself. Both the links. But if you see what I'm trying to say here, from the image by using a filter, this is your filter. Okay. But this is very high level introduction. I don't want to get into the details yet, but you got it, right? But how do you explain convolution to a kid? That question remains there, right? You can't say that, oh, you are taking a filter and all. How do you explain a kid? Okay. How do you explain convolution? Okay. So let me explain. Question is how to explain convolution to a kid. Let me help you. How to explain convolution to a kid. So let us break this. Suppose, so understand, we have a small image, right? So let us imagine checkerboard you have seen, right? Let us imagine, I'll write and talk through. Let us imagine we have a small image. We have a small image. So checkerboard is something, if you have not seen it, like you are adult and you have not seen a checkerboard, it looks like this, right? Now, what is our objective? Our objective is to detect patterns in it using a filter. Okay. So far with me, what is the working of this filter? So it will do what? Filter would slide across the image and at each position it will perform a small operation. Now this operation is up to us, right? To make this happen, it's very simple, right? You will do some operation, right? That operation is like, okay, I have an image. Let's say this is your checkerboard, right? What we have to explain to a kid that you will go and slide. Now, this is something you have to understand, that you put a box like this on top of it, right? So you're taking a 2x2 filter, which is more like a number 1001. It's like an identity matrix, right? And then you do some operation. What is the next step you will do, my dear? You'll move on to the next. Then you will slide the filter like this. Can you see? Then it will move. I'll use some 4 different colors. So this is your another one. So that 2x2, how many slidings you have done? Starting from here, you moved from here to here, then you came down and then you moved there. So total, how many calculation you will do? Overall, 4. 1, 2, 3, 4. I know this 4 is not visible, so I'll write 4. So this is your original image. This is your convolved image. Can you see that your convolved image is like having 2x2 matrix from 9 cell to 4 cell you have come, right? So you have captured the pattern, right, across the image and simplified it too. Now, how to explain this to a kid? Because if you explain this, you are removing a filter, the kid will say, go to hell, I don't understand anything. So what you have to say to a kid, I'll explain. You take a magnifying glass, right? And you zoom in using the magnifying glass, right? And try to match the pattern. You clearly know that the moment, suppose I make this like this. If it is this small size, right, you need a magnifying lens or glass. Now, the moment I know it is tiny for you, intentionally I'm making tiny. If this is this big, everybody can see the pattern, but the image is like this now. It is just a tiny part of the image of a big image. Think like that. You tell me, without getting into too much of it, you know that these two guys makes a sense. This is how you will realize there are 4 segments, right, guys? Let me make it 100%. So if you use a magnifying glass, you will be able to match pattern and you will say, see, which one is closer image to each other? So you will say, which one is closer to your image? You will say, looking at the magnifying glass, although it's tiny. So this is like why I'm trying to show you this story. This image, the moment you put to a magnifying glass, which is this, so you will say that, dude, look at this. If you put a magnifying glass on top of it, right? What I'm saying as a point, or what I'm making as a point, is that, so what I'm trying to say, guys, if you put a magnifying glass on top of it, your image will look like this, everybody. So what I'm trying to say, the magnifying glass will give you this image. Then you will be able to see that these 4 guys are closer, right? That's the role of a filter. You can ask your kid. Your kid will say that, I think this is closer. Slightly this one also. But definitely these 2 guys are too much closer, right? Similarly, we'll say that, okay, these guys are closer, right? Or these guys are closer. Are you feeling it? So what you are doing when you say closer, the word itself means that you are able to Match the patterns. You're making like look alike, match the pattern. Pattern of what? The color, the shapes, and the size, right? Are you feeling similar? Convolution does the same thing. If something is similar, something is correlated, why you need to keep two things? It's redundant, no, right? So that's what this image does, that out of 9 cells, the same quality of the image can be explained with how many cells? 4 cells in reality. And you don't believe me? No, you have to believe me. This is just the intuition I'm giving, guys, convolution. So if you see this, guys, if I just make it tiny, do you see any differences there? Come on. This is how this level it works. Any differences there? But at the data level, there is a lot of difference, guys. In one, you are using 9 cell, means you need a 3 by 3 matrix to represent that image, the left one. The right one, you are using how many? Only 4, 2 by 2 matrix. But in the quality, in the right, nothing goes away. That's how you are trying to take an image and make it easy for everybody. But the moment you zoom in, you see that there is some difference, right? But the moment you zoom out, and that's the role of convolution. Convolution, in simple term, it tries to capture the edges and the patterns and similarity of a big image, right? Detailed image, and simplify it. Okay, are we good? Are you guys good here so far? With me? Okay. So this image will be still there so that you don't forget this line of mine, right? Both original image and convolved image look similar. Okay, I'll write a note here. Do you think it's a valid example to explain to a kid? You can challenge me. No, Akash, it doesn't make sense to me. I think you can use a checkerboard and magnifying glass to explain to a kid. Second question. Obviously, there is some informational loss, no, Sharanya? But yeah, obviously, it's always about like you want a 4K or 2K, but the here idea is to not do anything quality image printing. It's not a media business. Here we are trying to detect the images. Convolution neural network is to help you identify the images. You will anyway get the idea, right? This why do you need to go to a clear image? So I'll now intuitively I'll introduce convolution network, guys. So I'll write a convolutional neural networks is a type of deep learning model specifically designed for tasks like image recognition, object detection, and other tasks involving spatial data. So what is the spatial data, guys? Geo data, weather forecasting, right? Whether the, in US, right, a lot of hurricanes come, right? And it has gotten a lot of name. Whether so spatial data is all about your anything related to geocoding, right? Okay. Ideally, any data which defines the location and the shape of objects. That's how it is. Okay. It's more related to geo. Okay. Now, you might be thinking, CNN is there. Before that neural network we are doing, right? Why do we need CNN? That can be a question. Before I get anywhere, right? Means you already had the NN, neural network, ANN, artificial neural network. Why do we need CNN instead of NN? Any idea, guys? See, image recognition can be also done, like digit recognition we did, right? There's a very big difference between CNN and NN, right? Let's understand. So, and that can be a question in the interview. So I'll put some star or something that, why do we need CNN over ANN? ANN. I hope you know, right? CNN is already, this is your simple artificial neural network, which have been studied so far, right? There are a lot of reasons, but the key reason is what? Where you should answer it. So guys, you need to understand the working of CNN and ANN, right? And remember, we were doing this, we did this task, na? MINST data, handwritten digit recognition, right? MNIST data set. I'm just going back. In this, we used to have a grid, remember? 28 by 28 pixelated form. So how many number of variables we have, input variables, guys? If I take this matrix, right, it will be 784. Remember that 784 input variables or features, you can say, or features. And if you recall also that in ANN, what we did, we said that each neuron, listen to me, I'm writing also, in ANN, each neuron in one layer is connected to every neuron in the next layer, right? And to do that, so to make it happen, right, to process an image in ANN, listen to me. The image must be flattened to a 1D array. And if you remember my code, I have done this flattening. You can open the notes, right? Image must be flattened into a 1D vector. So to process an image in ANN, the image must be flattened into a 1D vector, right? But what is the problem? The problem is not here. The problem is the moment you flatten, listen to me, the moment or the process of flattening ignores the 2D spatial structure. Computation will come later, but understand that structure goes for a toss. 2D spatial structure of the image. Basically what that meaning the neural network does not understand or does not explicitly capture the relationship between the neighboring pixels. This is the important thing you miss here. Most important, computation, all this thing will come later. Simple, not simple, all those things can come later. But you understand what happens? The moment you just put it and flatten into array, are you going to understand the relationship between the neighboring pixels, just like in this image, which we are trying to do? The relationship between these two guys, you're missing it. Because there's no 2D, there's no 3D structure altogether. I'll take a pause. This is what you do in ANN. Okay, so far with me. This is your working of now working of CNN. Although I'll go in a lot of detail, but this is just to give you a high level idea. How does it do? Because my working of CNN, I have to go into the heart and soul of this. In contrast, this is still part of introduction. I'm not teaching working of CNN yet. What CNNs are designed? CNNs are designed to handle the spatial structure of images. Okay. How do they do that? I have just shown you, in this, how you might have opened these links to see, right? How it is, sliding and, capturing the information. Or in this checkerboard example, right? This is what you say, right? Are you doing any flattening there? No. You are, without doing any flattening, you're moving a filter in that 2D frame only, right? With me? So CNN computational is a little tricky task, but it doesn't do any flattening of the array. It retains the structure of the image and do this scanning. So what I'm saying, high level, CNNs are designed to handle the spatial structure of the images, and they use convolutional layer, which is also called filters. They use convolutional layers to scan small patches, also called local regions, neighborhoods, right? Neighborhood of the image, and detect patterns. What kind of patterns? Like edges, textures, or shapes, and many more, without flattening the entire image. This is the major difference. If someone asks this in the interview, I think these are the questions they will expect you to know before they get into the coding and all. You agree, guys, on this? They will ask you this question, right? Why are you doing CNN? Because you have ANN. Why are you not using ANN, right? What does spatial structure include? Spatial image in the context of neural network is the arrangement and relationship between pixels. So let me show you. Now, if you understand this image, try to understand it. Guys, I would say don't worry about this output, input, this animation I'll show you later. But tell me one thing, if I go into like pixelated form and take any part of the image, do you think there is a lot of similarity? I've taken a very simple image, but if I just go to this part of this image, do you see there is a lot of similarity? At least this whole big patch. Come on. Agree or not? So rather taking each and every pixel and convert into like a flattened array, just understand that you're complicating the whole things and missing the similar information, right? So that's where CNN says that, oh, don't worry about it. Don't go into the pixelated form without understanding the pattern. There are a lot of things being done here, right? For example, this image. See this image, guys. Don't get excited about seeing these images. Guys, can you see that? I'm just showing you that, guys, if you see this, obviously, spatial is a word coming from geo, but here in an image, what do you mean by geo? Geo is like location of this patch, this filter, observe this. So location of this filter on this image, right? And then relationship between that. The same thing you do on a global geo map. I don't know how many of you guys have seen this. Earth, Google Earth. Guys, so look at this map. This is a Google. This is coming from Google. Spatial actually means you go to a location, right? So go and pin it. So you come here. Let's say we are, I think I'm sitting here somewhere, right? So I'll go and pin it here. So if I go here and pin it, right? And I come that, okay, go zoom in. So can you find that there is some similarity in the topography of this part of the, right? I don't know how many of you guys are aware that this part is known as Western Ghat. Why it is called Western Ghat? Because of some reason, right? But can you see that the green patches shows that there are a lot of trees here? Definitely Bengaluru used to have a lot of trees, but now not much. So you can clearly see that there is some similarity between the images, right? If I put a pixel here, guys, on this color, some other color, you'll realize that there is some similarity. You can clearly say that this part is more closer to this part, and this part is more closer to this part. No, sorry, my bad. This part is also closer to this. Okay, agree? So why I'm saying this, whole idea of these things is that find the location in the image and find the relationship. Now look at this Python thing. It's so interesting, right? You are taking one patch. Can you see that? It shows you this, right? So this is like you're taking the texture of the images one after the layer and layer, extract the feature, and finally you are able to classify this is a snake. Don't worry about how is it done it, but you can clearly find that after the training, sorry, that it is the snake, right? How does it do it? Don't worry about it. But can you see that there are some patterns and there is a lot of similarity? Okay. Even you put a patch by yourself, like let's say I put it here, right? Do you see some similarity? Yes, there's a lot of similarity. In fact, you will say that I can just replace this whole bloody part, right? Right? This whole damn thing, right? With a one, because it's the same thing. Why I need to keep different part of it, right? In contrast, neural network will do what? It will take everything, even it is similar as a new input feature, right? Without putting any brain to it. Listen to me, let me do it differently. Because in ANN, you will take everything as an image, right? You will divide it like this, right? And you will say that everything is like a one input feature. Agree or not, guys? This is what I have taught you. You have to agree. But here, you're not doing the same thing. You are going to do a lot of things different. I'll take a pause before I go anywhere. These examples are making sense? Yeah. And that's why CNN needs some power, some juice in the machine, Soham. It can't be done on like a baby machine because it is computationally heavy, but makes your life easy. There are two things happening. Okay. So you realize that CNN is really a good architecture for identifying objects. Can you see this? Now this image has a lot of details, right? It's not like it's a real image, to be honest. That is also a real image, but that image is most focused, right? For an algorithm, right, you can clearly see that it will go, obviously you have to take a filter. You can't take a filter which is bigger than this, right? Then the filter is going to confuse your output. But you can clearly see that it gives you a probability, and you will have seen a lot of guys doing this on YouTube, that this is a car, this is a horse, this is a person, right? On YouTube or on LinkedIn, people just keep showing this live real-time object detection, but that's not that great because they do it, right? They do it, they just copy paste the code, and latency is so high that till the time your camera is identifying what is what, you would have hit him. Okay. So it's good for lab or training project or small your college project, but I think that's what self-driving car they're thinking about, right? How to identify who is there in front of them. Right? Okay. So guys, what I'm saying, coming back to on the screen, observe, right? It is able to identify a car. Definitely it has been trained on car, dog, horse, person, right? But it does a great job, Lakshmanan, right? And obviously I'm showing an output rather than how does it do it, because that is something I'll cover in the course. But you understand that it is able to identify a real image and gives you a lot of details which are publicly available to the model. Make sense? Do you think this is an output of a CNN? On the right hand also, it does the same thing. It identifies a dog. It identifies a dog versus a cat. And look at the probability. The probability is like damn good. Hello, yes or no? See? So just imagine these images are like what? This the right hand image is such a dark image. Hello? Look at the image, you know, it looks like a dark image, not like very bright, but still model doesn't care. It will identify. It has to have the edges and the patterns. So I'll get into the heart of it. Don't worry about it. But does it answer the question that it will take care of it? That's more like a teaser to show you that it will take care if there are multiple images or the transparency you're talking about. So let me talk about a real example some real use cases. See, I'm not very sure that what are they using, but one very cool example, and it is in my home also, and this is something everybody is saying. So you must have had a company, I'm not promoting the company, TP-Link. So I have a camera, a house camera, Wi-Fi camera. And what does this camera do? Obviously, it does the recording and all, that's a normal thing, right? Monitor, but it has amazing feature. And what are the amazing feature? Person detection. Can you believe? So when I'm away from home, I set it to person detection, just thinking that if my door is locked, how can someone can barge in, right? So person detection, this is just for the safety. I don't know if some of the kids or movement detections, if someone is moving in front of the camera, it will, give you some notification and all. Or as a matter of fact, a lot of cameras are focused on the baby, and now you are sleeping and your baby starts crying so let's say you're sleeping in another room and baby is another room, or it's in the same room, but you have a deep sleep, right? So baby cries, so your phone can ring or do some big alarm, right? It's more like a SOS alert. You know what? This is like life-saving feature. A lot of time baby gets intertwined, gets entangled in the blanket or something, and they start suffocating. You know that? Uh, right? I have read about it. I don't have a baby, so I know that as a matter of fact, as an information. Such an amazing thing, right? And can you think this thing comes in 1,500 rupees, 2,000 rupees? Okay, let me also say this is not a promo post. So this is a camera, I have it in my home. It's very cheap, not expensive. But they must have some technology. I'm saying that even they have a simple, not they are running AI or anything, but even if they have some simple program, but it does the job, the convolution neural network, right, will do much better than this. Make sense, guys? With me? Another use case when I was in Amazon warehouse, right, so I saw it, is that now Amazon is testing humanoids doing their fulfillment. So what is a fulfillment in the sense what Amazon is doing, my dear? I'll show you. So what Amazon is doing, and you can watch this video later. I've given the link. So what Amazon is doing, that they are testing the humanoid. Can you see that? So they have the camera here, right? This is the humanoid. And this guy is so trained that it can detect a barcode. Obviously, there will be a lot of technology. I'm just saying that obviously AI is making it happen, else it would not have been possible. Trust me on that, right? AI is making it happen. Okay. So now they understand that in a fulfillment center, this guy will go pick a bag, pick a parcel, package it, put it to the logistics on the conveyor belt, and it will come to your doorstep. I know, don't go there that, they will be like, replacing human labors and all. Don't worry about it. That's not my job. I'm just trying to say that how Amazon is using human eye to pick a parcel, pack it, and ship it. In fulfillment, these are the three things people do, right? Pick, pack, and ship, right? Yes. And that's exactly they are testing, I think, in some Amazon warehouses, not in India. Amazon warehouses, they have this kind of testing going on. I don't know. They're also putting this to the deployment, means they're using it. So there can be 10 different applications. So, detecting the human objects and all these are all fine, right? But there can be a lot of real application of convolutional neural network. Trust me on that. And there are a lot of articles, going around. I don't know if you guys are aware of not, but if you are in pharma industry, right, medical science, there are international journal people have published. Obviously, these things are still not in too much uses, but I'll show you some images so that you get a feeling of it. So this is a journal they have published. See. So they are using a 3D CNN to understand the lung scans. Guys, can you see this? And here you get a bigger quality image. I think this guy they have provided. But why I'm showing this so that you understand that they have taken a CT scan. Can you see a CT scan, which is generally that looks like this, right? Can you see it? And if you want to read about this article, I'm sharing this here. So they're using 3D CNN to try to find if the patient has the, see, Arun, there any correlation with MRI and CNN? See, CT and MRI is what? It gives you a way of looking at the images, right? Isn't it? So CT and MRI more like the way to generate the scan of your lungs without looking into the bones, right? See, I'm not an expert of CT scan, MRI scan. But can you see that, guys? They have given you 3 combinations, RGB color. Are you seeing this? Green, red, and blue. Okay. So what they're trying to do, they're analyzing it in different segments, coronal, axial, sagittal, different slices and all, right? And they are putting into a model to come up with that, whether it is a COPD and non-COPD. There are only 2 outcomes, right? So they're trying to find that if somebody has, so COPD, I know it is chronic, obstructive. It's a technical language, or I would say, medical language for pulmonary disease. Trust me, these ones you can only find it. So this disease is there, and this is the whole thing, COPD. So means if the patient has a disease, this is like yes, this is like no. Make sense? Yeah. So they're trying to predict disease is there or not. Okay. And in this CNN model, they have reported that their accuracy came to 89.3%. So what they're saying that if you take a scan, give it to a model, it will accurately predict 90% of the time that a patient really is having a COPD or non-COPD. Make sense? This is the same thing the expert look at it and they try to find looking at the scan. The scan is a movie. It's a film, they give you a CD of the CT scan or MRI scan. Are you guys aware? They don't give you the images only. They also give you the, the scan video. So when I had COVID, definitely not a good time to talk about, but they also gave me so my lung was scanned and they do it. Okay. Make sense? Why I'm saying that this is so important. See, you really need a good lung specialist to detect this at an early stage, right? Understand what I'm trying to say. Any tumor, any cancer, any liver failure, any heart disease, right? You really need the expert. But do we have the experts across the globe? Answer is negative. Only lucky, the people who are rich, ultra rich, who have good connect and network, they get to the good doctors. Agree to this, guys? Come on. It's just like finding a good deep learning trainer also, by the way. So just imagine that if someone is going to just teach you or tell you or just using a tool, just like you have a watch, you have a smartphone, you really don't need Steve Jobs all the time. And you can yourself find whether you have this disease or not. Are you getting my point? Just imagine you can manage your health, right? If someone tells you that after 10 years, someone has a prediction that if you don't do this in 3 years, your heart will fail. You will do something about it. But if someone tells you that, dude, your heart has failed, what will you do about it? Nothing you can do about it. You will just spend all the savings in those 10 weeks or 20 weeks, but the end result doesn't change, 90%. But in 3 years, 5 years, if somebody predicts something can happen to your body, looking at your lifestyle, your body structure, your genes, your RNA, DNA, blah, 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 and they can tell you that, okay, follow this. Obviously, then the ball is in your court. Still, you follow the same thing. You keep smoking, lung cancer is about to happen. You know it. It's just like that. Now, evening rain will happen, but you still did not take out the umbrella. Are you getting me? So don't take these pointers lightly. And mark my words, after 10 years, maximum 10 years, 5 years to 10 years of time, a lot will be happening in the medical science using AI. AI is going to be tapped like anything into medical, pharma, medical, life sciences. Be ready for that revolution. Make sense? Okay, on this note, guys, I think let's take a break. But I hope you are getting hooked up to this, getting some good sense that wow, this is really interesting. And let me also show you the model they use. They have given this image in the end. Look at this. This is their convolutional neural network model on the images. Just understand this. Obviously, this is a complicated model. I'm not going to teach you this. And please don't ask me to do this lung cancer prediction problem. I have some protocols to follow, so I can't teach you this. Look at the loss and the accuracy. Can you see this? In the training and validation. Observe so close. I like this. So this journal, you should read about it and please read about it later when you are ready for it. But look at this, even for the training. So guys, blue is training and the orange is validation. Even if you put a lower line, right? After 500 iteration, you are maintaining easily more than 90%. Can you see this? Even you put a lower line, you put a lower bound. See? So this will be 0.88. So maintaining that 0.88. I think that's why they are saying 88, 89. So interesting, right? They have plotted a lot of things. Read about it. They have done ROC curve. Look at the ROC curve. So these are some confusion matrices, right? Okay, guys. So now I'll get into the, CNN detailed discussion. Okay. That's the module name. So CNNs. So the moment I write CNN, guys, you should understand it. I'm talking about convolutional neural network. Have proven very effective in image recognition and classification. Image recognition and classification. Okay. So what is the implication when I say this? So, it's a really successful in identifying faces, sketch drawing, putting into a digital mode and identifying the criminal through the database. Guys, if you just send an image, no fingerprint, how will you identify a criminal? How will you find the social security number? Have you seen these movies? Don't think it is all fake. It's all real. So they have a database of all the top-notch criminal, right? In CID, they are using, even in India, it's not like they have to do it outside India. They have these mechanism. So identifying faces can be a real use case in these kind of world, right? Like somebody has a, red corner notice, right? So let's say I'm the Vijay Mallya or likes of them, right? And I am done some fraud and I can't travel outside, right? You have some restriction. So one way is that to stop it, right? Or find that person is that, capturing images from traffic signals, right? Because they will be traveling and, process that in the database. Make sense? So objects, traffic signs, right? Apart from powering vision in robots and self-driving cars. So just understand the length of the use case, length and the breadth of the applications and the use case, right? And these are some well-known, example I'm looking at it. So if I show you these few images from the screenshot, guys, I have, just observe this. So, CNN can read and generate this, okay, for you that what is happening there. So soccer player is kicking a soccer ball, right? likewise. Make sense? Before I get into the detail of it, right, I'll show you the journey of, CNN. Okay. This is the timestamp CNN is having. Can you see this? So the first convolution neural network was introduced in the year, right, 1989. I think some of the guys were not even there. I'm talking about the college guys, right? Isn't it? So what is the timeline of CNN? You see this, right? 1989. So don't think that it was foundation was long led, right? It's not like something a new thing. So if you remember, I mentioned that in 1950s and 60s, perceptron got onto the canvas of AI. Remember that? Don't forget the guy, Frank Rosenblatt. He's the guy who introduced perceptron in 1958. Do you remember that? I had mentioned that, right? 1958 perceptron came. Okay, maybe I'll revise for you guys. This is very important. You have to understand the history. So perceptron could classify binary patterns, right? It has limited abilities. 1980 time, right? New cognitron came into the picture, and that was done by Kunihiko Fukushima, right? It is coming from Japan. So it was more, you can say that the early version of neural network, convolutional neural network, right? 1989 convolutional neural network came, and LeNet, right? So LeNet is an architecture name. So this is the early stage, but 1998 time, right? LeNet 5 got published. So they have missed this. But definitely they're doing research for the longest time. It's not like that they came in. So 1998, LeNet 5 published, and LeNet architecture, also known as LeQuan, okay? So the guy was Yann LeQuan. He developed the first convolutional neural network. I'll write a pointer. First convolutional neural network to do handwritten digit recognition, which we did with, ANN. So they tried it with existing use case, right? That's what you will do, right, guys? Come on, Eson. So they did it for doing the handwritten digit recognition, right? That's the first practical application of Mr. Yann LeQuan neural network. Okay. So far with me? Good. Then 2012 time, AlexNet. So AlexNet, this was a competition, and AlexNet was, I think I would say, like, it was developed to do a large scale visual recognition challenge. So there was a challenge going on, which is called ImageNet. Large scale. This is all research field nomenclature, so don't get overwhelmed with just this is the history, and we should respect the history. Visual recognition challenge. Just like Kaggle does it in a simplest way of saying it. ILSVRC. It's a big challenge. You can Google about it later. So, in this, and I'll talk about it, AlexNet, they used ReLU. Can you believe it? The first time they used ReLU as the activation function, which I was teaching you guys, right? And that guy also used the concept of dropout. You might have heard dropout, but I'll teach you. And leverage the GPU acceleration. A lot of people don't even know what they mean by GPU acceleration. Using all these things, guys, he was able to do a great job. What was the job? The job was to predict or to make deep CNNs, deep is like deep learning, feasible for large scale image classification task. Just imagine that. Okay. So this architecture was able to do quite a lot of, impossible tasks. So you can give hundreds of thousands of images. It can do a right classification with a very good accuracy. Okay. So far with me, this is what happened in 2012, guys. Okay. In 2014, right, you might have heard about VGG. So the guys, Karen and Andrew, introduced VGG Net. So VGG Net, these all are architectures, guys. I'm not going to teach everything, right? Because architectures are not in the core, because it's not the like a in-depth, but VGG 16, 19, Google Net, RCNN, they all came in 2014. 2014 time, right? They were able to use a lot of more filters, layers, make it more complicated and getting some better result than the AlexNet. If I have to keep it very simple. So they were using convolutional filters of different sizes, right? To do a lot of more detailing there. 2015, ResNet came into the picture, which is also known as Fast RCNN. So ResNet was, mind-blowing, Miss guys. So RCNN, right? It was doing training up to very deep. How deep? The 152 layers. Guys, you understand what is the meaning of 152 layers? Let me show you one image which I have given you guys. So suppose these are like 5, 10 layers, right? Or you see it here, some layers. Okay. So how does a CNN look like? CNN layers, you realize. So let's say this is a CNN layer and you are just seeing 4, 5, 10. They are telling that I can go as deep as 152 layers. So let's say this is your CNN layer, guys. And then you realize that when I make this word or statement 152 layers, you should be like, your eyes should be open. So this is a very simple CNN, guys. So I know it's not very visible, but let me show you there. This image is bullshit. Let me delete it, guys. See. So guys, can you see this? You are not going so many layers, right? Right? You have starting from the 1 layer, 4 feature maps, 8 feature maps, 4 class units. So layer wise, if you see, there is like 1, 2, 3, 4, 5, right? And you are stopping there. But what I'm trying to say that in ResNet, they are telling that they could go up to 152 layers. Okay, just imagine one behind the other, one behind the other in the sequential. Okay, makes sense? This is what ResNet gave it to. So see, the structure remains the same. Only thing they were trying to do some more layers, get better results. That's how any development happens, okay, to be honest. Now, in 2016 onwards, right, they are starting with the object detection by using yellow. I think yellow is something you might have heard about it. It's a very famous thing. You only live once. It's not that yellow. It's a different architecture. You only look once. It's not you only live once, okay? So yellow architecture is you only look once. This is the name of the architecture. So this architecture this is the architecture you use in autonomous driving, self-driving cars. Can you believe it? Or video surveillance. These are some real application, guys. Video surveillance, right? So you only live once, right? Is one of the top-notch and latest development, right? And definitely they are going behind the scene, doing a lot of things. So now they have gone into like, 2020 onwards. They have started testing the vision transformers. I don't know how many of you guys know. But YOLO is known for doing the object detection in real time. You know that self-driving cars do it, right? It's the same thing which I have been talking about. Makes sense? But fast forward to 2020, which is not here, 2020 onwards, they are now testing not CNN, they are using vision transformers. You can read about it when you are there, also known as VITs. So to be honest, AI has seen a lot of traction in last few years. I would say last decade, to be honest. So they're using a lot of information. What is the beauty of vision transformer is that they use limited training data and can give you accurate result, which is really effective, right? So for NLP kind of task, it can be done very fast. Okay. Transfer learning is being done 2014 onwards. There are a lot of things which we need to discuss. Okay. But guys, in CNN, these are the keywords, and that is something I'm writing here so that someone should always come to me and ask that, Akash, you did not teach this. Okay, so this is just for you to crack in last few decades. These are the things have been done. I think ReLU activation you already do, right? You already know, guys. I have taught then the concept of dropout has come. So these are some advanced things being done in CNN. Batch normalization. I don't know how many of you guys are aware of this term. Priyank, have you heard? Batch normalization, dropout. And the last thing is what? Transfer learning. It's all in the syllabus, and I am supposed to teach you guys. This is just to track. This is all part of what, my dear? CNN recent developments. Okay? So once I complete the fundamental structure of CNN, I'll show you the application of this. Make sense? So far with me, guys? Come on. These are just here for you to note it down. Funny, I'm going there. What does, what does it do in each layer? So that's my job. I'll tell you, we have not gone there, so don't worry too much on that yet, but I'll go there. Okay. This is it. Now let's talk about a fundamental architecture overview. Architecture overview, guys. I'll start with the typical CNN architecture. A typical CNN architecture consists of several okay. So guys, CNN layers, typical architecture. So number one is input layer, because this is nothing can change there, right? Number one is input layer. So let's start with input layer. Although you know it, but I'll make sure that you know it in detail. So number one is your input layer. So guys, you know, right, in input layer, what happens? The raw image data comes in a multi-dimensional array known as a tensor. So I'll write one line. The input layer of a CNN receives the raw image data in the form of a multi-dimensional array, also known as tensor. Okay. So for grayscale image, I think I spent some good amount of time on that. So for grayscale images, the input tensor will only have a height and the width, remember? So basically the input tensor is height, width, or you can say into one, but one is nothing. One refers to the signal. So I'll say, what is H? H is the height of the image. And see, height of the image can be decided in pixels, centimeter, inches, whatever. Generally, we take number of pixels. Okay. Number of pixels, but taken vertically, just refreshing a memory. What is the next one? Next one is width. That's your width of the image. And what's that? That's number of pixels horizontally. That's my first layer. And what is one refers to this point, guys? So what is one? One is like your single color channel, which is grayscale. Color channel grayscale. This is for grayscale images. For RGB images, guys, colorful images, the same thing, you will say input tensor is what? It will be height, width into 3. And I'll highlight that's the only difference. Everything remains same. What is this thing different, guys? Here 3 represents what? What are they? It is red, blue, green. Red, blue, green. Very good. So this is your input layer done. You don't need to do anything. This is the layer. Moving on, guys, quickly. Second is what? Convolutional layer. That's a new layer, right? This is the core building block of your CNN. Core building block of CNN. Without this, nothing can happen. So in this, what you're doing, it applies filters, also known as kernels, right? Not colonel, kernel. Let me write, you'll realize. Also known as kernels. That's a mathematical term. So it applies filters to do what? To extract features like edges, corners, textures, etc. So what I'm trying to say, guys, convolution layer has the filters which extracts these things, okay, like edges, corners, texture, etc. Continue. The filters slide up on the image, slide over the input, and this process is called convolution. So, right, this process is called convolution. Why I'm doing this? This process is called convolution, and the filter slide over the input, and this process is called convolution, and it generates a feature map as the output. And I'll show you by taking some examples, so don't worry about it at all, okay? So how do you do it? Understand the steps first. So guys, it's more like you are sliding a filter over the input to get what? The feature map. Just focus on the highlighter, right? I'm going to show you some real fun thing for the day so that you go like with a lot of ideas, right? So have you seen the tic-tac-toe game? I think everybody has seen tic-tac-toe. Every bacha has seen. Can I say that? Tic-tac-toe. Those who are struggling to understand what is this is it. Guys, you can't say no, right? So what I'm trying to say that, guys, I have image, right? 2 images. If you look at the pixelated form of X, O. So guys, I'll keep it like in my layman term. So this is like your letter X and letter O or 0, whatever you want to say, right? Let's not fight over this. Can you guys see that? It's a very, if I just make it tiny, you will see that it is, we're putting the O, right? If I make it tiny, it looks like you're putting an X. Guys, with me? Guys, say something. I need now frequent good to go on this. Okay. So if you see this, it's a very simple image. How many pixels you have? You have 6 by 6. See, 1, 2, 3, 4, 5, 6. So it's a 6 here on the width and 6 here on the height. It's a very tiny image, to be honest. It's a 6 cross 6 pixels for both the images. Agree? So total how many pixels? 36 pixels. Okay. Now if I have to use this in my normal neural network, what I have to do? In artificial neural network, I will flatten it. Just understand this. What I'll do, I'll flatten it. So basically, this is how it will look like. See, I've put someone has done real good job on this, right? So you see that images are making a lot of sense. That's why I'm taking this example. It's available, right? From somewhere I have referenced this. It's like taking each of the guys like this. Observe the pattern. So go like this. So see 0, 0. So wherever it is, it's a very simple. Wherever it is 0, it'll put a white color. Wherever it is 1, it is dark. Can you see? So it tries and keep it till the last. So basically, you are looking at what, my dear? You are looking at one single column of how many nodes, how many neurons? 36 nodes from the input nodes, right? So basically, it is a 1D flattened array. If I do this in the convolutional, sorry, ANN, agree? Now, if I have to go and complete this, it will look something like this. So what I'm saying, guys, here we have 36 connection from the 36 input nodes in the hidden layer, right? Guys, observe, this is how we will model it now. Correct? Suppose you have more neurons. So this is just one neurons. So you have one neuron getting connected to 36. Suppose I say you have two neurons. So it will look like what? Like this. So if you can see, the first one has how many connections? This has 36 connections. Means 36 weights and the bias, right? You have to do. How many this guy has? There are two neurons. So this is 36 and this is 36. If you do a plus, how many are there? 72 connections. Can you see that with every one, right? It is going like, my God. Makes sense? Just imagine that you have taken this image like a 1 megapixel. Not even saying, guys, 12 megapixel and 50 megapixel. 1 megapixel is like what? 1 into 10 to the power 6 pixels, right? If you take square root of this, that gives me the height or the width. So it means 1000 pixels in the height and the 1000 pixel in the width. Guys, agree? And that will make an image of how many? 1 megapixel. Agree? This gives you 1 megapixel image. Let me write fully so that you don't get confused. So can you see that? So for one neuron will have how many connection, guys, in CNN for this kind of input? It will have 10 to the power 6 connections. Means 10 to the power 6 weights. Are you feeling the complexity, guys? So what I'm trying to make a point that for a neural network, I'll write also, for a neural network having 1 into 10 to the power 6 input connections, for a standard size image. Yeah, 1 megapixel image is a standard size image. Now I have digressed away from the tic-tac-toe. the model needs to estimate 1 million. I have only taken a 1 megapixel. So the model needs to, it's a standard size. The model needs to estimate 1 million weights for each neuron which is computationally highly expensive. You guys agree? I think you have to. So do you think this is the effective way of doing this is the effective of doing this thing, guys? Which is computationally highly expensive. I changed the color because I did not like it, guys. I have this power. Which is a big turnoff, right? So it's not effective at all. This is what scaling we are talking about. This is what they were telling, Lennart, AlexNet, they were talking about the scale, this is called scale. So what we are trying to say as a conclusion, and this is something, if someone is really testing your knowledge, they'll ask this question. Applying neural networks, the basic one, the basic version, right, the vanilla version, right, is not the right approach. Agree? I just showcased you the problem. Millions of weights, how will you estimate, right? Just for an image classification problem, right? The reason is that as it does not scale, and it does not scale well. Make sense? Where CNN comes and help you, CNN says, hold on, let me come and simplify it. So CNN comes and simplify it. I know you might be thinking, how does it do it? That I'll explain in a moment. And make it computationally less heavy. So mathematics is tricky, but the straightforward computation is not. So what CNN does, CNN does, the first thing is to reduce the number of input nodes, okay? So I'll write, CNNs do 3 things to make image classification practical. And what are they? Number 1, reduce the number of input nodes. Right? We just saw that. Number 2, tolerate, and we will discuss more, tolerate and accommodate the marginal shifts in the pixels. So let me first write and I'll explain marginal shifts tolerate and accommodate the marginal shifts in where the pixels are in image. In the pixels within the image. This you will not understand as of now, but I'll show you. There's the third thing it does, that mind the correlations in the image, complex image. Mind the correlations in the complex image. Okay, hold on. So I'll show you all those things. Don't worry about it. So first thing first, guys, let's understand one by one these things so that you get a fair idea of what I'm trying to do. Okay. So let's take, this is our image. Let's explain the first point and I'll keep it short. This is the first thing they do, right? Step one. Let me also do the color coding. I'm talking about this part. Guys, reduce the number of input nodes. How will it happen? So what it does, guys, it will apply a filter, and there are a lot of different types of filters. So on top of this, this guy is saying, I'll apply a filter. So CNN applies a filter to the input image. And there are different types of filter. If you are aware, Priyank, some of the guys are having some good awareness. So they will think like, okay, he's only talking on one filter. I'm starting with one filter. I'll tell you all the filters which are important for your course. Okay, so don't worry about it. So this is also known as filter, also known as kernel, right? As I mentioned. So we're going to apply this filter on top of this image. Can you see this? We have the base image at 6 pixel by 6. I'm just taking a baby example so that you don't get lost. Okay, so don't think why is not taking a complicated example. Nobody takes it, right? And I'm applying a filter on top of it. How many pixel by pixel this is? Guys, come on. These are my instruments, and thanks to the guys who put together these things, I like it. If you observe, on the diagonal, it is only having the ones. Can you see this? If you observe this filter has a specific properties, and every filter has its own characteristics. But can you see this? It says that on diagonal, actually it's an off diagonal. So on off diagonal, in matrices, there are two diagonal, principal diagonal and off diagonal. This is the principal diagonal. So on off diagonal, values are 1, rest all 0. Can I say that? And rest all 0. With me so far? Now, in your head, you have to understand a point, which I'm trying to do it. So now, on off diagonal, values are 1, rest all 0. So what I'm trying to say that we will take this filter, listen to me, and we will start overlaying here. See. Can you see this? 3 by 3 pixels. Observe this, guys. Come on. Then move around. Are you feeling the same thing which I was starting the class today? So what I'm trying to say, see, guys. So this filter will look like this. I have an image. Only focus on that part. Guys, can you see this? So what I've done in this image, everything which is white, it is 0, 0, 0. And wherever you see black, it is all 1, 1, 1. There is some data, some information. Good. So this in the background, there is an input image, right? And you're applying the filter on top of it. Hello? With me? So this is the image. Keep an eye on the image. 1, 1, 1. Let me write 1, 1. So that you don't lose this image in front of your eyes. And rest, everything is, my dear, 0, 0, 0. Even I don't need to write. But the first border is this one, guys. Agree or not? I'm doing the partition. This is the first filter that I can just draw this on top of it. See? Right? See? Now, this is like a coincidence that wherever this filter thing is like 1, 1, 1, 1, 1, rest is also like 0. So if you multiply this, so, it's a dot product. Okay, so everybody, in convolution, this is a convolution layer, right? In convolution, you are going to do the dot product. So dot product between the input and the filter, input and the filter in the overlap area, right? Overlap area, only in the overlap area. And hence, we can say that the filter is convolved with the input. This is the step when you're overlapping it and doing some calculation to find something new, which we call as feature map. It's a fancy word, but the fundamental principle is that finding the overlap. So guys, if you overlap and multiply, what you will see, 0 into 0, cell by cell you do it, right? Then plus 0 into 0, don't miss it. Then 1 into 1, observe this, my cursor, 1 into 1, then go on. Plus 0 into 0, or maybe I'll write it below, 0 into 0, right? 0 into 0, plus 1 into 1, plus again 0 into 0, plus 1 into 1, plus 0 into 0. I think you can already see that the number would come out to be what? 3. Very good. This is the dot product. So remember when I was teaching you basics, gradient descent and all, in dot product is basically what? Dot product in algebra is equal to sum of products. Dot product basically gives you what? Sum of products, na? Isn't it? We have done sum products. Observe this, na? So dot products always give you this sum of product. Okay, makes sense with me? Just keep this in your head, right? So you got the first layer value, you know. So what I'm saying that you will have a feature map shape only, and you will come here and say, okay, I got this value as 3. Makes sense? But that is up to us because we can also put a bias to it. That's where the bias also comes into the picture. So I said, okay, if it is 3, no, I'll pass it to a bias term. And the bias I'm setting to this model, and this is ultimately the algorithm will do. Whatever the number will come, I'll subtract -2. Guys, can you see this? There's a concept of bias also, right? Isn't it the same thing we're doing in the neural network also, right? Some product of the weights and the input feature and then a bias. Tell me if a 3 goes and -2 happens, what is the final outcome you'll get here? 1. So you say not 3, it's 1. And there's a reason here. Okay? You're using this bias for the reason. So guys, now let's move on. Let's move on to the next part of the story. But I'll also give you the image, which I think important for us to show you that how it has been done. The same thing, I've done it manually to show you, but you can see the whole maths and you will see there is a concept of bias, right? The same thing and the feature map will be shown like here. So it goes through the bias, like I have shown you guys here. It goes through the bias and the feature map which I have given, I can move it around and show you. Make sense? It's the same thing I have written here, but I also want to show you pictorially nice diagram. With me so far? So 1 has come. Definitely this box is ready. Now what you will do, you will shift by a pixel. So next step. So what is the next step? You will shift by a pixel. It's so interesting, to be honest. Next, shift by a pixel. So what you will do, you will take this filter and you will slide. You will say, dude, now go to this guy. Can you see this? See? So I'll show you in the image so that you don't miss it. Good images always help you. So I'm showing you here. See? So you shift by a pixel, again do the maths, right? I'll do it for one more so that you get the confidence. So 0 into 0 plus 1 into 0. See, now things will start changing. 1 into 1 plus 1 into 0. Keep an eye on the calculation, guys. 0 into 1 plus 0 into 0 plus 0 into 1 plus 0 into 0 plus 0 into 0. Guys, just focus. I think here I get something. The rest, everything is gone, right, guys? Come on. So I just get the value equal to what, my dear? Come on, 1. Then it will go to a bias of -2, right? So finally you'll get what? -1. So the feature map will get updated to -1, and here also -1. With me? So far with me? So guys, if you do this, so you know, right? You'll keep doing this. So it will come here, it will come here, and then. So actually we'll get a 4x4 matrix. And later you can go home and do it. So obviously you're at home, most of the guys. So the final feature map looks like this. At least this is the output. So final feature map is this. After this final feature map. This is what you call convolution. This is the output of convolution. So guys, you started with 6 into 6, 36. You are seeing 16. So definitely have reduced it, isn't it, guys? Come on. When you apply ReLU function to this guy, you also know what will happen. So ReLU will make it what? Anything which is positive, anything negative is 0, right? Remember that? Right? Anything positive is positive. So this is 1, 1, 1. Right? And we can set that, but this is 1, 1, 1. Why this is 1, right? Rest everything will be 0, right? 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay, good. So far with me. You're trying to reduce the image size, right, guys? Come on. I'm writing concept of padding in convolutional layer, guys. So padding is a concept in CNN, okay? And that's something you should have a good idea and understanding why we need padding. You know, we'll try to answer those questions, okay? So in convolutional neural network, padding, the word is padding. The padding is used to control how the convolution operation handles the boundaries of an image. You know that any image will have a 4-wall boundary. Agree or not? Come on, look at this dog image only, right? There are 4 walls, right? So boundaries. This is boundaries. See. Correct? Any image if you take. So I'll make it tiny so that I can show you. So when I say boundaries, I mean this. Okay? So how does the convolution operation handle the boundary of an image, and why it is important? What is important so that you can ensure, so ensuring that the filter can process every part of the image, including the borders. Okay, so you understand, right? This padding concept is more, focus on the boundaries, right? Boundaries. At least we know this now. But someone can ask you that, why do you need to protect the boundaries? You can just let it go, right? Isn't it? Why? Question can be, why do we need padding? Definitely, it's like with respect to that, you don't want to miss anything in the image, even if it's a boundary, right? I think that's a very simple answer. But is that enough? Exactly my point, right? Why the emphasis on this? Now understand. No, it's the same image. Let's take this image, right? When you are scaling it, right? Isn't it when you try to move a filter, the filter will go like this, guys. This is a filter. Suppose it is a 3x3 filter. You'll keep moving like this, guys. Agree? Right? But the moment the filter is like this. You've covered this, but if there is no padding, the moment the next time filter goes, it goes out of the image. Agree or not? You understand? The moment I'll draw now, you will understand. So what happens during, and obviously the image keeps moving around. So you start from here, you go here, then you go come here, all the corners you will actually touch. So in the four corners, right, you are always going to lose something because you don't have a padding to support you. It's more like margin, right? Exactly my point, Mr. So why do we need padding if I elaborate on that? So I'll talk and write, guys. I hope now more or less you are tuned to the way of, you are in tune with what how do I teach? Keep focusing, guys. So what I'm saying, when a filter slides over an image, it starts at the top left corner and moves across the image. However, if there is no padding, now this is the most important point which I'm going to write. However, if there is no padding, the filter is your kernel. So someone is looking for the word kernel, it's the same, one and the same. Cannot fully cover the pixels near the edges of the image. Okay? And I think I just explained that, right? The filter cannot fully cover near the edges. So these will not be able to completely cover. Why? Because you have just overlapping here. Listen to me, guys, and pay attention. This is the only part you have been able to, you know, at least in this movement, right, guys? See? So you're only able to have this. What about this part? I'm making it bold so that you don't miss it. Right? So you definitely, right? Because there's nothing, right? This is the end of the image. It's a boundary. So filter cannot fully cover the pixels near the edges of the image. That's a very important point I'm making you show. And because of this, due to this, it results in convolution output being smaller than the original input image. Right? You're missing something, you lose something, right? So this is the biggest problem, right? Because your final output is not appropriate. So what we say, that's why we need padding. So I'll write with a different color altogether so that you can see. So we are saying that padding is used to address this. And Srini, hold on to your question. Let me complete the concept and then you can shoot me with all the question. And this is true for everybody. So just wait. Let me show you with examples. Padding is used to address this image. That's where I see you pinged me, then I lost the chain of thoughts. Padding is used to address this by adding, what do you add? Extra pixels at the border. Extra pixels, excuse me, usually zeros. So 0 means it's just the empty part, but it is there around the borders of the image. So this is more like, way of handling your image. It's image processing only, deep learning is all about image processing, right? So if I have to summarize what I've just mentioned, guys, what are the key reasons to use padding? I'll just write 2 bullet points because see, this is all theory, but in the interview, you can't go and, blabber this much. You will not get time. So you need some bullet points from me as a trainer because deep learning is something you have to be very objective. So number 1 reason, I would say preserve information at the edges. Agree? That's the whole job of padding. 1 bullet point. So basically we are saying that the moment you add, so now you will have something to slide over. So you preserve the information at that edges. Second thing is more on the structure of your output size. So now control the output size. And I think I need to expand a little bit on this. So what I'm trying to say here that I've already written on the top, it's just a reiteration. Padding allows you to control whether the output feature map has the same size as the input or if it shrinks. Now, before you jump to, jump to on this and ask me a lot of questions, let me give you some examples so that you understand what are the different types of padding, guys. Okay, so just hear me out. Let me complete this topic, types of padding. All right, let me keep moving on. So types of padding, guys, there are two types of padding, One is without padding. So that's actually not a type of padding, but it's like no padding or also called valid padding. This is the way they call it, so don't get confused. Valid padding, also called no padding. So what do we mean by this? We are saying that in valid padding, no padding is added to the images. So basically, you're not doing anything, right? But this is also a type of padding that you are not worried about. No padding added to the input image. So to understand it, let's take a formulation. So formula to do this, it's very easy. Formula for calculating output size with no padding or zero padding. And what is that? Output size equal to input size minus filter size by stride plus 1. I think this font is not good, so I'll change the color and make it dark. Okay, clear, guys? So this is how you have to read this. I think you already know what I mean by input size. So input size is what? So I'll write where. See, I keep writing this because I know people misses it all the time. People miss it all the time. So I'm just trying to be more vocal about it. Keep telling the same thing so that you start getting hang of it. But very good, Usha ma'am, you're right. Size of the input image, height or the width, right? Filter size is size of the filter or kernel. Stride is step size of the filter. Step size of the filter. I'm just revisiting this topic because I need it in the padding. Okay. So if I take an example, I have detailed it, Raj, a lot. So your question is already the heading in this. I don't know if you're there or not, but impact of input size on kernel or filter selection, right? So how do we decide the size of the image? Size of the stride and size of the filter. So it's all covered there. So example is very simple, guys. I'll take an input image 5 by 5. So it's a square, 5 pixel height, 5 pixel width. I'll take a filter size. So filter image is default one, 3 by 3. And I'll take stride equal to 1. Make sense, guys? I think easy. So what is the valid, what is the output size with valid padding, guys? You're not doing any padding and you're asking this question. So it is 5 input size minus filter size, 5 minus 3 by 1 plus 1. So I think it comes to 3 by 3. Because see, guys, feature map will be also square matrix. So it will be 3. Actually, it is, if you do the math, 3, which basically means size of the output is what? 3 by 3. Right? So always a square matrix. Now, can you observe, we started with what input image size? 5 by 5. That's the standard thing. And can you see here? So what is the observation? You tell me. So with valid padding, basically no padding. With valid padding, basically no padding. You're not doing any padding. The output feature map will be smaller. The output feature map will be smaller. God, sometimes my English. Output feature map is smaller than the input image. Those who are wondering what he has said, output feature map is 3 by 3. I'm writing here bold and clear. And input image is how much, guys? 5 into 5. Any confusion? So I'm writing with this highlighter because definitely you can see that. Now the question is that why the hell we are even studying that? So you have to tell us why. So yeah, I have a reason to that. So write a big note. Valid padding, which is basically no padding, when the primary goal is to reduce the size of the feature map. You want to do the downsampling for the big images, right? The whole idea is to reduce the size of the feature map. That can be a reason, right? So then you have to be ready. If you're trying to reduce the complexity and the computational power you want to use effectively, then you have to go ahead with the assumption that, dude, I will be losing some information on the border, but I am fine with it. Depends on the project, depends on the requirement. Agree? If you're not too much concerned about the borders of the images, why the hell you care about it, right? Yeah, it can be a use case. Agree or not, guys? Come on. But if you are worried about the borders, border does play a big role in your image processing or image classification, right? Now, so look at this, now, Srini, I answered that, right? So if you keep striding, where you will struggle? In the middle or in the end? The whole concept of padding is what? You keep striding from left to right. Look at this part now. I think you missed that point. The whole point is that it will finally go on. So that's why. So when I say edges, don't think edges. This is also an edges, huh? Edges can be on the face, also in the middle of the image. So don't confuse the word. Edges can be even here, right? Eye edges, nose, right? So don't worry about edges. I'm talking about boundaries. So don't say the word edges, right? It affects at the corner. Did I write anywhere edges? If I've written, then I have to change it. Hold on. Let me just go through. Boundary I have used everywhere. Did I use anywhere edges? I'm just being careful. Yeah, cover the pixels near the edges of the image. So look at the word. So it has a lot of meaning when I write, right? Edges of the image. I'm not saying edges in the image. So let me also write, when I say edges, I want to super clear on this, boundaries of the image. So even the right image also has edges, right? You can see this. So everybody just wait. I'll do this hands-on like I did it here, right? So we'll see that impact, okay? Don't worry. Shall we wait for that moment, guys? But I just explained valid. I've just done the without padding. Let me do the with padding. Same padding, also called zero padding. Please keep your terminologies clear, guys, as you move ahead. One padding I explained, valid padding. One is called same padding or zero padding. So what is it? I think you know the drill. So in same padding, can you see the word zero? It has some meaning, right? In same padding, the input image focus. So the input image is padded with zero around the border so that output feature map has the same spatial dimensions. I've already explained the word spatials. And that's, in simple English, same height and width. Same height and width as the input image. That's what we are saying. No shrinking. It's violet. Okay. I think one note is purple, right? Or that is also valid. Same spatial dimensions, right, as the input image. Clear? So there's a formula as well. Guys, come back on this. So there's a formula as well. Output size equal to input size by stride. Okay. You know that if you look at this formula in above formula, for what stride, it will be same input and output. That's right. It's a no-brainer. So I can write the output size is equal to input size, but there is a big condition here, but only for stride equal to 1. Those who are not able to understand what we are discussing here, put stride here 1, it will be same. But the moment you change the stride more than 1, 2 or 3 or 4, you are not going to get the same size. Agree or not? So then we need to calculate the padding. So to achieve, you know why we call same padding? Same padding as the input of the output as the input, same features in terms of dimension. That's the word got coined to achieve same padding. P is equal to, there's a formula, guys, F minus 1 by 2. Let me make it different color so that it's visible. Now, what is F? Sorry, what is P? P is the amount of padding to add. You need to calculate it. What is F? You know F, what is it? Is the filter size. So I'll just ask a simple question. For a filter size 3 by 3, how much padding is required? P is, come on, do the maths. 3 minus 1 by 2, so 2 by 2, so padding 1 is required. So what is the meaning of 1 here? It means, and understand this, guys, can't miss it. What do you mean by 1? What 1 padding means? It means that we need to add 1 pixel border of zeros around the image to ensure the output size remains same as the input. Remains the same as input size. But we need to test also, right? We need to test this. Example. So input image 5 by 5. Take the same example. Filter size 3 by 3. Stride 1. Now, what is the output size? It is, I've written here, input size by stride 1. So 5 by 1. So by 5 by 5. And you know that you need to do padding here. So basically, what is the top thing you have seen here? That you need to maintain the same size, right? So there are two things. I don't know if you paid attention here or not. You need to maintain what? Stride 1. If you start taking stride 2, then it will not work. Yes. So you understand? So you will not be able to downsample your image, also thinking about maintaining the input size. It's like you also want this or you also want that. You understand what I say? Okay. Now let me, I am going to show you two images with and without padding. Hold on, guys. I'm just opening my image repository. So how it will impact your image understanding, guys, that I can only tell you later, right? But let me show you a nice image and you will love it. Can you guys see this image? I think it should be up on the screen anytime. So firstly, I'll give credit to the guys who put together this. Definitely, they have done some analysis on top. Observe this. So I'm doing two things here. If you do, so obviously you don't need to see this part. Okay, maybe I don't want to show you the full image. So I'll just do undo, right? I want to show you with zero padding, okay? Because scaling is something I have not talked about it yet. But can you see when you do zero padding, what happens? Yeah, be it with padding. Do you get some real good insights? So you observe, right? You see a side border which is black. Zero is what? Black in our language, in our terminology, guys. Isn't it? Zero is what? Zero means what? Zero is black. Do you see a border of black? So when I'll go ahead, I'll also do some coding to show you the impact, and a lot of things will come, right? So I want to show you the whole funda of lost pixel, right? The heading itself is the lost pixels. And this happens without padding, okay? The heading is lost pixels. So I have a nice image to show you this. So why pixels are getting lost? Because of the, so whenever you are convolving an image with a filter is going to be applied upon sequential patches, right? Correct? Guys, yes or no? Hold on. So those who are struggling, right? Let me show you this. That's the only problem here. If you see this image, guys, right? Can you see this image, everybody? Yeah, I think you can see. So this gray box is what? This gray box is your filter, right? So you are moving around on this image like what? In what sequence? You go like this. I've done this a lot of time, guys, so I'm not going to repeat multiple times, but I'm just making a point. Isn't it? That's how we'll go. Observe this, no, guys, come on. With me so far on this, are you able to feel that how it will move on? Right? I have also given the animation videos as well, right? Now, why pixels are lost? So to see this, right, you have to come to this image. Now observe this. This is the same thing I was explaining earlier, but it is such a nicely done. So you will see it. So what you're doing here, a convolution filter falls out of the bounds when scanning over an image. So here you have an image of 6 by 6. Can you see that? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So image is of what size? 6 by 6. What is the filter size? I think you can see in this box. I'm highlighting so that you can count. It is 3 by 3, guys. Now see, if I move from here to here, when you come here, you have to stop here, right? So obviously you just have one. So see, if you follow me what I'm saying, guys, then you have taken this guy here. See, now see the beauty of, if you don't do the full task, understand me. See, this particular dot, just focus on this dot. Are you taking it 3 times? The first you took it here. The second you took it here. Can you observe it, guys? At least you're taking 2 times this dot in your correlation, in your snapshot. Are you able to see this? Can you observe this? Here you have taken this guy. Here you also have taken this guy, right? Are you with me? The moment you move out of here, you are not taking this anymore, right? True. Just focus on the corner. Just focus on this corner. Please observe. I want you to observe. So this guy comes only once here. And that's where we stop, right? Because we can't go outside. The moment, right? Because the moment you go outside, obviously we'll take care of this guy. You'll take care, but then where you will go here, right? See, if you're observing, this is a valid convolution. You have full overlap. It's a valid convolution, guys. You have a full overlap. Sorry. It's also valid. You have a full overlap. It's also valid. You have a full overlap. It's also valid. But the moment you go to the 5th and the 6th, it's invalid. Hello? Mathematically, I'm saying. You don't have the same range. It will throw an error in your algorithm. Understand, you need the proper matrices to be multiplied. Are you feeling it, guys? So you stop here. You stop here. Suppose you don't go beyond this. You said, Akash, I understand what you're saying, buddy. I'll not go beyond this. I'll just be here, right? So how many times you have taken this particular dot on the border? Only once. Now, this is what you say. You are losing some information, some complexity you're not able to understand fully if it's on the border. So what we have learned here, guys, let me write. So to illustrate, do you like this image, guys? And thanks to the people who have put together, I have not done it, but already I explained the concept. So I just keep using somebody else's diagram because I save time and my energy. So to illustrate, but you can give me credit to find it. Consider a 6 by 6 pixel image. So I'm just making that comment, the commentary here written upon by a 3 by 3 filter. As you can see above, the first 4 convolutions fall within the image to produce 4 pixels for the first row. Are you able to get it? So for the first row, see, if you do a maths, understand. For the first row, this will give you 1 pixel. This will give you another pixel. This will give you another pixel. This will give you a final pixel. Guys, don't forget the maths. Let me go up. I think you are able to. I don't know how to. You remember I was calculating the feature map? So see, for every calculation, see here, you get just 1 value for it. Hello, you remember that or not? For 1 overlap, you get 1 value. Agree or not, guys? That's what I'm saying. So for 1 movement of the filter on the image, you get 1 value. Everybody comfortable with the statement I've written here? So what I'm saying, let me go down. To produce 4 pixels for the first row, that's what you do first 4 on convolution. While that's why your image size is reducing, right? Even for slide 1, you will miss something. So while the 5th and the 6th instances fall out of bounds and hence ignored. So now, guys, you understand, no? If you have an image 6 by 6, filtered 3 by 3, see, guys, this is your image. This is your filter. So the feature map is what? It is going to be 6 minus 3 by 1 plus 1. How much is that, guys? 3 plus 1 equal to 4, means 4 by 4. Now you understand why does it come 4 by 4 nicely, guys? It's another way of looking at the same concept. You're reducing it because the fifth and the sixth fifth and the sixth pixel, they get ignored because of the way you are doing things. Everybody. So if you're ignoring something, right, definitely there are some information loss. Now, what is the implication of this? So see, to be honest, right, when you're looking at a large image, large means, ultra 4K, ultra HD image or HD image, right? It doesn't matter, right? Because you're just losing on the corner, right? You're not losing even 1%, it's 0.1%. Listen to me, right? But the problem is not here. Problem is on the smaller image where you have only 5 pixel or, where you only have very limited pixels, right? So I'll give you some maths because this is very important to understand. So hold on. If you don't understand this part, then you have not got it. So understand, if you're losing 2 rows and 2 columns, guys, you're losing it now. You might be thinking, what is writing? What gibberish is writing? Come on. Your feature map is, right? Feature map is what? It is 4 by 4. Come on. What is the image size? You started with, come on, 6 by 6. Are you not losing 2 rows and 2 columns? Observe, na? Row, column. So every statement of mine has some meaning. Okay. So losing 2 rows and 2 columns, you understand, no? Might not seem to have with large image. You might be asking why you are saying that. So I have a point. See, take a, some big image, ultra HD image, which is your 4K. Huh? What is the pixel of ultra HD image? You know that? I had written. I don't know. I'm just writing from memory. I think this is it. 2160. Or someone can confirm. 4K, right? 3840, 2160. If you just lose 2 rows here, what will happen? Do the maths now. 2 rows out of what? 3840. How much is that? So, or forget about, let's take a square matrix. So it's 2160. How much is that? Like equal, right? Into 100 if I do, how much is that? So it's not even 1%, guys, right? How much is that? 0.009 into 100 percentage, it is 0.009%. But not much, right, guys? Nothing is happening, right, guys? Come on, agree. So do you see any losses happening? Nothing here. But understand this, for ResNet architecture, it's the latest one in the market, right? For ResNet architecture, and that's who I'm talking about, 128. For ResNet architecture, which is 128, when I'll show you this architecture just for the sake of knowledge, it has how many convolutional layer? You know that? 50 convolutional layer. Can you believe it? And each layer of 3 by 3 size filter. Can you believe it? 50. Now take the same image, right? Here you think it's not making a lot of sense, right? No, it's not about the image. You are missing the point, Sandeep. In real world, you will not have only one layer. You will have multiple layers of convolutional and each having a filter size of 3 by 3. You understand what I mean? Where I'm going? So filter size is 3 by 3. Now for every 3 by 3, you are going to miss on what? Right? 2. Agree or not? Guys, come on, do the baby maths now. 50 convolution layer. One layer, how many rows you are missing? 2 rows of zeros, 2 columns of 0, correct? So the basic maths, unitary maths, 50 layers, how many will do it, guys? Do the math. So 2 into 50, 100 rows and 100 columns. Because this step will happen 50 times, you have to accommodate 50 times. You started with the image size, right? So here it doesn't make any sense looking here, but suddenly your image size will come down to from 3840 2160. This is the original image. And the feature map will reduce to what? Which is the extracted and the output image. I would say, sorry, output image. How many you have to reduce on rows? 100 and 100 in columns. So do the maths now. It is 3740 and 2060, guys. Come on. Is my mathematics correct, guys, here? It's simple. You understand? Just understand this. So now how much is the reduction factor? Do the maths again. So 3740 divided by, you started with 3840. How much is this? And you have to do 1 minus. Guys, what do you think? Now, do you see it has an impact of what? Into 100. So basically it is 2.6%, right? On one side. Then you also on the rows. So don't want to miss that also. You have to do this also. Don't think it is done. And 4% from here. So what do you guys think? How much is total loss? Total loss you have to take from rows and columns is a 2D image. 2.6 plus 4.63. How much is that, my dear? 7.23% loss is there. It is significant, guys. Almost round up to 8%, right? Are you feeling the beauty of this analysis? You were asking me, right? So 7% loss is good enough for a movie, for like a lossless information if we need. So definitely pixels are getting lost and I have quantified the loss. Are you seeing this analysis, guys? Someone can ask you this question in the interview that how much loss you will see. You understand the power of this analysis? Someone can ask for a resonate architecture 128, right? How much is the loss if you do this? I hope you are able to understand the impact of this discussion. Now you might be thinking, Akash, this is okay. Why are you so worried? So I'm not done. You remember, guys, I did the MNIST database. I hope you remember that. I did the digit handle on information, right? So in that, what was the image size? So journey is not complete. What is the image size? Come on. 28 by 28. Very good. MNIST database, remember? How many pixels? Okay. So 784 pixels, you know what? Even with a simple architecture, a very shallow architecture, I'm taking a CNN with just 4 convolutional layers. It's a very baby CNN. Agree? Guys, come on. 4 convolutional layer is okay now. I'm not saying 50, just 4 convolutional layer. Okay. So tell me one thing. With 4 convolutional layer, how many rows we will lose and how many columns we will lose? Do the maths quickly, guys. 4 into 2, 8. And columns, come on, guys. 8. Agree? So if you reduce this is the reduction. This is the lost pixels. Lost pixels. I'm using the same approach. So now your image size will come from where to where? Come on, do the maths. So it will come from 28 into 28, which was 784 pixels. And image size will reduce to what? 8 reduce. 20 into 20. How many is this? 400 pixels, right? Do you see the impact, body? Now you will thank me. Because now you make a lot of sense suddenly. See, these things you should be able to think on your own. That is my expectation. You should be able to quickly think into this. So look at this. How much you have reduced? So if you do the percentage, how much is the loss? So you have reduced from 784 to 400. And if I do into 100, how much is that? Almost 49%. Do you understand that 50% losing the information in an image which is just 28 by 28 is a big blow? Now you understand the importance of doing padding in that exercise. I rest my case here. Do you think losing pixel on the border? Because when I started, a lot of people were saying, just you're losing on the border, right? Why is having so much fuss about it? But this is where the discussion ends, right? That's why I say keep faith in me, keep supporting me. And so I started like a simple thing, but you might be thinking, what is writing, writing, writing? But suddenly you see that, oh, magic has happened. So magic is already no, it will happen, but you guys just lose the patience. And that is a common behavior because this behavior is important also. So don't think uh, I'm saying something wrong, but you also have to have faith when I say something. Good, but this discussion is yet to be over. Okay, you know me. So this discussion has yet a lot to be done. But this is another big concept. So if you recall or recap quickly, in this notes, I started with the image size, I started with the filter, then I talked about stride, and then I talked about padding. So if you see, right, I'm keep adding the complexity in the CNN, although without doing any CNN hands-on, to be honest, right? So this is the depth I have to provide to you as a good trainer. If I don't do it, I'm done. So if you understand, you have the feature map. How does feature map gets calculated with the stride and the image size? This formulation don't miss. Then I talked about a lot on the impact of this and that. Then I brought padding. Make sense? So guys, I want to show you some images, right? So I want to show you convolution with padding and without padding. Okay. So look at these images, guys. Do you see any difference? This is without padding, the cat image. And this is with padding. So on the left, you have the original image. What do you think, guys? Do you see some difference? If you are able to pay attention, you will see difference. So guys, look at the edge. Do you see any black dots? Any border here without padding? Just see there. Nothing. Just observe the borders. Come down. Do you see something dark is there on the border? I'm showing you this zooming in because unless until you zoom in, you will not see. Everybody, but you observe this. See, border. Now I will not miss it the moment I zoom out even. But in the hands-on, I will be able to show the striking difference by taking a use case. This is a large image. It's a cat image. So definitely, but this is how it will look like with padding and without padding. So the first image is without padding. And the second image is with padding. Unfortunately, I can't tell you more than this here because this is not the right place. When I'll do the hands-on, guys, I'll show you the impact of it, the implication. This is with padding. But only thing I want to show here, you guys, you can see the border. So I'll write, just observe the dark black border. This look like in PPT you do it, guys. If you're able to observe, that's what with padding. Okay. How is it going to help you? What is the implication in the prediction? All that, wait for the moment. Okay. Can I get back my original image? So it's not possible. Because once you've done the convolution, the whole point of doing convolution that you're going to lose information. Some information is definitely lost, right? So you can't get back to that. Doesn't matter. It's a non-reversible operation, right? Downsampling is non-reversible. And I think in electronics, they teach this, right? So in digital communication, right, which we are talking here, right, in terms of, this is digital, right? Talking over a Zoom is a digital. Talking through a smartphone is a digital communication. You know that, guys? So if I am, doing some calculations with respect to downsampling and making the data continuous to digital, right? Since we are talking and I'm from electronics background, so I can definitely talk. So this is like a continuous signal, right? How this is our voice looks like. But you take samples at equal interval and make it digital, right? Isn't it, guys? You can't ever go back. Make sense? It's irreversible. I would love to talk more on this, but I don't want to make this like a communication system course. I used to teach for GATE a lot of years. I did that, but I don't want to, confuse you guys here because it's not, how to say, it's not a lot of our, a lot of things are related, but we'll not go in that direction. So I'll move on to the next thing, guys. So we have done the convolution layer. I think I have covered a lot of things. So I think we are good here. The next layer is known as in the structure. So activation layer. I think in general, we are going to use ReLU. What is ReLU? Who remembers? What is ReLU? Rectified linear unit, right? So I'll just write one line because I have already talked about it. Most commonly used. So it is one of the most activation functions, most commonly used activation function. My pen is misbehaving. In CNN is rectified linear unit. Go back to my lecture. I've explained this a lot. By the way, mathematically, remember how did we define this, guys? It was ReLU is what? X equal to max of 0, x. So either you will keep it positive, minimum 0, maximum it can be x. So remember what it does, just to give you a refresher, ReLU sets all negative values to 0. That's the job it does, isn't it, guys? Sets all negative values to 0 and keeps positive values unchanged. And it helps us helping to prevent issues like vanishing gradient. I have also talked about it. So if you're trying to recall, remember that all the negative pixel values were set to 0 and while positive value remained the same. Remember that? That's your activation layer. The next layer is also important, and that is called pooling layer, also known as subsampling. This is something we'll detail out. Subsampling. What is pooling layer? So pooling layer is used to reduce the spatial dimension. So if someone is writing, you want to reduce it further. So you're right about it. Anything reducing the spatial dimension, if you're writing, it is correct. So height and the width of the feature maps. So this is like the next step. Why you do it? Because it helps you to control computational cost because you're reducing the pixels, prevents overfitting. So pooling is like a small window which operates on the feature map and aggregates the information. It can do minimum, maximum, average. There are different types of pooling. So let's talk about it. So how does pooling work? We're yet to answer that. So see, pooling operates on a small window like 2 by 2. Generally, we use 2 by 2 and aggregates. So I generally take this pooling concept like carpool, guys. Those who are living in a same society or similar area, they do this carpooling. What you do, guys? Isn't it you reduce the complexity of the traffic by carpooling? So aggregates information from these windows by either selecting the, and that is up to us now, the maximum values, maximum value. So maximum value, if you select, guys, it becomes max pool, right? Max pooling, or the average value, and that becomes, tell me, mean or average pooling. So I'll show you with an example, else it will not be very clear for you guys. It's the same example, you have seen it. I have been doing it earlier. See this image? This is something you are aware of it, so don't say no. Oh, sorry. So guys, this is the image. And in this image, I'm going to apply a filter which looks like this. Correct? This is my filter. So this is your input image, 6 by 6. This is your filter, 3 by 3. And this is your filter or kernel. And what are the output is coming out of it? It goes to the bias of -2. Remember that I had told you. And finally, you have a feature map, right? Then it goes through the ReLU operation. I'm showing the whole. So it goes through the ReLU operation, something like this. Not this. Why the wrong image is getting called? Yeah, this image. So it goes through the ReLU operation, guys. Now tell me what will happen after the ReLU. Your feature will look like this with the max pooling. See this. Now this is amazing. And thanks to the guy who had put together. So observe, and you can validate this later also. You're starting with an image 6 by 6. Finally, you do 3 by 3. So what should be the feature map size? 4 by 4. You know this. How do you know this? You know the formula 6 f minus this 3 by stride 1 plus 1. How much is that? Do the maths. So it comes 4, so it's going to be 4 by 4. Hello, yes or no? Follow the formula I have given in the last class. Then you get this. Negative becomes all 0. So I'll highlight the negatives. This is all negative. Oh my God, this is all negative. See? Okay. Now what feature map we are doing after post-ReLU? We are applying this max pooling. So you are taking a 2 by 2 thing and taking the max there. So what is max? See, in this, what is the max value you are seeing? 1. Then, right, you move to the next. So 0, next, 0, and the next. So can you see this, guy? So basically, you are able to reduce the feature map from 4 by 4 to a 2 by 2 matrix, guys. Can you observe this? This is called max pooling. Now, you can also have, average pooling. But let's understand what is the importance of pooling. Why do we do pooling? We answer that it reduces the spatial dimension, helps you to reduce the computational cost. How does it help in, so question is, how does pooling help in overfitting? What do you think, guys? If you're paying attention, you're able to answer this question. So I know it helps you to understand overfitting very well and avoid it. But why? By the way, what is overfitting? Let's do a quick check. So overfitting, okay, let me good in training, bad in big hand for path. So the true overfitting means you can say that. So I'll write overfitting occurs when a model learns to perform very well on the training data but fails to generalize to unseen test data. Correct, no, guys? This is overfitting, no? So very good accuracy on the training, but the moment it comes to the test, it fails, right? I thought I should write here. Correct? This is important. But how does pooling help you here, right? So tell me, everybody agrees, number 1 point, pooling helps with overfitting. We just answer that. As it reduces the spatial dimensions, we also told this to you guys, the spatial dimensions of the feature maps, right? But how does it help you with overfitting? If you have less dimension, right? Basically, it means what? The number of parameters will reduce, no, guys? Come on. Think in terms of neural network. The number of parameters and computations in the network is reduced. So now your model will fail to do a lot of learning. It will not try to learn everything. That's where the overfitting happens, right? If you are training a lot, I think Usha ma'am, somebody mentioned that, you're training a lot means you're training on a lot of parameters. It means that you are not going to get a very good result because you're over-training, you're over-memorizing over-memorizing this whole thing. So what I'm trying to say, just try to connect the dots and listen to me. Fewer parameters mean the model is less likely to memorize the training data. Memorize nahi karna hai, right? You can't remember everything. That's the reason that people are not able to. I'll take a very simple example. If you're trying to learn science, right? If you're memorizing things, it will still work to an extent. Science as in like biology and all. Idea is not to memorize anything, but if you memorize mathematics and the new question comes, but the concept remains the same, are you able to go and solve it successfully? Think like a kid. That's the issue when the learning is wrong, right? That's what I'm trying to avoid here. If I keep telling all those bullet points on any topic, you memorize, you don't understand. So when the next time someone is asking you, you're not able to apply the knowledge you are acquiring in this class. Agree? Same is with the modeling, right? See, what we are learning here is as good as what we are trying to do it in the model also. So fewer parameters mean model is less likely to memorize the training data. Do we need model to memorize things? No. We want model to understand things. And if you are doing this, that it is not going to learn everything, means it will not store a lot of information on those parameters. Model is going to be, that's a sign that model is going to be not be overfit. So less likely means, my dear, that model less likely to be overfit. So this is a very good argument that, oh, you know what? Pooling helps you to do. Pooling helps the model with overfitting. Model prevents overfitting because of this. But if someone asks, can you explain this? Then you have to talk like this. Makes sense, guys? I'll tell a very simple example and you will understand what I mean. Suppose I take the example, guys. Suppose you have 32 by 32 image size. Let's say this is your feature map. Obviously, would have come through the convolution. Now, after applying a 2 by 2, after applying a 2 by 2 max pooling with stride 2, then what will happen, guys? Any idea? What will be the end? What will the end outcome? So here the formula is output size. Maybe I'll write the formula in something different, bold. Output size is equal to input size minus filter size plus 2 into padding. Now this has everything, guys, by stride and plus 1. You have seen me writing this formula, but this is a more improvised version of it. Okay. So now let's take the example. In this, we already know. So let's take a very simple example. 32 is the input size. Let's say filter is 3 by 3 plus no padding divided by stride 2 plus 1. How much is this? Guys, do the maths. So I'm saying that we are taking with stride 2. So how much is that? So it is 29 by 2 plus 1. How much it is coming? For 16 it's coming approximately if you do the maths, guys, right? Right, guys? Are you? Yeah, 14.5 plus 1, which is approximately 15 plus 1, 16. Getting this formulation working for you guys? Makes sense, no? So what is the output size you're getting? 16 by 16. Don't worry, I have a very good cheat sheet for formula, all the formula I'll share with you. So generally, yeah, that's a sum rule. You can do half of the input. Very good, Usha ma'am. So if you're doing half of the input, what is the meaning of it? So meaning is that you are reducing the spatial dimension. Understand this, no? You started with 32 into 32 and you are moved to what? 16 into 16. Don't worry about it. All right. So you have done this max pooling with stride 2. So don't miss it. Right? So how much is the reduction you have done? So do the math. 16 by 16. Divide 32 by 32. You know that 2 into 2, so 4 times, not 50%. That's where you guys miss the concept. 4 times is what? You are doing half in 1. So 4 times. Is it 4 times is 50%, guys? So what is the observation here? Observation is very simple. So after doing max pooling with stride 2, spatial resolution of the feature map, I'm just making the comment here, reduces by 4 times, meaning, what does it mean? Meaning the following layers, the layers after this, have to process much smaller inputs, reducing the overall complexity of the network. And you know that if a model is less complicated, less complex, it is less overfit. You agree, no? Remember when I don't know, did I teach you the machine learning part or not? But if you pay attention and understand what I'm saying, if the model is less complicated overall, you are going to have less problem in the model with respect to overfitting. So in different ways, I'm reaching to the same point. Fewer parameters, less complications, all indicate a better model fit. Now also understand, pooling also helps you with one more thing, and that is with respect to image. So I have to give you that point. So this is note number 1. I have note number 2 also with respect to pooling only. So let me write pooling layers, and generally we use max pooling. So I'll write particularly max pooling help the model, and this I will only able to show you on in the hands-on, guys. So you can mark a note. Akash mentioned that here it will show on the hands-on because I need to show that in live. On the most important or prominent, both are the same words, features within a feature map. So not everything is important, right, in an image within a feature map. So max pooling helps you to zoom on the important thing, ignoring the unimportant thing. Generally, what are the important things in a feature map is your edges or the textures. You remember the dog image, guys, the dog image. So you are going to pay more attention to the edges or the texture of the image, not on the edge of the image, within the image edges or texture. So what I'm saying that by selecting the maximum value within that window, remember that window? I'll show you, I'll go up, let me complete. By selecting the maximum value within a pooling window, the neural network becomes less sensitive to small variation, which is your noise in the image, in the input in this. So until unless it is not a big feature change, it will not capture. You understand what I'm saying? I'll show you what I mean. So dominant feature it will capture, right? It will not take the redundant features, redundant images quality, right? So end of the day, it's a very big thing, right? Don't take it lightly. It's a very, very important thing that an image after max pooling becomes very choosy, okay? But I can only show you this with some images, else there's no point I can show you here. But I can definitely show you some images that after the pooling, what happens, you know, you will love it. But expect that I will be doing these things. Guys, can you observe? It doesn't mean that I like cats. Generally, people are doing tests on the cats. So in the lab, people use rats. Here, they are using cats. So I don't like cats at all. I love dogs, but the images source is like this, so I can't have a say on it. Okay. So those who love cats, enjoy. Isn't it? So guys, if you see, so what I'm showing you, let me also explain what I'm showing you. So I'm, trying to, show a few things and just observe it first. So, and I'll do all this coding to bring it up. So don't worry about that part. So what I'm saying, guys, so if you see the difference in the images as it goes far and far, right? Can you see it's being done max pooling 4 times? If you are smart, you would have find it. So starting from here, look at this. Are you seeing going half? Let's do the rough maths, 200, 200. Then again, you're going half, do a rough maths, 100, 100. Again, you're going half. Okay, those who are able to notice it, right? Big hand. First, let me give you the big hand, if you notice it. So these are all impacts of pooling. What is that pooling? Max pooling. Okay, now, do you see that as you go, yeah, so you have done it 4 times. Definitely, you have reduced the image quality to a great extent. But are you able to see that it focuses more on the edges? I'll show you how. For that, I have to go bigger. So after the first pooling, right, if you pay attention, and I need your full attention, edges are not getting lost. So I'll show you how. So if you focus on this part, I'll delete it. Focus on this part of the ear lobes, right? Even with this, you are there, right? You're capturing it. When you've done the first time pooling, come down. Even here, you're able to capture this, that it looks like the ear. Yes, come on. Can you also see that, right? That this part is also intact. See this. You're able to see this. Don't lie. You're able to see this or not, guys. Come on. Although you have done pooling to like a 1/4, you have come, right? 400 to 100 is like what? 1/4, you have reduced it. Come here also and don't lie again, because this is where you have to realize what I'm saying. Are you able to see that there is something is going on here, guys? Don't think I'm trying to connect the dots. Just observe and tell me. But definitely you are losing a lot, right? Means you're not having, so if I zoom out, still you can see that it looks like a cat, right? You're not losing, because when I say go up, like you see it's all bloody. Akash, I don't understand, but don't worry about it. If you go out of the zoom, you can clearly see, and don't lie again, that this part of the eyes are still able to capture it, which I highlighted. Yeah, it's not clear, but look at the kind of max pooling has done. It's not clear, but at least it's not like that you don't understand where are the ears. Forget about this. Just see this image. Just see this image. You can't tell that is it a cat, or forget about it's a cat or not. Can you see that? At least you have an idea that at this size that, these are the ears. Don't lie that. Ears are clear. I'm just making that point. Rest, everything is very cluttered because it doesn't pay attention to this, because there is no information, right? It's redundant, right? If you come to the pixel level, what is the difference between this pixel? Listen to me. This pixel and this pixel. Do you see any edge? No, I don't see any edge. It's just the fur. It's uniformly distributed, so I don't see. Guys, agree or not? But you can clearly differentiate from this to this part. Are you feeling what I'm trying to highlight here, guys? Understand what I mean when I say edges in the image. There is an edge. There is a clear edge here. And that's how our faces are designed like that, right? but you can't differentiate much between these three pixels. It's bigger than pixel, by the way. Okay, I'll come down. Now, I'll also show you an image which is now making more grayscale and only focusing on the edges. Look at this beauty. It's the same image, slightly done differently. But can you see, edges are coming so nice. I hope you're able to see. The edges I talked about, guys. Can you see it? Even in this, you have some vague idea. So now if you pay attention that finally, right, finally you are seeing only the edges. It keeps removing the extra information. Like in this image, sorry guys, in this image, if you see, it's also giving you these edges. See there. In later, still it is preserving this, right? This part of it. In the third one, it is still there. This part is there. In the fourth one, it's almost gone. See, almost gone. That clarity is gone. It's focusing more. It's just focusing more on the edges. But yeah, don't worry. I'll come back on this again at the right time. But you got the idea or not? That's the whole point I'm making. I'm not teaching you the padding and the importance. Not everything hands-on here. This is not the hands-on. This is the hands-on output. Hands-on will be done in front of you guys live. Make sense? This is what we call pooling. Everybody's clear with pooling? Okay, so I talked about max pooling, but there is also called average pooling. So where are the use cases? So I'll just write one. Average pooling use cases. See, max pooling. So max pooling definitely picks in that range the max value, but when used, so I'm going to write that. It is often used application area because it tends to, so this is more popular, by the way. It tends to retain the most important features. That's the reason. So whenever you want to just focus on retaining the most important feature and remove the redundant features in the image, you go for a max pooling. Okay. While average pooling, which is like taking in the window the average of the values in the feature map, it is used in the cases where smoothness or overall representation is more important than retaining high intensity features. So I'll also show you that in the hands-on, both the pooling, so that you know the difference. Hold on, guys. I'm showing one image and you will like it. It's a colorful image. You will love it. Not only like it. Guys, can you see this image? Maybe I'll show a bigger image. So I'll do a lot of detailing out later. This is perfect. Okay. In this, the bonus is that I'm also showing you the min pooling. Now, the moment you see this image, you'll understand what I'm saying. Can you see, and you have to go closer. Can you forget about anything else? The moment I zoom in, you'll say, Akash, I got it. Can you see it focuses more on the edges? This max pooling, right? So focus on the edges. See this. Observe this, no? Edges it picks. See? Okay. I'll come to the average pooling. This is like applying a filter on your face, right? Instagram filter. It smoothens out. It doesn't give you a lot of, see, it doesn't pick the edges. Look at the colorful. See, there are a lot of edges are there, right? A lot of edges are there showing the beauty of the flower. This guy is trying to pick it. Can you see these white dots, my dear? This is trying to picking it up. But the moment you go to the, why I'm showing you the zoom in, so that you can understand the difference. The moment I go into the average, it's like a paintbrush job. Like I'll make it everything uniform. It's like a plain face. Hello, making sense? Okay. So this is what my point. But are you getting the hang of these details, my dear? So funny what I'm saying, right? Average is making your image much more smoothing effect, right? That's the word I've written now. If I go back to my OneNote, am I not saying that it is going to smoothen the overall image? It doesn't pick the edges. I know you might be thinking, Akash, there is an edge now. Why you are saying there's no edge? You're thinking about this as the edge? No. This is just the pattern of the petals. Edge is like this. Observe the difference. See, it's showing those rig images, right? That zigzag thing. It is trying to pick that zigzag thing, guys. Observe this. Right? It's trying to pick that zigzag thing, right? It doesn't smoothen out. Here, it gives a very nice shape going like this. You understand, funny? So what I'm saying, average pooling is going to, average is like average only, na? And look at the statement also, right? If you want to find the topper in the class, isn't it not you're like going to highlight it? I always take this example. Suppose in my class, and you have seen me doing this in statistics also, if you have been taught by me statistics, see, so in my class, there are a lot of people, as in this class also, right? Deep learning class. Now, the moment I want to find the max in my deep learning class, I said, this is the guy, right? Isn't it? This is like saying the max. How I am saying the max is like the max performance delivered in interaction, right? Let's take anybody, Srini, for example. So are you not highlighting a guy here? Come on, think about it. This is, again, copyright me. Nobody will explain pooling with this example of a class. Think like Mr. Srini is the topper in deep learning. So his marks is going to be the max, right? Top of the class. But the moment I say average, isn't it? I'm saying smoothing out the marks of the performance. I'm saying on an average, so I'm highlighting everybody. See the brilliant example I've given. Smoothing out the performance. So smoothing means if someone is getting higher, someone is getting lower, I'm going to average it out, right? So performance is going to be averaged out. Both the performances as in good, bad, top-notch, worse. Everything is going to be averaged out. This is how the beauty of statistics is, right? So that's what is being done. You are not highlighting anybody. You're saying everybody is important here. So this is everybody. And here you're saying I will highlight some. So I explained this with the concept of statistics, and you're doing statistics only, no? You're taking max, you're taking average, you're taking min, right?
Just a quick info, guys. IntelliPath offers artificial intelligence course training, which will enable you to learn skills like neural networks, focusing on CNNs, RNNs, and their application in AI, natural language processing, computer vision, and generative AI. Through this course, you will also master deep learning concepts, AI model building with TensorFlow, transformers, BERT, GPT, LangChain, and NLP pipelines with advanced techniques like image recognition, chatbot development, and much more, all taught by top 1% experts and IIT faculty. And with this course, we have already helped thousands of professionals make successful career transitions in AI and data science. You can check out the testimonials on our Achievers channel. The link is in the description below. And without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take your first step towards the dream career growth in the field of artificial intelligence.
So guys, I'll talk about CNN a little bit more, and then I'll get into the hands-on. I think my focus will be on more on hands-on and try to, complete some outstanding thing from the hands-on point of view. Okay, so I hope you guys are prepared for it, right? So the lost pixel concept I was talking about. Okay, so the lost pixel generally happens, right, when you are not having any padding there. So that was one concept which just we discussed. Then I was talking about the pooling thing. So that also something I covered already. All right. So what I'm trying to say, you're only thinking from like a big company and trying to justify this, but think about normal users like us, right? Do you think your machine is smart enough? Your machine is smart enough to do things like, running a big object detection project? No, I don't think it's the reality. So it's not that, right? So that's why when we talk about these concepts, we are talking about a general machine configuration which the mass uses, right? Not the other way around. But you're right, means you can have some machines which are powerful, but not, trust me, I use a lot of the biggest machine. So currently the machine I'm using in my project is having, how much RAM? 664 GB RAM. I know how many workers are there, like CPUs, threads, 1024 CPU threads. And still sometime it doesn't work. Can you believe me? 664 GB RAM I'm using on a server. So, and I'm the only user. It's not like it's spread around multiple things. So yeah, means I know what you mean. Guys, this is just to show you the recapping the padding once more in a different way. So you can see, right, this is your original image of size 1, right? So if you see this here, pixel utilization for convolution of size 1 by 1, 2 by 2, and 3 by 3 respectively. So if you guys observe this, right, you have, so if you look at 1 by 1, which is basically 1 in the row, right? 1 is like what? 1 by 1 size is what? This is just 1 pixel. Can you see this? So this is just one pixel, like 1 by 1, right? 2 by 2 is what? You have, right? This is a bit confusing diagram. I think I should rather not use it because you will get confused. Hold on. I think I should take a different diagram altogether. So see this diagram. Is it visual, guys? So now I think this is much better, right? I hope you also like it. So this is an input image. What is the size of the input image? It is 3 by 3. What you observe, can you see that you have done a padding of 1? So basically you have added how many columns? Added 2 0 columns. Can I say that? Right. And similarly, you have added how many rows? You have added 2 rows. Look at this along this line. So you have added 2 rows. So added 2 0 rows. So this visual help you to understand your input size from 3 to 3. It has gone. Can you see that, guys? 5 by 5. And this is something I was telling you yesterday. But definitely, if you're adding 2 rows here, if you're adding 2 rows, it will happen. It's bound to happen. Similarly, if you add 2 columns, it is bound to happen. Do I make sense, guys? So this is what padding looks like. 0 padding. Okay. So guys, without wasting much time on this, right? I want to get into hands-on. Are you guys also ready for it? Because now this is good if we get into hands-on rather than doing this whole thing again and again and again, because there's no point anymore, right? So if you are ready or comfortable, I know you might feel some difficulties here and there, but that's fine. I will handle it. Don't worry about it. This is the image we are going to plan. Can you see it? So let's name this as CNN hands-on convolution. I will change this image later as well because I need the real source of the image. Convolution neural network. This is one of the famous images for CNN discussion. Okay, so this is the lady we are going to investigate today. Investigate as an image processing, nothing, don't get me wrong. Okay, so and we will start thinking. Well, I think this is what image? It's a colorful image, right? Can you observe? Okay, guys. So first I'll show you the use of filters. Okay, so different types of filters will have different types of roles. So first thing first, this is a colorful image, right? So we need to convert this image into what? A grayscale image. Generally, we do that now. So how we will convert this image into a grayscale? OpenCV library. Okay, so let me take it. So the first step. So guys, we need to convert colorful image to grayscale using PIL. That's one option. Or you can also use OpenCV, or you can use also Matplotlib. So these are the options. What are these, guys, my dear? Either you can use one of these libraries. These are libraries, no? Using one of the libraries, I missed right. Which I prefer the most is your, right? So we can focus this PIL import image. I think Matplotlib I have already there, na? PIL import image. So it's there. You don't need to do it. So to convert the image to grayscale, so the function is image underscore, you can say gray, and you can say image. I think I'm calling it image, right? img dot convert, and this is the code L. Okay, and then you can show the grayscale image. Okay, so you can do plt dot im show image underscore gray. Okay, cmap equal to, that's your color map. Remember, I had done this earlier also. And plt dot axis, we can switch off the axis up to us, and plt dot show. I hope it works. See, it's the same image. You can show the axis as well, but for now, just focus on this. And this is, or either you can use PIL or OpenCV along with Matplotlib. Matplotlib to chahiye apne ko, right? So that's the difference. Are we good, guys? Now, if you want to understand this part of the code, the most important thing is this. What is this? This is the code for converting the image to the grayscale. This is where you convert the image to grayscale. And here, more or less, you're printing it. But is this the pixelated form of the image? No, we'll come to that later. It's not the pixelated form. Do you see any pixel here? No, right? So far with me, this is not the pixelated form of the image. This is a fine image. It's talking about using OpenCV. You can also do. So now I just search the documentation because obviously not everything is on my top of my head. So I know L represents here. Now I can recall. I just search my document. L represents, the meaning of L is luminance. See, I generally don't go just blabber things. So luminance is for grayscale image. And grayscale image is like as good as calling it single channel. So if you remember single channel, 3 channels like RGB, I have talked about it. I also mentioned earlier that each pixel, just refreshing your memory, guys, If you recall, each pixel can take the value is a shade of gray ranging from 0, which is black. Remember that I have taught you in very detailed manner, 255, which is white. Now I'll do the same using OpenCV. So I'll say image underscore gray OpenCV. So I'll just call CV equal to. So the library says CV2 CVT color. I hope it works. I'm doing that only, no? CV2 dot CV2 CVT color image and CV2 color BG. That's why I did not use it. You know why? Look at the syntax complexity. Even if you try to remember, you can't remember this. Then take this part of the whole thing. I think we have to import CV2. I have not done it. That's why it's showing all. So import CV2. I hope I don't need to install image gray underscore CV, CV2, CVT color, IMG. That's the name of the image, right? CV2 dot color. I'm just thinking BGR to gray. Let me try this. Import CVT works, right? There's no problem. So what is this error? Source is not a numpy array. Is it expecting a numpy array? Interesting. Yeah, image is not my numpy array, guys. So need to convert this to a numpy array. I understand now what's happening. So guys, what's happening now? You understand what's happening, guys? This image is not a numpy array, no? So what is the type of the image? So what we have to do? No, it's fine. I think we can handle it here. Don't worry about it. We need to, so it's a PIL image, right? So we need to convert this PIL image to a grayscale image to a numpy array first. Numpy or numpy array. So you can say image underscore numpy. Let's try this. But can you see that for a simple task, it's killing us. Now we can use this. Hopefully it should work. Import numpy as np. Yes. Okay. So not that disappointing. Guys, makes sense? If I just zoom out, do you see any much difference, guys? In both the images, there's nothing, right? Not even an iota of difference. Good, so far with me. So this is the grayscale. Now, if I ask you to show as pixels, how will you do it? There's all types of data processing in here. Think like that. So whenever you have to show an image in a pixelated form, you need to reduce the resolution, right? So number one step, what is the concept? Understand the concept also, no? Just doing this task is not enough. So whenever you want to do pixelated, means you are zooming in. So, so idea is to display pixelated version of a grayscale image. How would you do it, guys? You reduce the resolution of the image, okay, and then scale it back up. Scale it back up. Now there are two steps. So basically, guys, I'm saying there are two steps. Step number one, resize down the image. Basically, I mean to say lower resolution. Okay, see. Second step I'm telling is resize up to the original image size, keeping the low resolution. Now you have done this in your phone, right? When you go beyond a size, your pixel starts coming, guys. Have you seen it? Zoom in and zoom in, you will see this. So we already have this image. Now we can use any one of it. So I'll use this one, guys. So I already have this image. I'll do the step one and I'll say small underscore image, means I'm resizing down, and I'll use the function resize, resample image. Now the moment I write this syntax, for you it is like alien because you have never seen this. Okay. So this is the first step. Second step. So now I'll say pixelated image, which is small image dot resize image dot gray dot size image dot nearest. See, image dot underscore gray, because our name of the image is what, guys? Our name of the image is, don't miss that, image underscore gray. So I'm just using that, right? So image underscore gray dot resize to 1616, then going back to the same size. I think this should work. So guys, what I've done here in the first step, I'm resize to a small size, okay? And for example, I'm doing this 16 by 16 pixels. Means total 256 cells will be there, right? 16 just 16 is how much? 256 only, no? And now I'm saying resize back to the original size. Let's what happen. Oh, it ran. So no error. Thank you. Now we will display this image. So we will show the image, display the pixelated image. So I'll say the same thing. I'll not waste your time, guys. So I'll copy this. Okay. I hope you don't write. So I'll say you come dude here. CMAP is gray. You can say on. See? Interesting, no? Guys, 500 by 500, right? This is what it shows. But so I'll also show you both the images so that you don't get confused, right? First, I'll show you the small image and then the resize image so that you understand what's happening, right? So this is a tiny image, 16 by 16 pixel, guys. Can you count on your finger that this is 16 by 16? Just understand this, right? And then I went back to the original image size. What is it? That is 500 by 500. You are not able to see what is the original image size because I had hidden the axis. Let me show you. You can see, right? Is it 500 by 500 original image size? Just understand the flow. I'll explain everything, right? So guys, when you look at this, I know to you it doesn't seem anything. So let's play with this, right? At least do 32 by 32. Let's see what's the difference. It is going to be interesting. Just observe. Now you feel something is happening nice. Now close your eyes, Priyank. You will see it. Now you will see Miss. Who is this person? Sorry, Len, right? Who is this person? Lena Forsen, right? It is one of the prominent image in the image processing field. That's why I took it. Okay, let's do some magic here. So this is 30 by 32. Go little far. Still, you are not going and taking a lot of pixel. Out of 25,000 pixel, guys, you are doing only 64 by 64. Now, I think you can see clearly that she's Lena, right? Are you feeling the beauty, guys? I'm showing you something here, right? Can you see the sharp edges and all in this image? Observe. It is downsampled image, but look at the beauty. This is what we are trying to do here in this class. Okay. Okay, cool. So now, guys, I think you got the idea, right? Now I'll run the resized image. So this is still, see, what I'm trying to do, you need to understand this image I'm taking and zooming in. That's what we call resizing. That's what you see here. Can you see this? So what's happening? You are extrapolating this small resized image to the again back to, but zooming in. You're not improving the quality of the image. Understand? So the image quality does not improve. You're just retaining the image size. Can you see this, guys? Okay, makes sense. So why pixelation is important? Number one, it helps you with the overfitting. Number two, it reduces the computational side of the story, make the thing, little more efficient. Now I'll explain that what we have done step by step. So let's understand the code. I think code is not very tough, right, guys? If you see the code, right, there is a command I'm using for resampling, and that is known as image.nearest. So what it does, guys, understand, it says that resampling method that, when you say image.nearest, it means that it ensures that no new pixels are interpolated. Basically, which means that it preserves the blocking pixelated look. That's the documentation saying, right? But what is the meaning of this resampling technique? It is a technique being used in this library, right? What is the requirement or what is the need for this? Okay. So if you take any of your images, right? Understand, guys, you have done it in your school days or when you are trying to make a passport, you take a good photo of yours, a big photo of yours, and don't you resize it to a smaller size? Just try to recall that. Take a big good photo from a camera and they make a passport size photo. You know what is a passport size photo looks like? It's very tiny. This is a passport size photo, my dear. I'll go to a new tab because I don't want to show some random people. They can sue us, but I'm just saying no disclaimer. This is just to show the passport size photo, right? Obviously, if you zoom in, right, it's a small image. After some time, it's a very good image. That's why it's not getting pixelated. But if you go and take any image which is small in size, and if you increase the zooming in, it starts showing the pixelated thing. Have you seen it or not, guys? Okay, so that's how the pixelated thing is coming. Now understand this, guys, this part of the code. So this this is the most important thing you see here, right? Resample image.nearest. What is the meaning of this? So it is one of the sampling technique, I would say simplest resampling method, which stands for nearest neighbor interpolation. Nearest neighbor, NEIGHBOR. Okay, interpolation. Now, guys, this is fully mathematical. I don't want to go this, but this is the technique you are helping you to shrink the image. So using this technique, image is getting shrink, which is basically resizing, reducing the image size. That's what I mean when I say. I would suggest don't go too much into the depth of it, because this technique is a mathematical technique. You don't need to really go and understand the maths behind it, but it does help you to do it. Right? Same thing you do here again, but this time it's more like you're using this technique to decide the size of the image, but size you have to tell you. Here we are not telling any size because we want to go to the original size, right? This is the original size, which is 500 by 500. So first I am reducing the resizing to a small size and then resize back to the original size. These are the two steps. Are we clear on this? It's a very simple 2 blocks of the code. And then I have used 2 blocks to just to plot the pixelated image, right? Exactly. Now the good thing is that you can take it and you can print this guy also. We already know the image size is 64 by 64, but or you can print on the top. Be smart. So you can print. No, generally who prints the image size on the top here? Okay, sorry. Let's print on the bottom. So now you have to just change this to this, and your job is done. It's the same code block. See, 64 by 64. Isn't it? We are saying that I will create a small image 64 by 64 pixel. Now it gives you a lot of confidence when I do these things, right? I know, understand, Usha ma'am. So when I show you this, you understand, okay, now it makes all the sense what he is saying. Why do we do it for now? Obviously, I answered that. I think you missed it. But we are reducing the image resolution to do a downsampling. And downsampling, the biggest purpose is to focus on the key things, right? The details only, and try to reduce the other stuff. But there's a lot to it, right? So the main result is to remove the fine details and compression of the image. Why do that? So that you can handle it computationally. That is the answer for reducing the image size. Clear? Now the second thing which we did, buddy, that increase the image size back to the same. So we did it so that we want to preserve the pixelated look while maintaining the image size. That's more like a requirement we do it. Okay, we want to show the pixelation effect, but in a good image size. Because see, although both the images look the same, but there is definitely a lot of size difference. One is 64 by 64. So just understand. So actually you started the whole discussion with this image, right? You started the discussion with this image, right? Which is like 474. And while talking to me, you reduce it to like what? 64 by 64. So let's say this is 200. This is 100. So you are like, you know what? You are looking at just this part of the image. Trust me, this is the image. Here you are not able to make out because it is showing the same big size. But reality is not this, na? If you see the big canvas, right? You are somewhere here only, na? So like this is 60 because this is 200 because this is 100. Agree with me, guys? This is the only image you are seeing. So to show the pixelation, you need to zoom in. To show the pixelation, you need to zoom in this image. Zoom in means bada karna, not zoom out. So please pay attention. So I want to zoom in this image so that it becomes bigger of the same size. Automatically, we see a lot of pixels now. Come on, understand or not? Agree? So this whole step we do to bring the pixelation effect, right? So I can write it here. This is your pixelated image. I think I have written also, no? Oh, I have not given any title. He will kill me later. Okay, hold on. plt.title, reduced low resolution image. That's the right word. Low resolution image. Guys, are you able to see this? Suppose I have written something. By the way, let's see your basics are strong or not. So if you see, this is coming nice, this pixelated image coming nice, but what is happening on the top? Why it's coming low resolution like a blank? Let's see your basic matplotlib how it is. It's a question for everybody. I can show you the code. What's wrong there? I made a mistake. I'm telling myself. It is outside the plt.show. Now guys, to show you this, right, you saw, right? So guys, it was nothing. If you write it after plt.show, no, so it will already has printed the image. Now just to show you this happening, I'm thinking if I can plot it one more time. So what I want to write a code quickly, just give me seconds. I should be able to do it fast because I know what I'm trying to do. I want to show both the images together to make my point. So 474 pixel, I want to do it like this, 47 by 47 inches. By the guys, you know, right? The relationship is that you want to show 474 pixels, but you want to give it like inches to divide by 100. So it becomes your 4.74 inches. So basically, I'm saying that 474 pixel by 100 is 4.74 inches. That's the relationship. Now I'm creating a multi-image within the same canvas. So I want to show display the low resolution image. So generally, I don't use this to plot because this is to show you multi-plots. So I am show small image and CMap equal to gray. Don't worry, I have to just write code for one part of the thing, and then I'll copy paste it. Trust me, I'm a big copy paster. You should be also. Be smart about your time. Set title. You know, right, guys? This is something done now. So this is the Python way of writing the code. This is not the MATLAB style of coding in Matplotlib. This is like object style of coding. If you study Matplotlib, okay, low resolution image. Now, bingo. Now what I have to do, I have to just copy paste this whole block. I made a small typo. And guys, I'll say one, display the pixelated image. Two. This is the name of the variable, na, guys. Be careful with the why to put a lot of efforts. Guys, I thought I should have done it in the first only, but I also improvise as I talk. Now adjust the layout to prevent overlap. plt.tight underscore layout. That's how you pack it up. And then plt.show. I hope it solves the purpose I'm expecting. Let's see the magic is happening or not. What's happening? Okay, I realized what I missed. plt.subplots, I did now, but I'm assigning the position, isn't it? Very good. Look at my spelling. But it did not do what I wanted to do, yeah. It was nothing to do with the assigning the plot position, right? It was gray, right? So sometimes errors will be different, but what happens, right? What happens that we think that error is there. I was damn sure that my code is correct, but nobody was paying attention to this, right? Okay, so it's okay, guys. We need to just think that we need to set it something here. I think this part might help us. Hold on. I'm just trying to set the figure size 4.74. So guys, I know what I was expecting. I don't know how to do it because that's something should work here. I was thinking to do that. It will be, you understood what I was trying to do, guys? I was trying, and I'm trying live, so obviously it's taking time. But I thought that it will be a small image, right? 60 by 60, something like this. And this will be a full image. You understand what I mean? So there used to be a way to do it. I don't know what's going on. Maybe the positioning of this line is not right. Okay, let me take some, let me give me some thoughts here. Okay, guys, I will look into this. You know, must be something I'm missing here. I'm trying to, so guys, what I was trying to do, I want to fix the scale, right? So guys, I want to fix the scale. Just let me plug in this in my side of the code. Hold on. There's a reason I'm doing this exercise because I'm doing on the spot. So I'm missing some parameters 100%. So we have to do it carefully. It's not that easy. Yeah, I thought so. I know that this is the function to do it, but why it is misbehaving like this? Fix.set size is inches 4.74 by 4.74. This is idiotic. Okay, anyways, guys, it doesn't work. Okay, I'll come back on this. That I want to show both the ladies in the same canvas. One lady should take the full image, right? Like it is doing. The other lady should do this. If someone can give me a working code, nothing like it. So what you can do, guys, try to show the first image as a tiny one in the same canvas size. That's what I'm trying to achieve, which I'm not able to do. And I'm feeling so disappointed because I knew how to do it. Now, guys, important thing we need to understand is that I want to detect some edges in this, right? Right. So in this image, in this code, I want to detect some edges, right? And I want to do this in 64 by 64 image, which is a pixelated image. How will you do it, guys? I'm not saying to do prediction. I'm saying that I want to understand the texture and the pattern in the pixelated image. How will you do it? Applying the filters. So while you're leaned out to detect edges and all, you need the filters, right? So there are different ways to do this, right? And there are different filters to do this. So guys, I'll just take from SciPy. I'm not using some, big library yet. I'll go there eventually, but I'm just warming up the discussion. Convolve. So you're using convolution. I'll take some sample edge detection. Kernels. Kernels is like filters, okay? But the same thing I'll do it. Lakshmanan is saying remove tight layout, it will work. Are you saying this? Is it really because of this? That will be a nobody. It's okay. Let's not try something. I know what tight layout does it, right? Anyways. Kernels is filters, guys. Let's come out of it. It's okay. It's okay. So I'll take the first filter. It's called Sobel X. Okay. And this filter I'll hard code with my hands, which is np.array. It's a 2D filter, -1, 0, 1, 2, -2, 0, 2. I told you, remember? I don't know how many of you guys remember that I'll show you a lot of filters in the hands-on. So this filter is a Sobel filter. It's the guy who did it. Sobel kernel for detecting vertical edges. Now, this is something you don't need to remember. You just need to keep it handy in a template. I don't remember this filter definition, but I'll explain why it is called a vertical edges. Similarly, you can have, my dear, it is carefully formed, and I'll explain the maths behind it intuitively later after the hands-on. There's another filter which is called Sobel Y, which is basically, I have to rewrite, it's a horizontal edges. So -1, -2, -1, I need to go and change it. Don't worry, I'm looking at my notes and writing it. Don't think that I remember it. Huh? I don't want to give any wrong perception about these things, guys. Then I'm not an honest trainer. I'm looking at my handout, right, and then writing this. Okay, now if you observe this, guys, what's happening is that it's a transpose of this matrix or this array. Can you see it, my dear? So this is like for detecting horizontal edges. Let's understand. Let's see this filter. Okay. So this is like edges. Oh, not images. Come on, Akash. What are you doing? Okay, edges. Okay. Now I'll also tell you about the textured, So to detect texture in the image, we have another kernel, and that is called Laplacian. Laplacian is a big guy, and that is np. Read about it, Mr. D. Laplace. Those who study signal system, Laplace transform, remember that, using e to the power st, which is j omega t, right? Laplace transform, converting a differential equation into an algebraic equation, right? So 1, -4, I can talk on Laplace for hours. Just see that my array construction is good. 0, 1, 0, 1, -4, 1, 0, 1, 0. So this is your Laplacian, not Sobel. This is another guy. Laplacian, very famous. D. Laplace. Let me show you the face. This is important that you should know about these guys. D. Laplace. See, Pierre-Simon Marcus D. Laplace is a very famous guy. Fourier transform. I don't know you don't need to be like an engineer to understand about Fourier. Mr. Fourier, I'll tell you about Joseph Fourier one day. This guy, life was really bad. Yeah, I mean, so when I used to teach Fourier transform, this is the guy is the reason that you're using internet. You are talking in frequency, right? Wi-Fi, bandwidth, megahertz, right? This is all because of Mr. Fourier. He was the guy who created the bridge between time and frequency. And everybody knows that time is 1 by f or f is 1 by t. So Fourier was his idea was rejected by so many people, including Mr. Laplace. So when he used to present his paper to these guys, right? Fourier used to present his paper. So these are like mathematicians and the physicists, right? So Laplace was always in the panel to reject his idea. So Fourier wrote a book and he died. But later people started recognizing him. So he did not get his due recognition while he was alive. That's the sad story here. Okay, don't worry about it. Let's move on. But yeah, you should read about these guys. If you're aware, I don't know how many of you guys are aware of this story, but it's okay. So now apply convolution. Convolution is like apply this filter to detect edges and textures in the pixelated image. You can change the image. It's up to you. Just change the code. Your image will change and you can do it. You can take a lion. You can take any object. So I'll write a quick function to apply filter so that I have a lot of filters, right? So I want to use it again and again. So I just need two things, right? In this function, image and the kernel. So image is what? Pixelated image. You don't really need to use pixelated image. Let's start with without pixelated. So generally, let's use the grayscale image to get the filter applied on. And kernel is your filter, right? Choose the filter of your choice, right? Isn't it, guys? So this is a docstring. Docstring is like your definition of your function. Return, convol. The parameters are image and kernel. So this is our own function which we have written. Let's do it. Okay. So I'll apply the first filter to detect the vertical and horizontal edges using Sobel filters. So I'll say edges along X. So we'll apply the filter. Guys, take the image gray only and apply the Sobel. Aja. Okay, guys, this is done. You are in synchro. Similarly, you can detect edges Y. So guys, this is your vertical edges, but I'm writing like X. Okay, so I'm following the convention. So you will just do this and you have to just change it here. Sobel Y. But you should know, right? Okay. Now, this is done. Detect the texture also, no? Texture before we go on a break. Detect this texture using Laplacian, right? What is the guy? Laplacian filter. And I think I don't need 2 lines of code. See, I'm just being smart using one block. You can say texture. Don't worry, I'll explain the code if you're struggling, but there's nothing to struggle in this, to be honest. And you can say, what is that? Texture. Yeah, sorry, what I've written. No, not texture, Laplacian. Okay, I'm famished, guys. But yeah, run this also. Now I don't need to do anything. I need to just use this code block and get the job done. So see, I'm being smart. So now I need to plot 4 images in one row. Why? Original image, 2 edges and 1 texture, right? So we need this. No, guys, come on, say something. Now fixed size will be what? 16, 6. I don't need to give this DPI and all. I'm not doing any those kind of job. Now I'll say this is my original image. So I'll say EMG underscore gray. Axis I want to show. So this is like original image. Whatever the image, right? It is pixelated, it is not pixelated. You know that. You know as a matter of fact. Clear? Then I'll take this guy. And this is your what image? Edges X. So this is your vertical edges, and for that you're using Sobel X. I'll explain the funda behind it later. But you got the idea right, guys? Come on with me so far. And this is your horizontal edges. So you'll do here 0, sorry, 2, 2, right? Underscore y, Sobel y. And the last bit is, my dear, is the texture, right? Texture detection using Laplace. So guys, you can clearly see that using Laplacian, I give you a lot of detailing so that my code looks complete, guys, as you can see here. It's very easy, huh, by the way. Okay, time has come. Show time. Anything I'm missing? Do you think it will run? Yes, I'm missing 3. Come on, no error, yaar. Wow. Okay, not bad. What do you think, guys? Does it work? I know a lot of people think, what is this? This looks very ugly, but it's not ugly for CNN. Have you seen the lungs images I showed you earlier? Can you see the vertical edges are being picked up? Let me show you, then you will understand. And we'll discuss more. See, this is the vertical line. It is like very clearly picked up. Observe this. There's no vertical here being picked up. Can you observe this? Then you will thank me later, right, Agas? You are doing some real job here, right? Look at for any horizontal thing, anything which you think horizontal. Let's think about this one. See, it's coming, right? Right? See this? Are you feeling it, guys, or not? And texture is texture. So texture, if you go and zoom in, hey, mister, you get lost. You will see that it shows you the whole texture, right? It shows you everything. But obviously, this image is like, you know what? This is the original image, okay? Makes sense? Now, if I just copy this, hold on. Do the same thing on the pixelated image. What is that image? Come on, pick. But we like it or not? And this code block is so nice that you can practice a lot of things. You have seen it, right? You must have seen on the portal or some Google link, right? But this is what we have done in our own way. So what is our task after this, right? That we have to just understand these filters a little more. How does this work? But you are able to see this. So don't apply those things. We have not done any of those things. This is just general thing we are warming up. So we have not done any, convolution like that, like using those pooling and all. But yeah, it is going through this 3x3 array, and it is running through the whole image. So you're right about it. Yeah, you're right about it. But that value is coming from the literature. So this Sobel kernel for detecting vertical images, right? It's not something I have put together. It's a whole thing. It's a so this is not something I have put together, right? So they have done, see, so there's a lot of detailing around. That's what I'll come back and explain it. Make sense? So there's a proper literature being done on this. So it's always through the science is what? Iteration. So people, those who are doing the experiment, right? They are trying all the different filters, not like randomly, right? They are trying in different ways and understand what is the impact in the overall modeling approach, right? We are going to be consumer of this, right? So I'm not going to suggest here, like you are from academia, so I forgot, I think you are a professor, right? If I recall correctly. I think I had 2 professors in my batch. I forgot one name, but I think you're in academia, right? So those who are trying to be in the academia, they have to think and understand that how they came up to this Sobel X, Sobel Y, and finally understand and make something better than that. But you can clearly see that the vertical edges, it does pick, right? It does pick. You can clearly see that all the vertical edges, it is picking very nicely, guys. Understand this. In this, it is picking all the horizontal edges wherever it is possible, right? And texture is to anyway texture. It's nothing to do with vertical. This looks good. This is what I wanted to show. So guys, can you see that this image looks in the small size? This image, if you see, right, it looks neat and clean. But the moment you zoom in, right, the moment you zoom in, it starts showing pixelated, which is on the right hand side. This is exactly the reason. So now, Usha ma'am, you understand, right, why I'm doing it. So once you reduce the size, your image does not distort a lot, right? Because you're reducing the image size. It's a very tiny thumbnail. thumbnail. But the moment you zoom in, it will look like this. Understand? You're asking, right? What is the whole point here? The moment you zoom in on a small image, it starts, it starts blurring out. Not blurring out, it starts spreading out like pixels, like this. And if you remember, everybody, I told you that in a pixel, you can only have one color gradient from 0 to 255. So you pick any pixel, you will only see only one color in the whole pixel. So guys, this is one pixel. Observe, only one color. Observe this pixel, only one color, only one color, only one color. Take any pixel in the whole damn thing, right? This pixel, if it comes on the phone, people get heart attacks, especially if it's an iPhone. Just kidding. I'm being sadistic here. Okay, everybody. So I'll create a block called code discussion. CNN, hands-on, or code explanation. So this doesn't only mean that I'll explain the code, I'll also explain the concept behind these things. Okay. So how to set the values is something you don't set the values. You're talking about the filter values. So the filter values is it's not something you set. There are default filters which we use, and I'll talk about it. Right. So I showed you some. I have shown you guys some filters, right? So let's talk about these filters. Okay. So first filter which I use today, let's talk about a bit. So I'm putting the heading, guys. Several filters for edge detection. So it is one of the most commonly used filters, guys. Okay. So how does it work? I'll talk about it, but I'll just give one liner for it. It is most commonly used filters for edge detection. So don't take it lightly, means it is one of the most commonly used filters. The moment I say this means it is being used. Okay. Guys, if you look at the intuition behind its working, it uses the gradient. So I'll say it works by calculating the gradient, which is rate of change. You know, right? Gradient is like slope of the image intensity in a specific direction. Now that's where the direction comes to the play. Now direction, remember I was doing two, either horizontal, and guys, I'll keep it little light here because I can't go too much in the depth because I'm not trying to do the research here. So there are two directions where the slope can work, which is horizontal, vertical as per Sobel, right? And wherever the frequency is higher, right, it finds the edges, higher spatial frequency. So I'll try to explain it. I think if you recall, this is a little tricky, guys. So just have patience and look at it. Sobel X, this is your vertical edge detection. Sobel X is your vertical edge detection. And just to show you the filter, it was this filter, guys. You can go back to the code and check and validate. It's the same one I have written, guys. So it's a 3 by 3, but -2, -1, 0, 0, 1 to 1. Okay, now if you look at this filter detects the vertical edges. Yeah, it's written. Nothing rocket science about it. It detects the vertical edge. That's fine. Very nice. But if you observe this, then you realize that, and that's where the intuition, I am not going into the detailed maths behind it because then it will be super problematic for us. I don't intend to teach this much of maths. It's not in the syllabus also. But guys, can you observe that the first column or the leftmost column is what? All negative. Did you observe, guys? I think most of you guys have done this. So this is negative values. Negative values in the first column. Okay, very good. So then you are also able to observe there is positive values in the positive values in the last column or the right column, rightmost column, right? Not right column. The right English will be rightmost column, and here the right English will be leftmost column. But since there are only 3 columns in our scope, because we are looking at max 3 by 3 here. Okay, perfect. Now, what to do with this observation, right? So we are saying that pixel values on the left side of the filter are negative. Those on the right side are positive. Means what's the whole point? The whole point is if you go from left to right, there is a high chance in intensity. Means you will be able to capture if you go from left to right. Okay, but I know this is not very clear what I mean to say. I'm thinking how to explain this. Just thinking, guys. So I know what I mean to say. You are able to detect the vertical edges, right? So I'm just thinking. So I'm going from negative to positive, right? I'm going from negative to positive. So we are going to allocate more weights. We are going to allocate more weights around the edges, and that too on the vertical edges. Okay. So if you observe, and I think guys, that's why we have to take an image to show it. But this whole, I think this is the right statement, that if you compare an image with the vertical, vertical edge detection, right? You are going to do an overlap of this. So suppose you have an image here, and you're going to take this guy and keep multiplying, right? The way we move the filter. So every time if you're going from left to right, okay, you're going to allocate some higher weights. That's how it works. Because see, I don't want to. I'm thinking. I don't want to go into the math, the whole mathematics, because then there's no point. So you are trying to just understand that if you put this vertical thing, the vertical values, right? So moving from left to right, it will keep detecting and allocating the vertical edges high intensity. So it will get more weight and it will become more white, right? So if I want to show you with the image, hold on. So I still understand that there can be a lot of detailing around it, but the whole idea is not to go there that depth. But what I'm trying to say here, guys, the moment I'll show you, giving higher weight means what? Making it more white in the vertical, guys. Come on. If you look at this image, isn't it? Wherever there is a vertical part of the image, you are allocating a higher value. Guys, can you see that? Higher value means white patches are coming. Can you observe these white patches, my dear, if you are able to pay attention? And whatever is already dark, they are making it more dark. So that way you are able to highlight more across the vertical lines rather than horizontal lines. But again, I would like to keep it here only because I don't want to increase or create the confusion here. Okay, but this is the filter. Now, how does this filter value have come in the past? Looking from if you understand this whole the lecture, right? We are not going to look into it, but obviously this guy, Mr. Sobel, he came up with these values. You don't change these values. Means you can definitely try play around, but ultimately what happens, guys, that these are the values you have to use and you can play around, but you can only highlight the scale, but don't change the negative and zero in the positive positioning. Okay. Okay. So let's not get too much into the detailed thing. Okay. Sobel X is vertical or horizontal? See, guys, obviously, if you see this image, you tell me it's vertical or horizontal. X and Y don't go there. Sobel filter we are talking about. I might have underscore written X underscore Y, but don't go in that. It will confuse you, to be very honest. So there are two types of filter. I would always say that this filter is associated to vertical edge. The other filter is associated with the horizontal. Okay. So Sobel Y is horizontal. I'm just also trying to say, I'm just confirming, guys, give me a second. The kernel is vertical is negative on the top. I'm just trying to recall that. But looking at the image, what do you think? It is like horizontal or vertical? I think image itself says here. So I don't worry about anything else. Just look at that. This is giving you horizontal edges. It is picking because I can clearly see that these are your edges on the vertical side and it is picking it. So this is definitely vertical edges, no? guys, or we are doing some mistakes? But I'll double check and confirm because it's just a transpose, So I can be at mistake. So I agree. So guys, okay, the image is like vertical only because if you see here, right, it is picking the vertical one. So the other filter is, guys, vertical, horizontal edge detection. So well horizontal edge detection. I think, and some of the guys were able to find that what is the relation between horizontal and vertical. It's just the transpose, right, guys? I'm not writing X and Y just for the sake of not confusing in it further. So if you look at the this Sobel, relationship, you know that it is it, right? It's a transpose. I hope you guys are able to see it's a transpose, right? So the row becomes the column. Okay. So now this filter, let me write very clearly. This filter detects the horizontal edges. Now, why it is calling this Sobel Y? I'll also tell you the reason I'm calling Sobel Y. Because you are going from negative to positive, which is your top to bottom. Can you see this? So are you not going on the Y axis, guys? This is like Y now. And here it was what? So when I said it is Sobel X, you are going from like this, left to right. See? So that's the reason we are giving the notation X and Y. But in case you're doubtful about Naveen and you know something different, I can confirm and come back. But for now, I'll go with my memory. I'll back my memory. So detect the horizontal edges. Now what's happening, guys? You're seeing, right? You're going pixel negative top to bottom. See? So you go from negative to positive. Just observe this, my dear. So the same thing it does. So it gives more weightage to the bottom than the top. Okay. Now I'll talk about, so Sobel is done, XY. Now I'll talk about Laplacian filter for texture detection. So here, if you observe, again, it's the whole thing, but the only difference here is that it is used to detect textures and other fine details by measuring the rate of change in pixel intensity over the entire range. Now, this is very easy to understand. So what we are saying that, and for that I have to go to this guy. So this is original image, and I'm doing with respect to original image, no downsampling, guys. So now if you observe, it's all about intensity. So now you go from, and since it's not pixelated, you're not getting a lot of sense. So I'll take a pixelated image, guys, and then you will understand. So we have three things, right? And later I'll ask you guys to pay attention to the pixelated image. Now, this is the pixelated image, making it bigger so that you can see it's a pixelated image, guys. Can you observe? Right? This is something I've shown you this is something I've shown you earlier also, right? When I was trying to show you the pixelated image. Now, if you observe, there is some change in the intensity. You can't see here. You have to go bigger. Why I keep zooming in, then you will realize that. Focus on one part. Do you see there is a change in the intensity, guys, in the pixels? So when I say pixel intensity change, what do you mean by that? You mean by that, so, right, if I zoom in and zoom in, right, you will see that I have a better image to show you this. Hold on. Yeah. See this image, my dear, right? I'll make a copy so that I can show you. Guys, there is a change in the intensity. This is brilliant. Well, this is beautiful. Can you change in the intensity is what? Shades. So see from here, and across the image it has to do, right? It was bright white, going from bright white to dark on this side, right? Can you see that? And going more darker on this side. Can you see this? Just observe this part. Then again it goes from here to here, white. Now come here. Look at the madam's hat. Now come here, guys. This is the texture, right? This can get better also because I'm not using the pixelated image. So let's do one thing, because then apple to apple comparison will happen. You understand what I mean? So let me run this function with the pixelated image, and you understand why I'm doing it. So I'm doing in the background because you are looking at my OneNote. So I'm running this the whole thing, rerunning it, so that I can show you the image. So when you do this with the pixelated image, it looks really awful because your pixelated is really bad. You have reduced the resolution to like a really low. You means me, right? But I'll show you because I don't want to cheat with you guys, but it is like of no use. But me with Ming, I'll show you. This is how it looks like, guys. Not good. So you can reject it, but can you see? Nothing you can see from here. But it does give you something which is of no use. So you go there back. Can you see it, guys? It's nothing. So what you can do, you can't be reducing like this much. 64 by 64 is not good. Let's do little bit of pixelation by half of it. So I'm changing the code, guys. So I'm just seeing that if I can get a good image to explain the concept I want to show. Now this is super good. Yeah, this is powerful here. So this image is so nice that you see the vertical and horizontal edges so nicely. Guys, observe this. So this is of no use to us. I'm just deleting it. But look at this one. At least look at the vertical lines and horizontal lines you're detecting, man. See, it's not about you to decide and make a. So again, a lot of people think, Akash, this picture is not making any sense. Baba, this picture is not for you to make a printout. Always remember my word here. But look at the clarity it gives you, right? Are you able to see all the vertical lines nicely, guys? Patches of white and the black, guys. See, observe this, right? Can you see it, guys, or no? And can you see this horizontal lines coming out? And look at the texture. It completely gives you, if I make it small, right? It looks like the texture is very clearly shown here. Because I'm going into this, it looks like, and that's how we have to see, my dear, right? Because it's a pixelated image, right? But can you see that the lady is very much, you see all this, the whole texture is very visible. I don't know how to say this, but see that everything you see here, if you pay attention on my screen, right? The whole, I can see the eyebrows, by the way. So if you are thinking that I'm just doing a blind chart, it's not blind chart. Can you see the eyebrow at the right thing? For the model, it will be able to detect. Just look at this, my dear. See, are you able to see the texture? Just see this and this image. You're able to detect the texture of the image. But there are other filters all as well to do it. But you got the point of discussion, guys. Okay, everybody? Because that's how the model will understand. You don't need to do it with your mind, right? It's all about this, right? But it can be better. So I can make it more smoothing out, right? Using that average pooling. Remember that? Can you see how does the edge detection is being done in this image? Can you believe it? So I am going to bring this quality of image very soon, but I want to go slowly. So I want to show you, this is so amazing, right? You're looking at a colorful original image, right? You do the Y direction and X direction. So basically you're doing this gradient to do the edge detection. Are you able to detect the edges nicely in this image? So everybody understand what is the whole point of edges. This is just for edges, huh? This is just for edges. It's not showing you this is not showing you the anything else. This is just the edges. Clear? So it will come. There can be a lot of different types of edges. And I don't want to go into the mathematics behind it, because then it will become complicated for us as a learner. And I'll also show you for the same image, Laplacian detection. See this. Isn't it better, guys, for the texture? The moment what happens, right, I take an image, it doesn't look nice because texture is not coming nicely here. Because some issue with the screenshot. I don't know what is happening. Well, I don't know how to show you. Can you see this image, guys? If I give you the address at your end, I don't know what's happening. This is so bad here. Means if I take the screenshot and when I paste it, it doesn't look nice to me. Are you seeing the texture looks nice? Anybody is able to see this? See the texture. You're not able to see it. I'll show you. I'll zoom in. Can you see the texture is coming so nice? Now you will see that. So this texture I'll show you with the filter, with the also there will be some fine tuning steps, right? So why you are not able to see in my image? Because I've done nothing. I've just blindly applied the Laplace. So you will understand from me that, okay, this doesn't work that way. But the moment I show you this, your level is getting up, right? See the texture, guys, on this. See this. I can't show you here. I'll use some. Just observe this part of the image, guys. Are you seeing this? So when I'll come back to the this madam, what was her name? Lena, right? So then you will realize that I can generate the similar texture for her. And then you will say, wow, we have come a long way from here, but this is the ground. This is the reality behind the scene. And then we will do some fine tuning and the images will get better. And why we are doing all these steps, my dear? Because the moment we have to go from here to do the detection, we will use these steps in the model building, in the architecture. Okay. Recurrent neural network, RNN. RNNs, you can say recurrent neural networks, are a class of artificial neural network. So you can clearly see that it is also a branch of this guy, designed specifically for sequential or time series data. And this you have to keep in your head. Sequential or time series data. Continuing and writing, RNNs are widely used in applications that involve a sequence or order, such as language modeling, speech recognition, machine translation, like Google Translation, Hindi to English, English to Kannada, right? Kannada to Tamil. So I can talk to Srini in Tamil. Obviously, I'll miss on the pronunciation and the dialogue delivery, but I can still say some words. Time series prediction. So all those, I think almost a decade back, Google came with the translation and many more applications. So don't think they are good for nothing, definitely, but it's like a very niche area. How many you need such use cases? It's not like high, okay. I feel RNN is taking us closer to the human behavior, right? Generally, this is a question that why we use RNN. So maybe I'll write this question. It's an interview question, guys. And you know me, I keep giving you this kind of question. It's like a pro tip means interview. So why use, before I get into the depth of RNN, my question is to you, why use RNNs when we already have CNN? Could not we have used CNN for these tasks? Question. You know that as a matter of fact, CNN can't do these things, but why? CNN cannot deal or cannot handle previous history. It cannot remember. It's like Ghazni. Have you seen Ghazni movie? Amir Khan, and there's another movie, I think a Telugu movie as well, right? They are going to shoot the Ghazni Part 2. So Ghazni movie is there, right? So this Ghazni movie or Tamil movie, I can be wrong, but the guy forgets things he only can remember for 15 minutes, something like that was in the movie, right? Short-term memory, right? So when I'll teach long-term, short-term, right? LSTM, long short-term memory. So I'll be going to anyway talk about it. You love it. The Ghazni resemblance, I will bring it up. But that's the problem with the CNN, guys. Okay, that's the problem with the CNN. CNNs are really good when you have to understand the image. What is the relationship between the spatial pixel relationship? But it cannot, local speciality, right? But it cannot remember the sequence in which you have inputted the data, right? It can't remember that. So I'll detail it out for you. But a very high level, I can say that CNN is really good for any image related stuff, as you know. Why? Because it is good in handling spatial relationships between pixels, and that took, in the local relationship. But it cannot handle the sequence of the events, right? Or the sequence in which you are entering the words. Like I'm saying, hello guys, how are you doing today? How was the week, right? It does matter if I say hello guys. I'll show you. So this generally I say, right? Hello guys. If you say this is my pet line, how are you doing? Or how are you? How was the week? Now just imagine, that, let's say everything is an input. So I know every character is an input. For simplicity, I am making boxes, right? For CNN, everything like one input, and it can take in any order. So what CNN will take it, like it will say, are weak guys, hello, right? Are you getting it? You, the, how. Are you getting? There's no sequence. Now, if someone is saying this in the class, saying, are weak guys, hello, you, the how, right? You will say, who is this guy? Is he gone crazy or something? Because you don't know this. There's no way you can, I give you a jumble of words and you make some meaningful sentences. Generally, we used to do that, right? You understand what I mean? So generally, we used to jumble the words, and this happens in some government examinations like that. So you make a meaningful sentence using those jumble of words. But who talks in that language? Yeah? Nobody agree with me so far? So this is like totally beyond comprehension. So I'll put a line to it. Non-understandable, as there is no sequence. Okay. So let's talk about it more. So now I'll answer it, guys. CNNs, which is convolutional neural networks, are extremely effective for processing data with a fixed spatial structure, like images. Isn't it a fixed spatial structure? You say that you have an image of 32 by 32 pixel, right? And there is nothing changing in this, right? There's no dynamic sequences coming up. So it can quickly handle this. Okay, I'll continue. However, CNN lacks the ability to maintain context. Guys, in natural language, context is very important, or process sequential data effectively, right? We know as a matter of fact. So what I'm saying that CNNs excel in tasks wherever or where the spatial relationship between pixels matter. And when I write this now, you know what I mean by that. But they're not designed, so I'll also tell you that, but they're not designed to capture relationship in the sequences. Just like I have shown ever, right? That how do you guys, if I'm saying differently, you'll not understand it. Okay. This is a very high level. I maintain that whenever you have an image and you want to find spatial relationship between pixels, it will work for you. Who will work for you? CNN. Can CNN use to process video? The answer is yes, but not the natural or the inherent CNN can do it. They need, some more advanced version of it, which is obviously we are not capturing here. So you might have heard about 3D convolutional neural network. So you'll go, so right? CNN is for images mostly, but CNN in combination with some other architecture, it can do it. Okay. So there's something called convolutional LSTM. There is 3D networks, 3D CNN, two-stream networks. So I'm just, giving jargons here, but CNN can be, so what CNN does, right? If you take pictures, they're all images, right? And if you just, play 32 pictures or 32 frames in a second, it becomes a movie. You know that? It becomes a video. I think this is something a basic GK. Okay, now though it's going more than 32 frames. So if you just start showing images 32 frames per second, to human eyes, it looks like a movie. That's what I'm saying, guys. Okay, at least this is a basic definition of a video. So now since CNN can only look, right, one image at a time, right? That is CNN. But you also need to capture the sequence of it. That's where you have to either apply CNN with LSTM or CNN with RNN, or there are some more architecture, etc., to analyze a video. There are architectures. Okay. See, only like once is like is a real time object detection algorithm that uses a convolutional neural network only to predict the class and bounding box coordinates of objects in an image. It is still an image, guys. Okay. But guys, I'm not getting to detail it out because then I will, gives you the coordinate. I'll show you a real image which is famous on the web. So this is, you have seen, it comes on the LinkedIn. A lot of people keep doing this. I have seen people doing this. So this is somebody's screenshot I'm placing here. Can you see that? So it gives you a lot of details in an image. Okay. It's still a CNN. It is not like a 3D video analysis you're doing. Okay. So for dataset is a facial recognition dataset kind. It's just like our those 10 classes, right? So CNN is more preferred because it's more like a classification task, right? As it's an image classification task. You understood? You're not trying to box the image and find object in that, right? So that's what I'm trying to say. It's still an image classification task. You're not trying to find who's person, where is the traffic light, right? You're not doing those stuff. So you don't need YOLO for this. Okay. RNN, at least you're getting a sense that it tries to store the sequence and then tells you things, right? Okay. So whenever I say sequence is so important, buddy, that you realize this. I think a lot of guys must have tried this. Have you seen this? This is coming from the Google Translation website, guys. What I'm doing here on this screen, guys, I'm saying, did you eat biryani with Amir? Right? Can you see this? It's a Google translation. Source is Google Translation. So what these guys are doing here, when I say, did you eat, right, biryani with Amir, it is trying to not only sequence these words, it also tries to remember, right? क्या आपने आमिर के साथ बिरयानी खाई, right? It has to be lexical correctly, grammatically correct. So I'm asking a question. Did you eat biryani with Amir? It's written in English, right? Just understand. This is English. But here, Amir comes in the third place. Can you see this? Observe this. Where is biryani? Biryani is in the second last word in the Hindi, right? And Amir is coming in the third place. Just observe the color coding, guys. Everybody, please pay attention. Just tell me one thing. If RNN would not have the memory, right? Do you think it is possible to write different languages having different grammatical setup? This is one of the very key thing I'm discussing, guys, right? If I just do this to Tamil and Telugu or Kannada, right, you will see biryani is switching the position. Agree or not? See, I'm not a champion of other languages. I'm good in Hindi or English. I'm doing it, and I hope you also understand a little bit more. Don't get into this controversial discussion that Hindi is the best. Every language is the best. Language is a way to communicate. So then don't take it so hard. So I'm not getting into that zone. I'm saying that did you eat biryani with Amir? In English, this is what it looks like. In Hindi, look, Amir comes here, which was the last position. It understands that so first, if you write something, did you eat biryani with Amir? There are a lot of stuff happening, by the way. So it goes through this translation, but it first understands each and every character, its positioning, its meaning, and then it generates. So it's like first it takes then generates the response in Hindi, saying that same stuff in Hindi, giving the right position for the words in Hindi without losing the meaning, without losing the context, without giving any confusion. Isn't it brilliant? I'm not saying that Google Translation only uses RNN and it's doing everything. No, I'm saying that I'm just making a point. Use cases like this, right? Use cases like this that definitely needs to remember things before you can do anything. Agree or not? So what I'm trying to say before I go anywhere, guys, you guys agree with me? So this is in Tamil. Now different language, look at the beauty of this. So this is Amir, the popple. And this is biryani. Look at the language has changed. It's Tamil, right? Positioning has also changed. But the same thing can generate this in Hindi and this in English. You don't need to change the left side. You agree? So what it does, it not only takes this character, the word, the positioning, everything it remembers. So what I'm trying to say, RNNs imitate the function of human brain where it tries to to model the sequence data like conversation, like human conversation. So there's a friend who is not happy that you ate biryani with Amer. Definitely he's not happy. That's why he's confirming. I'm just making it up. Did you eat biryani with Amir? Means he's not happy about it, right? How can you miss me? And it can identify, which is more like I would use the word anticipate sequential data in a way that other algorithms can't. That's the power it has. Algo means algorithms can't. I don't know how many of you guys seen this. When you write something on the Google, it predicts it. Suppose I'll show you an image. Is the market going to crash? The moment I write, I'll show you. Those who are investing in market, I'm just making an example. Don't say anything. Is the market is going to crash? The moment I start searching the Google, I'll write source Google as Google Mind. These days Google can be a little tricky. Source is Google. Definitely we're using Google. So when I write something, is the market is going to crash? Understand. Is the market is going to be crash? I have not even completed it, but it has given me the top ones. How do you think it works? Right? So it can do ranking. You can say that suggestion. There can be multiple ways. So I know it can be a little misleading and confusing. Okay, guys, this is just like ranking of the search people are doing and showing in that sequence, right? I understand. But you know what? Google has this feature that auto completes it. And I have talked about it. You remember that auto completes the sentence. And that called Google Smart Compose. Agree? But it can only be possible when it remembers things, right? Google Smart Compose is one of the very good use case. Google Smart Compose is one of the very good use case for your RNN. I'm telling you. So why this is the hot topic? Because if you see now, a lot of people are searching this. Generally, people are always going to search this. I think Google Smart Compose, I'll jump to this. I realize that this is not a very direct example. So I'll talk about Google Smart Compose. There's something called Google Smart Compose. Okay. So when you write anything on the Gmail, right, it tries to predict what you're going to write and gives you some suggestion. Okay. Agree or not? This is called Smart Compose. So what is with the Smart Compose, right? Google's Smart Compose feature suggests, or you can also say anticipates the words or phrases to complete the sentences while typing. Okay. You know what? As a matter of fact, it's in the data, it's in the web, that it was originally Google Smart Compose has definitely come a longer way now. But the first time they built it, my dear, you'll be amazed to know it was originally built using a form of RNN. So guys, these guys are like legends, right? Using a form of RNNs. Obviously, it was also having, that's why I'm saying none of the Google application, just one algorithm with long short-term memory, LSTM. So you know why I'm not able to go and build you for like a Smart Compose? There's a reason behind it. It's not a joke. But why I'm taking this example, then the cross question will be like, Akash, then why the hell you're taking this example? To show you that if you are an expert of this or you want to pursue something, there are some real life application which everybody is using. Like it's a real life use case. Guys, can I say that? Everybody is using it. So whenever you combine this deadly, guys, RNN and LSTM, you can do n number of things. Trust me. So that's why I'm saying, this is the topic of advanced deep learning. Now you're getting deeper in deep learning. So just to give you some evolution or Smart Compose thing when it started. So Google first launched Smart Compose. They were leveraging RNN with LSTM, right? LSTM is known to track the sequence of the words to a great level. Means it can remember what you wrote maybe 100 words before. And that was helping them to predict. But once Transformer came, not that movie Transformers. So when the transformer-based model came like BERT or GPT is a transformer-based model, right? They showed right significant improvements of over RNN and LSTM. So what Google and other tech companies did to do some text prediction tasks, they moved from here to there. So what I'm trying to say, transformers outperform RNNs because of attention mechanism. There's a concept of attention mechanism, and that helps them to beat RNLSTM. Okay, are you feeling it what I'm saying? Maybe I'll also write quickly so that you don't miss on this. So this is the, so I was talking about how does Google Smart Compose evolve. God knows what they are using now. Google doesn't tell you these things, right? Obviously, these are their IP, intellectual property. They'll protect it at any cost. So what I'm saying, guys, obviously, Google first launched Smart Compose leveraging RNN plus LSTM to handle long-term dependencies. Okay. When I'll teach you LSTM, you will know that LSTMs are known for or can keep track of earlier words in a sequence. That's the beauty of LSTM, which allows them to better predict subsequent words. But later, as transformer-based model such as BOT, GPTs emerged and showed significant improvements over RNNs because they also keep doing research, right, to make better things. So it showed over RNNs and LSTMs, Google transitioned to using these models for text prediction. This is called text prediction task. You're predicting the next word, right? It's text prediction. Trust me, it needs a lot of power, compute power, money, and then you can do that. Okay. This is the evolution. I don't know. Transformer based model is the latest I've heard, but why don't know? God knows, are they doing some more testing on some new world of the models? Only Google can answer that. But this is a very, I would say, one of the coolest application of RNN, guys, which you are using till date. But obviously, it was initially a use case of RNN, but now nobody is using RNN. So you might be thinking, then Akash, why I'm even learning RNN, right? Thinking, na? How many of you guys are thinking on that line? So मुझको RNN क्यों पढ़ा रहे हो? Why are you teaching RNN? It's like you are still going to learn linear regression, even you want to do decision tree and XGBoost. This is the route you have to follow, right? So you're starting from like a baby here. You have to go all these journey milestone you have to achieve to be here. Now the question is that how fast you can go, right? That's you can decide as a learner. But you can't just jump. I keep telling this. We need to go through the foundation. Else you will be just knowing stuff on transformer. It will be just like a wannabe. You know about encoder, decoders, right? Transformers, you know, learning, you know, transfer learning, but you're not going to be an expert because your foundation is weak. Okay. It's not like multiple people are writing the same mail reply, right? It's not multi or parallel thing. I think it's more on accuracy, the kind of prediction they're doing. And obviously, LLM models have attention mechanism, right? Those transformer based or GPT models and now LLM models. So they have better ways of handling that. But these models are having more control on the context. They can keep more history. They can better use that information for prediction in the text prediction use cases. That's how it is better. So now you see when ChatGPT also came, now it is able to frame its sentences like human beings does, writing like a human, right? But obviously it took a lot of training, a lot of work. But now the GPT models are the latest available to human as an application where you can actually do anything. You can just copy your mail and say that, can you reply to this mail? And it will do a great job. I've tried those things. So obviously I'm not getting into the details of how is it better because that's not the scope here, but it's a big discussion. Can't start suddenly, but definitely it's better. That's why it is replacing the older version of it. RNN. Is transformer based on RNN? No, transformers are not based on RNNs. So it's like a pre-trained models, right, which can do parallel processing, having the attention mechanism. and they do not rely on sequential processing. But no, transformers and RNNs are two different things. RNN follows sequential processing, transformer does parallel processing, and there are other things. Okay, let's move ahead. I think it was a good discussion on RNN. Okay, guys, I'm more of an application kind of person, right? Means I'm not the guy who know everything, to be honest, but at least I will be knowing what I have to teach. So it's a vast thing, it's a vast world. But yeah, I don't know how many guys are aware of this, but Grammarly is another application. It understand your use case. So these are some plugins coming from these companies, Quillbot. I'll give you the links so that you know that, okay. So Grammarly is something you must have used. Quillbot. So I'll give you the link. So Grammarly has become a big company. Now they must be using some OpenAI kind of stuff. So don't worry, but I'm talking about the Grammarly when people were, trying to do this mail check and all, it was integrated to the Outlook. So now they're they're publishing their website like this. That dude, we are doing a lot of stuff. What do you know? So obviously every company is developing their research. So they're saying now they're using responsible AI. I'm damn sure they're using instance of ChatGPT or OpenCV. They must have trained. It's like their AI writing partner that helps you to find the words, the tricky words. You want to write a mail like an aggressive manner, right? And the Quillbot is something I'll show you also as a hands-on. Hands-on as like a use case, I'll show you through. So Quillbot is also very famous. A lot of companies are using this, right? So it will fix your grammar issues. Yeah, you can write better English. So you can do 8 tools in one platform. I'm just giving some screenshots. So that's why. So it can do grammar checker. So you can increase the fluency, fix mistakes, prevent plagiarism, right? This is amazing, huh? So if you are using this to write some article or blog, you are unknowingly not, copying, pasting somebody else's work. You will be in a big soup. So generally, if someone is writing a content writer, they try to have this subscription and do it. So when I was in my master's, I think I had to do a thesis. Okay. So they give me a plagiarism checker. So in IITs, right, professor will validate your answer that you're not just copying pasting somebody else's answer. You know that as a matter of fact, any good colleges will they do this, right? So that they don't, because your professor name is also stamped on your thesis. If you are trying to do a PhD and all, right? FYI, I'm not a PhD. I'm just an MTech. Could not do PhD. Not my cup of tea. Always wanted to be in consulting. So what I'm trying to say, plagiarism is one of the biggest thing. If you can just go through your article or your research paper, your journals, and you just get to know your similarity index is less than 30%, they will accept your work. Analyze text, summarize text, citation, translator, flow, right with AI. So I'm damn sure this is a new addition. But yeah, I also wrote them an article saying that, or like a mail that, can you give me a free version of this? They're like, sorry, Akash, who are you? So I'm damn sure when I become famous, little more famous, then they might come to me and say, please use our services. Okay. So the startups are reaching out to me saying, can you use our services, promote it, talk about it. But the big companies, for them, I don't exist anymore. Still not there. I think I have to do a little more hard work to reach that level. Okay. But I think good, interesting discussion. This is the introduction, guys, right? I have not talked about how does this work? What is the hands-on for this? Nothing has been done yet. So this is just the introduction bit. I would still say this is the introduction. Let me write introduction to RNN. So let's say I do some mistakes in grammar, right? So let's say Rahul do not like to reading a book. Obviously, it has some grammatical mistake. So you can clearly see that it has so quickly identified that Rahul, those who know a little bit of English, right? They know that Rahul with the name, you have to use, V5 form. So Rahul should be here. Rahul does not like to read a book, right? So if I just take a screenshot just for the reference, and I'm putting in OneNote. So the corrected is, suppose I click here, so it will correct this. See, Rahul does not. So I'll just take the corrected version. I'm putting in the OneNote. So when I'll publish this, you will see it, my dear. Okay. Then if I click here, look at this. So far we have come. Isn't it? It is, is it like your English teacher highlighting with a red pen saying it's all wrong, what you have done, right? So generally teacher, what they do, right? They say that this is wrong and they'll write here, Rahul does not like to read a book. Isn't it? That's how the paper or exam paper or practice paper checking is done still today, guys. Just imagine down the line, AI is being your, grader for your grading. Make sense? Cool. So now I am also showing you plagiarism checker. So the article is coming through this. I don't know how much credit they are giving. Yeah, upgrade to start. They're not giving me. But I'll show you some online free plagiarism checker. I hope free is like free. Yeah. So guys, this is an article I'm taking from this website, which is about the lung cancer journal. If I say scan for plagiarism, right? Grammarly is looking for, see, it's saying no plagiarism found. First of all, it's fully plagiarized. I don't know what this idiot is doing. Sorry about it, but I don't like this. But not every tool is good, yeah, for plagiarism. So this is completely coming from this website, guys. Let me show you. So how can not be plagiarized, right? Someone who is like R. Pandian has written this article. The whole thing I copied, pasted. Okay, let me try this. So that's how you cannot just go blindly and, take any of those application and trust it fully, right? So let me take it again. So this is another one. Everybody needs money. I know nothing is free in this world. There are no free lunches. Check 500 words for free. So let me check till here. It's okay. Yeah, it is doing something. But right, even in this application, you need your tool to understand things, right? Or at least able to compare text on the web through this, right? Agree? See, and this is so nice. It is better than Grammarly, right? It's 100% match. Why? Because it has to be, no. I just copied and pasted it. Just see, it's 100% match. And if I click here, it will give me the link to this article. So let's say go there. I say, okay, this is the same guy written this. Although I took it from sciencedirect.com, it is telling that it is coming from some Harvard, right? A very good paper. Very good paper. Did you like this use case? So it helps you to unknowingly, obviously nobody is able to mimic everything, but even if the percentage match is 50%, you will be in trouble. Okay. Text summarizer. So you can take this, the whole thing. I think now you are using ChatGPT, so you know that the whole text can be summarized. But here, this you can also do it. You can say that summarize this. See, so the whole thing it has read and summarized it. If I saying, what if we remove some sentences from this in the plagiarism thing you're saying, right? But still, it will be 100% match, right? Because it will match some other part of the chat, right? Got it? Okay, so this is all about Quillbot. You can try doing review of these things later. But yeah, that's all I wanted to show you quickly. There was another question which was asked in one of the interviews, that why does feed forward neural network not good at predicting text? So guys, remember when I was teaching you artificial neural network, you have a feed forward, you have a back propagation, right? So question was mostly on that, why it is not that good, or it is not at all good. So just to answer this, and also telling the concept behind the scene, in feed forward neural network, the information only moves in one direction from the input layer through the hidden layer to the output layer. That's the direction. Any doubt? Anybody? You know this in and out? So what I'm saying is start from input layer to the hidden layer till the output layer. Okay? That's the flow. But this flow has its own problem. And what is that problem is that feed forward neural networks has no memory of the input or the order of the input they receive. And that's the reason order is also important. Let me highlight this. Order of the input means what? Remember in our use case, right? You have X1, x2, x784 inputs, right? Now all these guys are connected in parallel. Remember that? Suppose even if I take one neuron, all these are connected. Now who is going in what sequence? There's no sequence at all now. All going towards to the neuron at the same time, right? Hello, in a layer. So there's no sequence at all. There's no order. So there's no order. So, and that's the reason they are bad at predicting what's coming next. It's like you have no idea what is going to happen with your career, because they don't know at all, right? There's no sequence, there's no intelligence there, nah. So on contrary, so I'll just add also, on contrary about RNN moves the information through a loop, which basically means that when it makes a decision, it considers the current input and also what it has learned from the inputs it received previously. Okay. So what it does, it considers the current input and also when it has also what is learned from the inputs it received previously. And obviously it's just a one line I'm telling, right? You will not understand. I know that. So I take a very cool example to explain. Let us explain the spelling of Apple. I took Apple because I like Apple products to a kid, like a 2-year-old kid. Let's try to do this. Suppose I am the kid here, okay? 2 years, 3 years of kid, right? Let's take 3 years. I don't know spelling when they teach. I have no clue. Yeah, sorry. So don't kill me for this if I'm saying, oh, this is too much. You are trying to explain spelling of Apple to a 3 or 2-year kid. This is insane. Don't kill me for this, okay? Let's say this is me. Just imagine spelling for Apple is what? APPLE. Everybody, definitely you were a kid, right? Before, long back, right? If someone is telling you to remember the spelling of an apple, you know, this is the favorite time pass of parents when some uncle, auntie come, right? Uncles and aunties come. The kid has to demonstrate. It's like, come on, beta, demo it. Please, this is my request to all of you. I don't have a kid yet. We are thinking about it. Never ever do that to a kid. Don't demonstrate. Okay? Let the kid answer if someone is asking. And I think don't be that uncle, auntie also. You go to a house of your friends. The moment you meet a kid, you start asking, okay, tell me the twinkle, twinkle, little star. Come on. We need to stop these things. Okay. You should talk to the kid. What did you do? Right? How's your life? Not like a big question, like what did you play? Who are your friends? These are the questions they would like to answer. Not like a test here. Just imagine I'm coming for the very first session, start asking questions, right? It's harassment. Huh? In US, we call this harassment. In India, it is called parenting. Okay. So that is a point I want to make. But at least you guys agree to this. I think every one of us has been through this harassment. Now the kid is trying to explain, or just imagine they're trying to learn the spelling of apple or mango. They're two different fruits, right? Order is so important, right? So the kid say a kid is trying to recollect that apple. So they say them in their heart or in their mind, and they try to pronounce those letters of the apple word, right? Agree or not? Sometimes kid will say apple like this, right? Okay. Then so no, beta, you missed it. It has to be double P. So when you say double P, then he knows that double P means, or she knows that just P after P is double P. The moment I said just after P, right, there is an order and there is a previous memory that I've already told P just now, a fraction of a second back, means now I have to tell P again because they are continuous, consecutive, right? Double P means like this, right? And now they don't have the apple means they will recollect that after the second P, L comes, right? And after that, there is another word, E. So this is how learning happens in case of a kid, right? You try to show images and then make them pronounce these things so that they keep rehearsing and they try to remember. Okay, there's nothing. So now it has become more scientific, the course curriculum. So they're talking about syllable, phonetics. There are a lot of good knowledge they are providing. In my time, phonetics was nothing in the syllabus. Similarly, for mango guys, they know mango means in their head they are thinking that I should start with M. Then they try to recall what is the next. Then next, isn't it a kid is trying to predict? Not literally predict because they're not using RNN model, but the kid's brain is trying to think, right? And that's why sometimes it's a tricky spelling. You also get stuck, isn't it, guys? So if I ask what is the spelling of a champagne, how many of you guys write it correctly without doing any cheating? So kid is thinking about these orders. You know what is the spelling of champagne? So this is the spelling of champagne, right? If I can be wrong, but I think I know it's a tricky spelling. I think I missed a A, right? No. So champagne is right. It's not a easy spelling. So a lot of people have, so I have missed A, I know that, but a lot of people, they miss this. They write chimpanzee. But let me give you the Google search for it. Let me search for you. This is how champagne is. So now if you tell your kid, maybe 8-year kid, they might also struggle. Don't take those spelling bees, those kids who are too good at spelling, they spell like this much long word. I'm not talking about those kids. We are not those kids. We are normal guys. Okay. So champagne spelling is something, right? A tricky one. First of all, champagne word, it looks like I'll start with S, but that's wrong. It's not champagne, but still champagne is little. So those who have good phonetics, like I think the South Indians have good phonetics than North Indians. They have good, their language is more difficult. Huh? You guys agree that all the North Indians. So the language and most difficult language is Surinese language or next to Malayalam, right? So Tamil and Malayalam are the most difficult ones. The most easiest one is like Telugu and Kannada. Kannada language. The Kannada who speak Kannada is most easy compared to Tamil and Malayalam, right? Telugu is also fine. Okay. But trust me, the most easy language to learn is Hindi because I don't know what is the reason. It's because of the movies. What is the right reason to say that? Or it will be the language is simple. Obviously, Hindi is most simplest. Hindi, Bengali is also simple. Odia is also simple. But because of movies, Hindi is like prevalent in all the parts of India, even in the northeast. Okay, so I don't want to go into controversy of Hindi and all. I respect everybody's language, culture, rituals, right? And I have a strong feeling that if you're living in Bangalore, you have to behave like a Bangalorean. If you live in Tamil Nadu, you have to behave like a Tamilian. Then you are being true to their culture, right? Don't try to disturb the majority. You know what I mean? So behave and respect. So suppose, right? I don't know how many of you agree, but I'm making a point. So you are just one segment, right? So then you can't be like saying that, okay, you practice what you practice, but don't try to superimpose your concepts on somebody else, right? That's not accepted. Okay. Yeah. So to be honest, in Bangalore, Francis, I don't know, have you been here or not, but Bangalore, everybody speaks Hindi, even the Kannada. So that's the reason it's very tough to learn language a little bit. And now in Bangalore, even everybody is speaking English and all. So you're living in Bangalore only, right? So you know that. So either English or Hindi. If you're practicing Kannada language, sorry, I keep saying Kannada, but Kannada is the people and the language is Kannada. So Kannada language is not tough, but you need some intentions. I think my kids will be able to learn it. So I can tell that. Okay, moving on, guys. Guys, working of RNN is not easy to understand. Okay. How to explain RNN working in a simple way, right? So, I feel, how many of you are like a avid reader? Like you read a lot of books. I like to buy books. I don't get time to read books, but I like to read books. I have all the good books which I need. So when you're trying to read a book, right? Let's understand. This is a very cool example to understand the working of RNN. So suppose imagine a person who is reading a storybook like Panchtantra or any other books, whatever you like. So every time you read a book, right, you start reading each line and you try to also remember what happened in the previous line. I'm talking about us human beings, right? You're trying to remember what happened in the previous line so that you can understand the next line better. Isn't it? And what I'm talking about books like fictional books or Panchtantra ki kahaniya, right? These books are amazing because the story is so tight that you remember things. Like even I remember that Hira Moti Do Bal The, because I studied that Hindi, right? Uh, I only read once Chitrakatha, Chimte. There was a movie. There's not a movie. There was a Eidgah or something where the guy buys the, chimta. Chimta, right? In Hindi we call chimta to flip rotis. I don't know. I don't know. Those who have been in my peers to know this story. Eidgah, I forgot that. Buys chimta. No, yeah, I know. It's Hamid. So yeah, Premchand Eidgah. Yeah, I remember the name of the story. Yeah, so proud of myself. So just imagine, I'm older, so still I remember. So Hamid gives the chimta, that's the tongs, to his grandmother, and she felt shocked and started beating him. Right, but later she got emotional. It's a very powerful story. If you have not gone through this story, Munshi Premchand, he is from my place, right? I don't know, those who study Hindi, those who don't study Hindi, or they don't know Hindi, so you can always say that. So he is from North India, UP, Banaras, right? So definitely Godan, Kafan, what a story, man. So suppose you're reading a story, coming back to my example, I got carried away because that's the impact. Isn't it? You try to remember the previous line, what happened, right? You try to sequentially understand what is happening so that you don't lose the grip. It happens in movies also, right? You go and watch a movie. If the story is not tight, the narrative is not that tight, or it also happens for the classes, right? Suppose I keep jumping here and there and haphazard manner I teach you, you will not be liking me as a trainer. Agree or not? Come on. So I try to go so sequentially that you connect the dots. You are able to connect to what I taught earlier with now. That's where the learning is enriched. It's immersive learning experience, right? So when you go to IMAX kind of theater, who definitely they charge a lot of money from you, but end of the day, you like to watch movies in there because the experience is mind blowing. So when I watched the last Batman trilogy, so I watched in IMAX 3D or something. It was a 2D or 3D, I don't remember, but IMAX is a different screen. Those who have been able to see, it's not in every place is in India, I'm not sure, but definitely it's in Bangalore. So you watch, it's a big screen, right? 88 or something, and then you feel like you are almost into the movies only, right? So why? Because you're able to connect to the dots. What dots? You can only connect to the dots when you look backwards. Steve Jobs said that, right? So that connecting the dots is all about RNN, right? So suppose if I stepwise breaking down. So let's say breaking it down step by step. This is interesting. So let me draw the analogy. So what is the heading, guys? Oh, sorry, I missed to write the heading. Working of RNN. Let's start saying that, let us think, or let us say RNNs as a person reading a book, one line at a time. That's how kids read a book. So before you go and read a book, isn't it? You go in stepwise. What is step number one? Step number one is you read a word. Go slow, huh? So don't behave like adult. You have to behave like a kid. How does a kid read a book? You will read a word, right? Isn't it? So what I'm saying, when RNN reads the first word in a sentence, it processes the word and stores some information. Like suppose a kid, and even adult, suppose you see the word gaslight, and I know you guys are too intelligent, too smart, but anybody who doesn't know what is the meaning of gaslight, don't Google. I know this guys just can Google it in a fraction of a second. That's the power technology has given to you. But trust me, when I was a kid, to know a meaning of a word, it was a tough time. Gaslight. Gaslight is too famous word in the corporate culture. Obviously, what you're saying is like, yes, it's like a gaslight, gas flame, 100% correct. But have you heard the word gaslighting? But there's another meaning to it, which is more important for us, and that's what I'm manipulating. So gaslighting is a verb, right? And generally people do this in corporate culture, psychologically manipulate a person over the extended period of time. Manipulate. Where does it happen? Everywhere. Okay, anyways, I don't want to go into the emotional nerve point, right? But someone can also say that in your class, sir, right? You are manipulating us for the extended period of time, right? I know, I'm just kidding. You don't have those kind of ill thoughts about me. I know that as a matter of fact. But you are also gaslighting, huh? The only thing which I don't do is gaslighting, I never say that you can be the biggest data scientist or deep learning guys after I teach you. The only thing I say that what I'm giving you is not easily available. It's tough. Not everybody is doing that stuff. That's truth. Okay, so when RNN reads the first word in the sentence, it processes the word and stores some information. Suppose you see this word in a novel or a fiction book, right? Isn't it you'll try to remember this word? Think like that. Come back to the real thing which I'm explaining, right? So it's like generally people what do, they used to write in a diary. Srini, have you tried this? So people used to write. So I used to write on a small diary, pocket diary, right? Come on. Pocket diary, everybody. So I used to read the Times of India, the Hindu, and used to write. So that's how. So see, I come from village, right? So I come from like not. So I have a very humble beginning, right? So my career is like, I would say I've come a long way. Trust me on that. When I say that, it was not easy for me to be where I wanted to be. Okay. So I used to have a pocket diary and I used to have a dictionary called Bhargav Dictionary. It was very famous in North India. I don't know, it's still there, Bhargava Dictionary. Not like those Oxford and all. It was more like English to Hindi dictionary for me. So I was like trying to learn English without knowing how to learn English. I spent my teenage in my village, right? So definitely, and I know it's not uniqueness about my story. A lot of people have been, or they're still doing that. Trust me. The only turning point for my career was that I went to Kota. That's the only turning point. From there, things changed for me. And the reason I went to Kota because I was one of the top 3 students in my district. Not like I was dumb and then my dad and my mom sent me. So it's not like I was pushed. I deserved to be there, so I went. But obviously, it took a lot of efforts and money. Let us not go there. It's long story. Okay, so you will note it down, right? You will say, oh, gaslight, I learned. I'll write it. So I'll say gaslight. So I used to do it. Why I'm taking this example? That's how RNN is doing it. Now it has to do digital. So this is something it has to do digital. So digitally, they will put it into the sticky notes Microsoft provides. For an RNN model, it will put in the hidden state. Can you see this? So for RNN, this is as good as saying the hidden state. Interesting, no? So in the hidden state, they store the information. What is the meaning of gaslight? Are you feeling it, guys? So the pocket diary has been replaced by sticky notes and notes in your phone or Google Keep, right? But still the functionality is same, right? You find a word, although everybody reads a word and they try to understand it, interpret it. So to understand it and store the information in the hidden state, I missed to write hidden state. Thank God I saw this of the model. So I'm taking an example. You read a word. Obviously, we are putting in our brain also, but we are trying to take it for sure, right? Brain can make you miss. Model can't miss, right? You understand? So that's why I'm taking this example of pocket diary. So this pocket diary used to write. I'm damn sure some of the guys are still using this pocket diary. Still, we are living in the digital world. I said that in digital world, now this has become your smartphone as a sticky notes on your laptop, right? Guys, everybody notes down, right? Some task to-do list, which I'm saying that in RNN sense, it is going to be in hidden state, right? That is, so I'll write a note. That is your way of storing information. So I'll say hidden state is the RNN's way of remembering what it has seen so far. And don't worry that it will only store one word at a time. No, it's not like that. It stores a lot. What is the next step there in the or working? Step 2 is after reading a word, I would say reading the next word. That's how you read. Just imagine you are like a 5-year-old kid, you're reading a big newspaper. You'll go word by word. Try to close your eyes and resonate with what I'm saying. You will say, Akash, you're making a lot of sense. Because I'm trying to jot it down the feelings of what you have already done. Then what happens in terms of RNN? Then RNN. So I'm drawing a parallel universe or two worlds together, that you're reading a book and you're imagining, and I'm trying to use RNN to explain. Can you see the brilliant way of explaining RNN? I don't know if you appreciate or not, but I'm trying to explain RNN while making you recall what you were doing, like reading a book. You know what I mean? Okay. So then the RNN moves to the next word. That's how you will do. And it updates. This is interesting. Its memory now by combining what it remembers in the hidden state with the new word it just read. You know what I mean? This combination helps the RNN understand the current word better. You know what I mean? Step 3. So what I'm saying, guys, RNN continues to read. Now, obviously, the kid will not keep doing like one word at a time, right? RNN continues this process. The kid will continue to read the book word by word, understanding it, and updating its hidden state each time. So it's like a loop. Every time I read a word, I understand it and update my hidden state each time without fail. Agree? So this way it keeps carrying forward and updating this hidden state to capture the context. That's where funny you get. I know it's a one-liner. Updating this hidden state to capture the context of the entire sequence. The problem is that how long it will go, right? Will it remember everything starting from the beginning of my life? Answer is no. So capture the context of the entire sequence. There are limitations. That's why LSTM is there, right? So don't worry about it. You are in the right direction. But I'll come to that later, right? Before I can demonstrate RNN, how can I say limitations here, right? Right now, I can't say limitations. Hold on. Now, I'll talk about making prediction. That's the last step in the whole thing. Now, your brain is so good. Does it ever occur to you guys? You start making prediction in the next line in the movie dialogue. You start making prediction in the next line in the novel, right? Obviously, the language will be different, but you understand what is they're going to say, right? It has ever occurred to you? Do you also try to do it? Like you must be thinking what Akash is telling or what you are telling, and I'm reading it. So yes, that's how brain works. And look at this, how good they have done it. You should be proud of these guys who have built this. We have not built it, so we are just the consumer or the user of this technology. But at the end of the sequence, right, RNN uses its final hidden state, which basically used to predict. Now they are not doing, so when we are reading a novel and all, we tend to predict, but we actually also read. So it will predict the next word or classify the sentence or perform other tasks. Sentiment analysis is the task. We will do it, guys, here as a use case here, or perform other tasks like sentiment analysis, one of the biggest use case of RNN. In social media world, sentiment and perception is everything. Agree? If you're not happy with me, even I'm doing a great job, I will be replaced. You understand what I mean? Because you don't have the true sentiment about me. You have a false narrative in your head because someone is impacting me, because they are influencing. That's called gaslighting. Psychologically manipulating you. Okay, guys. So yeah, I think this is just a very simple way of explaining how does RNN work. So whenever you're designing a neural network, any one of it, MLP, CNN, whatever, right? First of all, let me tell everybody there are no hard and fast rule for determining the number of neurons in a layer. But it has more to do with what kind of infrastructure you have. For example, iris dataset. There are only 4 input features. I think anybody would take all the input neurons, right? So what we are trying to say that ideally, if it is not like 5,000, 6,000 and hundreds of thousands of neurons, means input variable, you don't need to think about importance. Ideally, it will not be in real world. Okay. But in CNN, you can have like 300 by 300, which gives you 90,000 pixels, right? So 90,000 inputs are there. And that's why we do downsampling also, remember? Using the max pooling and all. So yeah, that's there. But ideally, we see that we try to start with the fully connected, means all the inputs we will take in the input layer and going forward. Okay. The other thing you have to keep in mind is that try to do the scaling. So suppose your input ranges are in some data points are like in thousands, some data points are like in hundreds, some data like in 0 to 1. So always is better to standardize or normalize your data set. That helps your any neural network to converge faster. That is another best practice in the input layer I'm talking. Okay. Now, how many hidden layers we should have? We should have one, we should have hundreds, we should have how many neurons there? So there's no rule as such. Again, I'm coming to that. But idea is that at least the thumb rule says that you should take input neurons and output neurons ka average. So for example, if we have, generally we use, and again, this is like an empirical formula, that suppose I have 700 neurons coming as input and I'm dividing. So take that example now, MNSIT data set. So 784 inputs, output was 10 classes, right? Okay. So anything which is average of these two guys, okay. So, you know, 2 touch size of the input layer or half of it. So 350 neurons you might be having in the hidden layers. Now you know that I have not taken 350, I have taken 8 or 10, right? Because I don't have the power, I don't have the infrastructure. But ideally, I feel that for a MNSIT data set, people start with 16, 32, 64 neurons and they stop it because of the computational challenges. But ideally, in the best practice, we have a big machines, you can take 50 to 200 neurons. Again, I'm saying there's no rule, there's no formula someone can give you that, okay, these many neurons you have. But it will only come with the right set of questions. Suppose I have a big machine, I would still try with 50, 100, 200 neurons. If I have a small machine like my normal laptop, I'll not be able to go beyond 8, 32, 64 max. Okay. In a hidden layer. Because it's a sequential transformation, right? So you can have more hidden layer, but within a hidden layer, number of neurons, you have to be very smart about it. Ideally, I start with 8 neurons. You will see 8, 16, 12. Okay. The best practices is that don't do underfitting, don't do overfitting. How will you know it? You will only know it when you run iteration. There's no other shortcut. That's why you have to keep iterating, keep thinking about it. Okay, I know there are some website they will give you a formula or something, but again, I'm telling you, reading a lot of research I have done, nothing works like this. You have to do some overfitting handling, you can do regularization, you can do dropout and other stuff. So we have already covered that part. So, images can be noisy, and I think I want to show you one quick screenshot. So how does an image which can be noisy looks like? I'll put it here. So this is your having noisy image at sigma 90. And so, right, this is the clean image. You see there are a lot of jittery or noisy dots, right? But you take this image and then you denoise. So that's why I have to go into detail to explain that you have come from 9.05, 9.49, right? This is your power of signal to noise ratio. It's communication electronics background guys would know more. And you're using BFS CNN, right? Your image, which was full of dots, as you can see, it gets really better from here. If you go here, right? It's almost as close to, close to this part, not like 100%, but at least it gets smoothen out, right? This is called power of signal to noise ratio. You can Google about it. So I have done BTech electronics. So this is power, signal power to noise power. If it is more big number, your signal has less noise, right? Means good signal. It's like a good signal. Signal is as simple as that this image. And if this is less than 1, means your noise is dominating. Much less than 1 means you have bad signal. In this case, it means you have a good image, or here you have a poor image, or you can say a noisy image, or this could be your denoised, or I would say less noisy image. So that's why if you guys focus 9.05, it's almost 3 times, right? 3 times. If it was 27, 3 times the quality of image has increased. But you will hardly see any difference between these two. So now again, they're using a technique called BFCNN. So you will ask me, what is Akash BFCNN, right? BF is bias free, so obviously I can't go in all the details. Okay. Let's talk about RNN architecture. You know that RNN architecture is going to be from your neural architecture. Neural network architecture, it's a feed forward. Let me show you. This is a feed forward. So you go from one layer to another. So I'm excited about that. This is your forward propagation, you can say. Right. And you know that you have another layer. So this become input for the next one, and likewise. And finally, you have an output layer. You know what I mean? If you go back, it called backward propagation. You have seen this in neural network, CNN. So you know that when you are going to do forward propagation or forward pass, you predict. This is your prediction phase, right? So during the prediction phase, right, there's no context getting about, right? It always try to take a new word and understand the context better. But since there is no sequence, there's no order, and in forward propagation, it keeps taking the output and making an input in the next, and so on and so forth. So ultimately, it doesn't do anything like this, right? In the forward propagation. In the backward propagation, right, that is your, obviously backward propagation and forward propagation, they are a little bit different. Why? Because you train while you are updating it, right? You go back and update your parameters and the training phase is complete. Ideally, to be honest, it is combination of both. So if I say forward plus backward, together the combo thing makes your training happens. But when you are doing prediction, right? When you're doing prediction, right, it doesn't do anything. It just takes the data and predict for you, right? There's nothing you fine tune in the output. So far with me in the neural network. But what RNN does, RNN has internal memory. And let me show you this. In terms of architecture, I'm saying. So if you see, I have already written few of the things. So if you compare, this is a feed forward neural network, guys. I'm just saving some time. And if you observe, I have highlighted something, this part. Can you see there is a circular loop on this node itself? I think someone also wrote that. So this is what helps you to do. It helps you to store in the internal memory. Do you see that? You can't do this here, anything like this, right? There's nothing like this. So I can say that no, I can say that there is no internal memory. So that is the biggest difference in the architecture itself, right? Okay. So what I'm trying to say, my dear, is something which is having everything. It has a hidden layer, but you know, it also use output to store. Okay. So I'll show you one architecture. Just pay attention. I'll explain everything here. That's why I'll not go into too much of mathematics because trust me, mathematics is super heavy here. But what I'm trying to say, and you have to pay attention to understand. So I'll just write one pointer. RNNs allow previous outputs to be used as inputs while having hidden states. Now this line has a lot of depth. How we will see. I'll try to show you. It's not easy to show you within the box. Here, understand here. So here XT represents sequence of inputs. Sequence of inputs. Okay. Now we will also break it down that what do you mean by this? Sequence of input, okay, but what do you mean by sequence of input? It is contextual. Contextual. Depends on the context. green boxes at the bottom denote the input sequence. About yesterday. Now we are labeling as what? So this T is like what? X1, X2, so on. A. So green box input sequence. This sequence can be as simple as that. Listen to me. Input is a sentence. If I say input is a sentence, then each X T could represent a word or a character. Are you getting? Could represent a word or a character. Right? Sequentially it will go. I'll also take an example. Don't worry about it. So now you understand. I will elaborate this diagram now. Moving on. Second is what? Hidden states. Hidden states. See, hidden state will be there, right? Hidden states will be there. Hidden states, we are saying that the blue, can you see that is what? Let's say in the diagram, blue rectangles in the middle represent the hidden states. So let's understand the game of the land, right? So at least you know that this is the place where they will store the memory. So think like this. These are all your X's, right? So this guy is going to store the memory. I meant to write here this side. So all this part is going to store the memory in this diagram, which is in terms of this architecture is the same thing. So what I'm saying, these hidden states maintain the memory of the. So let's understand the first. What I'm saying that each hidden state AT carries the information from the past. Past inputs up to the current step T. Okay. So what I'm saying is that in a basic RNN setup, paying attention, the hidden state AT is computed, right, at any point T is computed using the current input X of T and the previous hidden states. And what is going to be the previous? previous hidden state. Now you guys are getting hang of it. T minus 1. Then you can put T equal to anything, 1, 2, 5, 6, 7. So this is how sequentially it is capturing, right? It's not jumping to it. Okay. This is your second thing in that architecture. Third is what? Outputs. Notation is telling you loud and clear. I mean the green, the pink boxes. So pink boxes are like your output. Okay, I'm talking about this one. Here actually they're calling red boxes, but that's fine. So let's write. So red boxes at the top denote the outputs of the RNN at each time step. Okay. Labeled as Y1, Y2, Y3, and so on. So I'll show you again. Look at this architecture. Now it makes sense. So what you're doing, guys, apply your ATwala method. So Y1 is going to be what? Taking the current input and the previous hidden state, right? So it will be what? X1, taking the previous 1 minus 1, A0, getting the Y1, okay? Then this Y1 is going to get stored here. So when the next time you do X2, it will come A1, taking the previous and using X2 as the current input. It is already capturing what happened here, right? And telling you this. And then it keeps moving on. Make me. And that is, I love ice cream. At least everybody loved ice cream when you guys were kids, right? Let's say this is a sentence. Hello. See how, okay. So I love ice cream. Ice cream anymore. Yeah. Okay. So the first thing, guys, if you see here, what don't say cream, guys, it's coming from left to right. So processing the first word, which is I. Okay, first word I. What will happen here? Now to process this, RNN will start with some initial hidden state. Generally, it will be set to some standard random values, right? You remember that? It can be as simple as zeros also. Then I will be passed into the network. RNN processes the word I and updates its hidden state A1 based on the input I. Okay, so I'll write a few things so that you don't miss it later. So I'm saying, guys, number 1 point, RNNs starts with an initial hidden state, usually initialized to zeros. In the coding, you will see that, or random values. Guys, you really need a hidden state, right? So you need A0, okay, for the first input. Don't worry. The first input I, it will go to the network. First input word. What is that word? I know it's one character, but you are going to pass into the network. Now network processes this word. RNN network will process this word, right, using this blue box, which is your what? Remember, no, blue box is your hidden state. Using the initial and the input, it will process it. That's how it works. And store it in the memory. Now this seems like a black box for you guys, I understand, and we have to keep it like this. RNN processes the word I and updates its hidden state. Now you might be curious that I'll try to go a little more deeper, but I am skeptical about it. Need to keep it as per the syllabus. So you're going to make this learning happen. So you will say that hidden state. Sometime no literature also write A1 or H1. So both are correct. Don't worry. H for hidden, so that's why they use H, but people also use A. I'm using A, so I'm. The next part, guys, you tell me. Next word. We are not worried about space here as of now, Masrad, to answer your question. And in NLP and in other tools, there are ways to ignore word spaces and few those things. Processing the second word. What is the second word? I think love, right? I love ice cream, so love. The whole word will be getting into the model. Sequence is very clear. I'm just explaining the sequence. Second word, love, is passed into the network, which is your RNN network, along with the updated hidden state. Now this is something tricky and you have to understand. Guys, remember when I started the hidden state, it was initialized to random values of 0, right? See, usually set to zeros or random values. When this first process was done, hidden state got activated or updated with the word I. Clear, no? So what it's saying, second word love is passed into the RNN along with the updated hidden state, and that is your H1. Or we also write A1. So what I'm saying, I'll go and see in the show in the diagram. Here you had brought I, good. This is your love. So what happened? I is already being captured here. Now the next time this I will be going along, please pay attention. Or I'll use different color so that you don't miss on it. Are you able to follow what we are doing, guys? This I is already captured now. It will go there. So next time when you go here, it is already having what is already updated in there. I love, right? So then the next time you will see, it will see ice. So I love ice. When you go next, it will become I love ice cream. Clear? Sequence you are able to understand. I know you have tons of questions in your head. How does it do it? What is the science behind it? Ideally, when I say science, it's the maths, not the. RNN uses the hidden state H1 or A1 along with new word. And what is the new word we had, guys? Love. And this to produce, alter the hidden state, right? So to produce a new hidden state called H2 or A2. Cool, no, guys? Thing you can say processing the second word, moving on to the third word. But this is how the model updates. I told you. And the next will be processing the final word or the fourth word, 3. S2. S2 has is I love as the word. When you go to this, you will get H3 or A3, right? And you will get I love ice. When you move to the fourth one or A4, you will get I love ice cream. So the whole context is getting captured. Now the question is that how does RNN hidden state understand I love or I love ice cream? That is something we are trying to understand a little more in detail. See, obviously there's a mathematical scene. below under the hood. There's a concept of word embedding. Have you heard embedding? Now I'm trying to deep dive my idea. So there's a concept of word embedding or semantic or sequential. And let's say you're trying to write a journal. So you wrote something, but then you slept because it was pretty late in the night. Again, you came back and picked up. So isn't it when you did something here, till here, it is all stored in the journal, which is your hidden state. And then you again put your input from the mind or your journey and adding further. But what I'm trying to say, when you say I, you give a letter I or a word I love, what it converts into the vector in NLP also. So it's like converting the characters into numbers. You know, vector, embedding vector. So I will also write, else you'll forget. So what I'm trying to say, how does RNN process the word I? And in NLP, I will be literally doing this. You will understand. So processing the word I, what it does in this, it transforms, it's a transformation, right? Transformation, the word I into an embedding vector or embedded vector, which is basically in layman term, numerical representation. You know, right? Our algorithms, our machine are all 0, 1, 0, 1, right? It does not understand English, Urdu, Farsi, Tamil, Telugu, right? So it has to be a numerical representation. What is this is does? This is the first thing it does, that it converts into a numerical representation. The beauty of this numerical representation is that it captures the semantic meaning of it. Now, what is the word semantic? Idea of NLP. Semantic meaning of the word I. Obviously, we know I means मैं. I love ice cream. मुझे ice cream पसंद है. So, semantic meaning of the word, in this case, I. What is the meaning of semantic meaning of the word I? You know, semantic means relationship between the words, right? So you must have heard about lexical semantics. So it's like, you know, denotation, connotation. There are a lot of things, to be honest. But suppose, you know, you're trying to understand what with the context is called semantic. I don't like ice cream. It means you just not only know the information, you also understand that person does not like ice cream. And if he tells that, you know, I don't like ice cream and some reasons, you know that the person does not understand does not like the ice cream with this reason. So you understand the whole context, yes. Because it's very important that context is here. I'll give an example. I walked into the bank. One sentence. So NLP, well, NLP started, guys. So now I think you'll be feeling happy about it. Sentence 2, I walked on the bank of the Ganges. Now you understand the same word bank has two different meanings because context is changing, right? One is your financial institution, right? It's like more like your bank, PSU, private, but it's an institution. And this means side of the river. Side of the river. Agree, no? So this is what we mean when I say captures the semantic meaning of the word. Although I here is very simple, there's no confusion, but this is what you have to see. Semantic, I'll also write one-liner so that you don't miss. Semantic refers to the meaning and interpretation of the word, and it can be not only word, it can be words, phrases, sentences, and symbols too. All right. I'll tell you another example. Right? Brick in the wall has one meaning. Brick in the wall. It's like we are talking about there's a wall and right, and there is a brick. So brick in the wall. Right? You understand what I mean? Or bricks in the wall. But if someone like one sentence, we are just brick in the wall. You know what is the meaning of this? Now the two things have different meaning altogether. Trust me on that if you're not believing. Very good, Francis. So we are like one brick in the wall. We are insignificant. We are like one drop in the ocean. You know what I mean? One brick in the wall. So now this becomes like an idiom. Very good. This is just like a phrase. Meanings are too different, right? This is actually meaning brick in the wall. Right? This is actually meaning brick in the wall. But here things have changed. Why? Because it has different semantic meanings. So we're saying that semantic refers to the meaning interpretation of the word, sentence, and symbols. The context. Okay. I'll highlight this. Good. So I'm saying that processing the word I was saying that processing the word I, converting it into so model tries to understand the semantic meaning by converting this into a numerical one, and there is a lot of going behind the scenes, so we can't go into all the detail, but are you getting the functional understanding of it? That's my max. Once they're processed, they know that, the model knows that I is like a pronoun. Hello? What is I in English grammar? Pronoun. So model knows that. So I'll just also write that. So once hidden state. So now once the processing is complete, once processing the word I is complete, the hidden state H1 or A1 now holds the information about the word I. Now this is the very first word, and it can be as simple as like, it has not a lot of meaning to it, like recognizing it as a pronoun. But it's a good identification, na guys? And model would be able to understand that pronouns are generally the subject. Hello? Pronouns are generally the subject of a sentence. Come on. He, she, I, right? These are all pronouns. You know, he, him, her, his, her, right? He, she, his, her, and him. Okay. Subject of a sentence. Now, guys, those know grammar, they know there is subject. I don't want to teach grammar. You can refer to Wren and Martin. So what we are saying that now model also understand, my dear, that this sentence which I'm going to look at in some time is going to have a sentence. So in essence, I'm saying in essence, now your H1 or A1 is now aware of the fact, see this is how the model is learning, is now aware that the sentence has a subject. This is a big learning for the model. Now again you can question me, but how is it learning? That's what I'm trying to not go into, and it's a little difficult. Now once you do this, now I will process the next. Yeah, how is the mathematics? That's right, and that's what I'm trying to avoid, because see, I have some, see, to be honest, I know exactly what happens, and trust me, I know, because it's all my interest. To be honest, I was not taught. Processing the word love. Let's move. Let's spread the love here. Okay. So the moment you will bring love, already it knows that you have, and subject I, and the next word love will make that the subject love something. Come on, think it. Take it like a how to say? Think like you are a machine trying to learn something. So I is the subject. That subject I, which we are referring to, love, is what? Something will come. But what is till love, right? So when the next word come love, again it does the same thing. I'll write it again because so that I'm completing it. So when the RNN receives the second word love, it transforms obviously this into the word love into an embedding vector. Again, the numerical representation. Which is your x2, right? Which captures the meaning of love. Okay. Now, next thing happens. This is the first step. The next thing which happens is what? It also updates the hidden state by combining x2 with the hidden state h1, or I have been also writing a1 with the hidden state, and this is your previous hidden state. I'll write in bracket. Which already holds information about I. Which already holds information about I. Very good. You guys are getting hang. I know, at least I can give you what is the maths looks like, so that you don't say that Akash did not tell any maths, but I'll tell you the maths. How does it look like? The first update we did, it looks like this: h1, or you can write a1 equal to tan hyperbolic. So the activation function we use here is tan hyperbolic. Weights hx multiplied with input. This is what we do, weighted sum. Weights into the input plus WHS, HH or HS, how do you pronounce? H0 plus BH. Don't worry, I'll explain the terminologies. That is what? So here WHX is the weight matrix. But guys, I'm just telling you for your curiosity. I was trying to avoid this. That connects the input to the hidden state. Okay. And you can clearly see, right? H in hidden state and X is what? Your input, right? Observe this, guys. Cool. What is your WHH? This is like weight matrix connecting one hidden state with the other, right? So weight matrix that connects. Both are H means hidden state, which means connecting the previous hidden state with the current. Can I say that, guys? And it's important now that you have access to current as well as the older. BH is the bias term, most easy term to identify. Bias term, and tan H is another easy term, and that is your activation function, tan hyperbolic. Right. So this vector, this mathematics will handle everything for you guys. Understand? Let me write here only. Tan H is your hyperbolic activation function, tan hyperbolic activation. Now, for the second layer, it's the same thing. Now look at the beauty. You will understand very fast. So this is going to be a hidden state, H2, come on, H2 or A2 equal to, so tan H, again hyperbolic, WHX, input, right? Second input plus, what is your second input? The word love, the embedded vector love, WHS dot H1 plus BH. See guys? So if you remember, here I had written this H0 if you're paying attention, my dear. See this. So you're updating the activation function, sorry, hidden state, and you keep adding this. Now, can you see that? Take a pause and very good, right? So does neural network gives you this functionality of embedding one input to the other? No, right? There's no way you can. Now, question from Francis: why tan H is used as activation function? Because you need to understand. Number one, the range is from -1 to 1. Okay, so it can take both negative and positive values, and you know that text can be also positive and negative sentiments, right? So definitely it helps you to handle the zero center data very well, because I don't like ice cream can be another word, right? Sorry, another sentence. I do not like ice cream can't be on the same side as the I like ice cream. It's opposite, no? It's like positive sentiment and the negative sentiment both are there. If you take sigmoid or some other activation function like that, then it will only be focusing on the positive side. Oh, you don't like ice cream. Oh, you like ice cream. So even someone is saying, I do not like ice cream, you will make it positive and understand that, oh, he loves ice cream. You understand what I mean? So it is important that tan H is there to handle the positive and negative values. That is the biggest reason. Your question, Francis, why do we use, writing proper English, tan H as the activation? So now answer is, I'll just write the answer. So tan H function ranges from -1 to 1. I hope you know the graph. I'll show you in a moment, from -1 to 1. Okay. Which means that which means it produces both negative and positive values, which is advantageous, which is an advantage, or which is advantageous as it centers the data around 0. So neutral comment will be around 0, center the data around 0. So neutral comment will be around 0. Positive comment will be on the positive side, negative will have negative side, right? And because of this very clear-cut demarcation, your model becomes better, so making optimization and convergence faster. Right? It's very easy to find the appropriate answer, guys. Come on, yes or no? The whole idea is to make the model converge faster, obviously accurate. Activation function is a lot to do. If you take sigmoid squeezes between 0 to 1, so it's more like non-centered output, and that can lead to slower convergence and also the not the right fit for something like RNN. Better? So you clearly see that the range means Y, by the way. Range is Y, okay. Domain is X. Those who are little weak maths. So range means Y values. Let me write here. I think those who are good in math, they will understand what I'm saying. So what is the range for sigmoid, guys? So range for sigmoid, you can clearly see between 0 to 1. See, the lowest value is 0. The highest value is 1. I have this power, right? Why am I not using it? Come on. See? So 0 to 1. This is for sigmoid, right? What is the range for tan H? -1 to 1. And this is your sigmoid. So why I keep showing this nice charts and all, my dear, because you can see the beauty in the concepts. So obviously it is a better data, right? So now what I'm saying, guys, because of this, what I'm saying now, guys, because of this, write a note. If someone asks in the interview, you just say. So that's the reason RNNs often use tan H. It's not like this is the only function you should use and all the time, but it's one of the most preferred choice for modelers, as the activation function, as they need to capture what RNN model need to capture, which I've been telling you guys, both positive and negative relationships. This is reality. Life is not always rosy. It has also thorns, right? A lot of thorns. Both positive and negative in sequential data. Like I said, no. I love ice cream is one sentence. I do not like ice cream. It's another sentence. This looks like positive, those who are ice cream lovers. But the moment you see this do not, you know that that person doesn't like. So positive and negative. Color coding, I did it. Now the next topic is recurrent. But before I go there, I want to just give you a summary of why recurrent networks are so special, right? So now summarizing the RNN. Okay, coming on. Internal memory. So this is important. This is the key features, right? And key features in contrast with what? How is it different from neural network? Because this is also neural network, right? Recurrent neural network. But how is it different? Someone can ask this question like one guy can ask in the interview. So I'm summarizing this because I have taught or talked more from neural network. And when I say neural network, like all of it, ANN, CNN, so I should rather write for other neural network. Obviously, it has its own swag. India is losing match here, one after the other. Okay. So RNNs have an internal state. We just saw that, the hidden state. That allows them to retain and leverage information from previous inputs, which is crucial for tasks where context matters. Okay. That is why internal memory is one of the coolest feature it has. What is it? Sequential data handling. It doesn't handle data at once. So, picture. So RNN, what you're asking, specifically designed for working with sequences. Okay. Making them ideal for applications like speech recognition. This is your summary. You already have been taught. Sorry. Language modeling, topic modeling. These are some real use cases in the businesses. As a matter of fact, time series analysis also. For time series analysis or models, you can. Okay. Now, contextual understanding. Does your neural network or CNN understand context? No, no way. So RNNs can interpret in the context of prior information. So RNN is known for contextual understanding. When I'll do a model, I'll try to show that the kind of promise I have done to you guys, done with you guys, which is essential for understanding the meaning and the flow in natural language tasks. and flow in natural language tasks. And last but not the least is dynamic adaptation. So RNNs continuously updates internal states. Continuously updates internal states, allowing them to adjust to evolve patterns within the sequence. There are different versions of RNN architectures, and there are different types of RNN, guys. So let me show you one by one. Can you see it? What I showed you at the first thing is your one-to-one. You see their pace here. See, it's one-to-one. So this is your traditional, neural network for the RNN. I did write recurrent neural network. As you will start thinking, oh my God, this is a neural network. No. Okay, one-to-many, right? One-to-many. So one-to-many is used when you give one input, right? You give a single input and network result in numerous output, right? So generally this is being used in the music with me. So more. So you can clearly see that I'm giving just one input. See, this is the input. Let me highlight. This is the input and output is getting as an input. See, so that's why you're getting only one input and many can generate, many output can be generated. Okay, that's the point. Now, let us think of why. So this is very simple. This is something I've already seen. Any idea, any thoughts around one-to-many? So this is the new. So how does it help? Sa is a sur, right? But that can to make multiple music, right? Musical notes, different. So what it can do, you just give input and it can create a whole sequence of patterns basis that one input, leveraging the training. So what I'm saying, a musical note, trust me, I can't show you as like a demo, but a neural network in here, a RNN is given an initial note or theme as input and then it generates a full sequence of musical notes based on that input. Someone can ask me, Akash, any Google Magenta is an, so you can give a short and then right can create the beats class. So I give you the example, you can go through it later in your own time. And if I find time, I can show you that. So there is something called MuseNet. And there's another one, Magenta. It's not the color. Magenta use neural networks. Mostly we are talking about bunch of neural networks. That's why I'm writing neural network to expand on a small piece of input node. and create longer moving on to many to one and so another two architecture, guys, see. So many to one is, so now if like you give me a feedback, right? Suppose someone is very into, they'll write it that trainer Akash feedback. So now in this, so many inputs you can give, right? Many. So you can give many, writing full on about me. Now overall, it can be a, okay. But ultimately, guys, it will be what? Out of out of 5 star, either you will give me 3, so you'll say 3 star. Are you getting what I'm saying? Or 4 star if I'm lucky. Okay. So what I'm saying that ultimately it will come as a score out of 5. Let's say it is 4. So isn't it not? Are you giving a lot of inputs, so many inputs, finally translating into that he is good or he is very good, right? He is bad or he is very bad. Agree? So you might write 100 inputs, words, 100 words, but finally it will conclude to this one number, 1. Got the example? Now this is very named entity recognition. So named entity recognition is a common task in natural language processing. What is natural language? The language we speak is natural language processing. It's a big area. So this named entity thing that involves identifying and classifying and in text. So entities are all in text into predefined categories. And I'll show this in NLP, such as names of person, organization, location, dates, many more. Like an Indian name, right? Organizations, locations, dates, and many more. It has a huge list, by the way. So I'll give an input to the model. I'm saying that Apple is looking to buy. Apple is looking to, Apple Inc. is looking at buying UK startup for $1 billion. It goes into RNN, this input, RNN model. The output you will see the same sentence, but it will be able to classify real quickly if the model is trained. It will say Apple Inc. It will know that it's an organization because of the database information. Looking, buying, right? It will know that this seems to be actions. So Apple is doing some actions, right? It will also know UK means it knows that it's a location, it's a country, it's right? It's a country. That's what it means. It understands line by line, guys. Startup, again, it will say startup means what? It's an organization, some organization, but the name is. And the language thing we can, and if I say this is $1 billion, so billion is the amount. So it knows that it's the money, and it also knows that what is the currency. Because the model has been. This is how does the output looks like. See, person, Steve Jobs. Organization, it knows that Steve Jobs is a person. Organization is Apple. Location is Cupertino. Cupertino. I don't know how to pronounce. Date, third, time, money, percentage, product, event, Golden Gate Bridge. You understand? So it understands a lot plan you can expand, right? So that's why Google Translation, I'm talking about the Google Translate. So if I say something in English to Hindi or English to Tamil, the number of words for the sentences I have spoken will be different in different languages. Agree? I'm talking about the number of words. That's why it's called many to many, but we don't know is it going to be equal or not. So I can give you a scenario. So people learn French. A lot of people are learning French to stay in Europe. So someone is trying to learn English to French. Okay, so how does it work, guys? What it does, so there is a model. So sequence to sequence, it's called sequence to sequence, which is SEQ to SEQ, model with attention. Yesterday I was also talking about attention mechanism. Processes, obviously it is out of your syllabus, and input sentence in English, but understand the use case so that you have awareness, and generates an equivalent sentence, not equal, equivalent. Why I'm saying equivalent sentence in French, the meaning and the context will be same, but it will be slightly different, right? It's not going to be exactly same. The same feelings you can't get. So if I try to speak Kannada in Bangalore, I can never be like Kannadika because they feel the language. I will be just speaking it. Okay. That's what I'm saying, no, Srini, you have to understand the feel, and that's where the machine will not feel. It will just translate for you. You feel and speak. It's not trying to speak for you, right? That's why if you see all the AI robots, they just speaking. The encoder reads and understands, right? So there is an encoder and decoder. So encoder reads and understands the input sequence, and decoder generates the corresponding translation. Word by word. Here in this particular use case, tone is not a thing. That's like Google transformation, right? Sorry, Google translation. It just generates the word, right? So if I say, can you try the same thing here? See, I can't show you this or can't make you listen, but if you try this, it will just read. There's no feeling. I love watching, right? You will see that it does the same thing without any, it's just a translation, my dear, okay? It doesn't give you a feel or vibe. Agree or not? Just do it and tell me. Now tone is coming with AI and all. Google Translation is like one of the best use cases in the world here. I've already talked. Let's talk about, limitations of constraints. So one of the biggest constraint, which is a topic for the interview, please note it down, and that is called, that's I'm next session, but I'm giving a teaser. Explain. But this is one of the biggest interview, one of the top-notch interview question. If you can Google it, you will find vanishing and exploding gradient problems, right? It is really an issue. So what is the issue you will see in this model during back propagation? It's like, okay, the gradients of loss function with respect to earlier layers, gradients of loss function with respect to earlier layers become extremely small. If something is vanishing, means what? Gayab, right? In Hindi. Become extremely small, right? That's called Gayab. Or it can become, so, it's like very small, that's a problem. Or it can become extremely large, right? That's called exploding. So I think I am 6'2". I've exploded in each direction, 3D direction, XYZ. Okay, not good for my health, but definitely I'm exploded. Someone who might have lost weight and that guy might have vanished. Okay, so both are problems for us, isn't it? We don't want that. We need balance in life. This is the biggest issue, and this will only happen. Let me also tell you, this issue is not like it happens all the time. This issue comes when you have long sentences. Sometimes I keep talking, right? Or there are people who will, suppose they want to go to somewhere, they will just keep talking. This issue is especially when someone using a lot of words in their vocabulary, right? And there are people who will just say something in, right? They'll just give some signal and they will understand. Guys and the girls, they communicate differently. So this issue is mostly with the girls' conversation and with the guys' conversation, or bhai bata kya, that's it. You know what I mean? So I'm not trying to be sexist here, don't feel, but nowadays even guys are talkative a lot and all. I'm one of the talkative guys, so don't take it otherwise. But I'm just trying to make you remember or give you a mnemonic to remember this. Now, what happens if you keep giving long sequences, right? The model needs to. So this is the issue. But this is the issue. What is the impact? When the gradient become very small, let's talk about very small. Is there any intelligence added in the next layer? So earlier layers receive very little information because there's no intelligence, right? Very little information during training. So your train model is crap. So all the earlier layers, they receive very less information during training, making it difficult for the network to learn dependencies from earlier steps. Make sense? From earlier time steps. Now I know you might be thinking in your head, how little or small gradients are related to these. Now, second point, which you guys were telling, maybe might have done some Google or might have known from your earlier or prior information, RNN has inherently difficulty with the long-term dependency. Difficulty with, that's a second important drawback or limitations. So long-term dependencies. So what do I mean by that? I mean by that, the issue is here, RNNs struggle to capture long-term dependencies in data. So what we are trying to say, as the length of the input sequence increases, suppose you are giving 100 words, or even I would say here in this case 50 words, model is totally gonna screw up. And what is the reason for it? Because RNNs tend to forget. It's like Ghazni. It has some limitation, na? Ghazni has limitation of how much time? 15 minutes, right? So it has limitation in terms of short-term memory. So RNN tends to forget the earlier information due to their short-term memory capacity. This is the model drawback. Now you can always question me, prove that it has short-term memory like 1 MB. I can't prove that, guys. Then you have to go into the depth you have to go to 30,000 feet under the ocean, okay, which is not the scope. If you want, obviously I can also get crazy when I have to explain this, because that is not something so easy to explain. It has a short-term memory capacity. So what I'm trying to say, and that's the reason, remedy is what? Who is going to save you? So the remedy is LSTM. Okay, that's where the topic. So model is not able to remember things, and to a point it has to do with this gradient issues, because long-term issue creates problem. So this model becomes like Ghazni. This is just a way to remember. Okay. Ruchika, we can say that when we have long sequences, then yeah, exactly my point. Yes, exactly. Now, what is the impact? So don't worry, vanishing gradient is something I'll go mathematically and tell you when we meet again. I think I did not discuss this. I have not done this. So impact on what kind of tasks? So tasks like language modeling, right? So language modeling means what? You have to actually read paragraphs, or topic modeling, right? Or understanding contextual meaning of a para, right? Suppose someone has given an abstract and they are saying, do you understand what is the gist of this? So suppose I give you an article of 200 words from a newspaper and I ask you that give me a headline for this news, right? Then this model would fail. Agree? Suppose you're working in a news agency and you are looking for some catchy headline. You need to understand the news, right? So generally people write the news and then they look for heading. You know that in journalism. So news headline has to be catchy, still capturing the essence of the article. So in this kind of work, these kind of models won't be able to useful. Won't be. The sequential nature is going to create issue, and that is something called lack of parallelization. Right? So lack of parallelization. So you know what? CNN, unlike other models, it can be processed in parallel. So Masrat. So unlike CNNs, where operations on different pixels can be processed in parallel, RNNs process one time step at a time, right? Isn't it? X of t, 0, 1, 2, right? So RNN process one time step at a time. You give one word, you give one big sentence, doesn't matter, but it will only process one time. Let me highlight, process one time step. So what is time step? This is your time step now, T0, T1 at a time, which prevents parallel processing. Now this is the issue. What is the impact? Impact is longer training time. Right? Training time will be longer, na? Dhire. Longer training time and inefficient utilization of hardware. Suppose you have a nice GPU, paid some $10,000, but you're not able to use it because it doesn't allow parallelization, right? Not paralysis, parallelization. So it is going to be inefficient utilization of machines or hardware. I'll write machines. In bracket, I'll write hardware. So these are some, top of my head, these are some issues.
Just a quick info, guys. Intelepath offers artificial intelligence course training, which will enable you to learn skills like neural networks, focusing on CNNs, RNNs, and their application in AI, natural language processing, computer vision, and generative AI. Through this course, you will also master deep learning concepts, AI model building with TensorFlow, transformers, BERT, GPT, LangChain, and NLP pipelines with advanced techniques like image recognition, chatbot development, and much more, all taught by top 1% experts and IIT faculty. And with this course, we have already helped thousands of professionals make successful career transitions in AI and data science. You can check out the testimonials on our Achievers channel. The link is in the description below. And without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take your first step towards the dream career growth in the field of artificial intelligence.
Natural language processing, that's the topic. So I think I would like to start with this bullet point. NLP is one of the hottest areas in AI. You will be surprised to know that you have more jobs even with respect to jobs. Number of job openings. What is natural language processing? So natural language processing, NLP, I'm not talking about NLG. So natural language processing is a branch of AI. AI is artificial intelligence focused on enabling computers to understand, which I saw some of the guys have written, understand, not only understand, we have to also ask them to interpret and respond to human language in a way that is both meaningful and useful. Now, this is very important line, meaningful and useful. See, meaningful is one thing. So if I'm asking something, but you're saying something that has some meaning, but is it relevant for me, right? Suppose you ask Alexa or anything like that, right? Tell me something about air quality index. Air quality index, if I'm asking, right? What is the air quality in my area? For example, and I say in Bangalore. So let's say Alexa replies, air quality index for Delhi is 300, right? Is it useful for me? It's meaningful, right? Obviously, Delhi air quality index is telling me it has some meaning to it. But is it useful for me? No. Relevance is the key, right? I want to know the cricket score for India team. They are telling out it's telling something else. So that's why it's very important that machine needs to understand. See, first thing is that understand. Then machine can interpret what I'm asking so that it can respond, right? See, it's all in like sequence. If machine cannot interpret, can it respond to it? No, there's no way. Understand, respond. So this is step 1, followed by step 2, and this is step 3, right? So any time when you're explaining NLP to anybody in this world, you have to come to this part of the definition. Understand, interpret, and respond, right? Now you might be thinking, Akash, what about NLG? Obviously, when the machine responds, it does the NLG. So it's like implicit definition of NLG is already being captured here. Suppose if I am talking to Alexa, correct? Yeah, it's Amazon. So guys, again, no marketing intended. Okay. Suppose I say something to Alexa, right? Same question. So I'm asking, yeah, Alexa, Siri, whatever. What's the air quality index in Bangalore? Let's say I ask a general question. Alexa says, air quality index for Delhi is 380, whatever. So definitely this is not relevant for me, right? Why I'm putting a cross? Because it's not relevant. But it is meaningful. It has the correctness to it. It has some meaning. Let's say Alexa says, okay, good. Obviously, I'll say, Alexa, what are you doing, right? Tell me for Bangalore. So let's say air quality for Bangalore is 150. So now, between these two things, right? These two conversation, right? There must be few things going on, right? Obviously, I ask a question to Alexa. Alexa, understand, interpret, and respond. Till the time it processes and understand and respond, right? Everything comes under NLP, right? Even generation has that. But definitely here, Alexa has generated something, right? Do you see, guys, what I mean by that? When I say that, Alexa has generated the natural language. So when Alexa talks to you, Alexa is doing what? Right? Alexa is doing NLG. NLG is another terminology. So it is natural language generation. This is NLG definition. One more line which I want to write. NLP mathematically, if you think, from deep learning and machine learning side, if you see, NLP combines computational linguistics. Now this is a new terminology for a lot of people here, right? Computational linguistics with ML AI models, right? So everybody started with ML, then moved on to AI to process and analyze large amounts of data. And trust me, text is something like large amounts of data. Now, though ChatGPT is like with the LLM models. Okay. Let me talk about it, guys. Shall I talk about computational linguistics? So any college you have studied, right? There must be a linguistic community, right? So don't think it's like, so similarly, when we are building this NLP, Later on, they coined this term called computational linguistics. Now there is no poet, there is no author. Everything is a machine. That's what computational comes into the picture, right? So it is an interdisciplinary field that combines linguistics, and computer science. So these are two things they combine, linguistic and computer science, to model and analyze human language. Let's talk about some key areas in this field. So what could be the key areas? I think one which I feel is very much in demand is language modeling. Topic modeling is one of the key areas within this language modeling. So let's understand what is language modeling. What is the objective of language modeling area? So those who are working in this field, their objective is to predict the probability of a sequence of words. Predict the probability of a sequence of words. So I think Smart Compose is a little far-fetched here, but examples like, speech recognition. Guys, speech recognition, when we speak something, it writes, right? It types. Have you done this in your phone? Rather than typing, you just say something and it types for you, right? Or TV or Alexa remote, right? Speech recognition is transcription, right? So speech recognition, also known as ASR. ASR is what? Automatic speech recognition. That's why I'm totally against the idea of jumping to build something without knowing the foundation. So guys, what it does, speech recognition, it is a technology, right? Converts spoken language into written text. That's it, nothing else. I don't know how many of you guys have done this. So when I have to do something, I have to write a lot of content, right? I don't type. So those who are having a Microsoft PowerPoint, so in consulting, we have to make a lot of slides. So we think a lot. So whatever we think, we talk. So what we do, either we use PowerPoint to capture it. PowerPoint has a dictation, you know that? So I've used this service a lot. I'm a big fan of it. It does a good job, by the way. So if you want to increase your productivity, you have to go to the PowerPoint, just take a text box and do it. I'll make it a little more bigger. Can you see a mic button there? Dictate, it says, come on. So this dictate thing is it will dictate. So you have to just talk through any of your mics. And trust me, it's really good. I have tried it and tested it for a few years. Whenever I think it got launched, I forgot. But yeah, you can also use it. Now there are a lot of apps which can capture, you can use your phone. Okay, so that was one of the key areas. I think language modeling, right? Within that, I took an example of speech recognition. Moving on. Okay, number 2 is your text generation. Now, text generation is, what is text generation? Another big area. Text generation and machine translation. Two things. I think ChatGPT, right, which is coming, right? It involves creating, right, new coherent, means fluid, with fluency, and contextually relevant text, not some random text. If you're able to, or you're doing these kind of things based on a given prompt, that's where I think NLP has branched out from here and gotten deeper and deeper, right? So a lot of architectures are being used here. So for example, common architectures include, always remember guys, the starting point was NLP. Remember that, don't forget it. So common architectures include RNN models. We have studied recurrent neural network. This was the baby stuff, but at that time it was a big thing. Obviously, LSTM and transformers, long, short-term memory, which is LSTM, and transformers like GPT. Now, another big area is what? Machine translation. Machine translation. Okay, what do you mean by machine translation? Answering your queries on the chatbots, text generation. So this is like a world in itself. So this thing, so obviously it's a world in itself, but that doesn't mean that you will be just using it. I'm also talking about what we should do. That's my job here. Okay, how many of you guys remember more than 10 mobile numbers? You know, my aunt, she is like 75, right? 70 or 75. At least she knows numbers of 50 plus people. She has this Nokia button phone, right? She just dial from her memory. So what I'm trying to say, we should not be in a situation where we have to search our own names in Google, or you have to ask, okay, tell me my dad number, Siri, or call Siri. So what I'm trying to say that human has to understand, if everybody machine will do, our ability to perform or compete with them will also degrade. So that's why don't ever write mails using that device, the ChatGPT, whatever you have, or Copilot. Always reply your own mails, right? Machine translation. It is the process of, like Google translation, right? So it is the process of automatically text conversion or translating, of automatically translating text from one language to another language. Obviously, it's not that simple. It requires quite a few things, right? So it requires understanding the syntax. Now just imagine that if I'm saying something and generating that in Tamil right? I need to get the syntax right. I need to get the grammar right. I need to get the semantics right. And not only the source of both source and target language. Suppose I'm saying English and it has to be translated into Tamil. Earlier it used to take a lot of time, right? But now I can teach in Tamil, you know that? So those who are like native speaker of Tamil, right? Tamil Nadu, anybody who is living outside Tamil Nadu, but they only know Tamil, no other language, I can still teach them to deep learning. without knowing Tamil. That's the problem, that people don't learn a lot of languages. Accurate and fluent translation. Let ChatGPT talk to me in that language. Suppose I'll give a script. It involves creating new, coherent, contextually relevant text based on a given prompt, generate Tamil text for it, and also the pronunciation, right? And I have to practice and then I have to speak. I have to still dub it, right? It cannot directly get converted into Tamil. I need to check. Maybe some paid models can do it. I have seen. Guys, let's talk about a little bit. It's all mathematics. I don't know. So those who have done signal processing, they know. Suppose I say, so whenever I join this class, right, I say hello guys. So I do say hello guys. And I ask this question, how are you, right? Isn't it? So when the moment you say the word hello, right, every letter has its own way of sounding, right? Hello, right? Hello. It's a speech. But if you try to show this, right? So when I say hello, it's an analog signal. It's a continuous signal in time. So this is my, let's hypothetically, I'm saying, I'm not teaching you like signal system and signal processing here. So let's say this is your hello, and this is your analog signal, XT. Analog is like your, remember that analog, digital, they were used to like, different types of devices, analog transmission, digital transmission. So it's an analog signal. When I say hello, obviously hello is like a speech, human speech, right? It's my voice. Hello is my voice, right? Machine cannot understand voice. That's why it has to get converted into a audio signal. So what you're seeing here, you guys, is your audio signal is an analog signal. And to convert this into speech to audio, there's a device called transducer. Those who have done engineering, they might have heard about it. Trust me, this is exactly even machine is doing today. Transducer, it converts one signal to the other form, right? So speech is my speech. It comes from my throat, right? That's why those are speaking different language. There were different ways of moving the tongue around their mouth, within their mouth, right? It touched the upper side, so depends on the word and the pronunciation, right? So God has created that. So we have this gland, pharynx, I remember. Then we have this throat, vocal cord, tongue, teeth. Everybody has a role to play when you speak. Trust me on that. Yeah, larynx. Transducer, in simple, audio signal is like electrical signal. So guys, what I'm saying here is that, have you seen a loudspeaker? Like I know a lot of people have seen a PA system. What is PA system? Everybody has seen in the college. So I would like a moment to explain this whole thing. So PA system is something you have seen it. You go to a party or DJ or whatever, right? You must have seen a PA system. Trust me on that. Not obviously like a big PA system or DJ system, but at least everybody has this. So if you see here, there is a microphone, right? So let's say I am trying to talk to you guys. Obviously, I can't sing. I'm a terrible singer. I'm a terrible comedian. It's my lame joke. Nobody. But let's say, at least I could give some gyan, right? That's my forte. That's my skill. So suppose, there is a mic and this guy is trying to do something, right? The moment we say something, let's say here I said here, hello. I just say hello very quietly, not loud, not shouting. Hello. This hello goes where? This hello goes into this microphone first. Microphone, it's a short for microphone. Microphone is a transducer. Let's talk a little bit of engineering here, and you will love. So guys, I've done electronics, right? You remember this? So when I teach communication system, right? I mean, I used to like, trust me, I used to like control the whole class. communication system, and I used to teach, like, it's still a hit. So hello, microphone transducer, what it does, microphone is a transducer, guys, listen to me. So where is the microphone? Let me highlight, this is the microphone. So microphone is a transducer. So what it will do, guys? It will convert, this microphone will convert speech into electrical signal. So you can say that speech or voice to audio, which is your electrical signal. So let's call this audio. Audio is your electrical signal, Shania, not the other way around. Audio and electrical is same, right? Now, once you're done, then you have seen it, right? This microphone will be connecting to either wirelessly or whatever, but will be connecting to this part. What is this box? This is a very famous box, amplifier, right? And then you see this is your loudspeaker. Guys, loudspeaker is also a transducer. This is also a transducer. So now what machine does now, and you will love it. So what it does, if I say a hello, let's say this is the voice for hello. This is the waveform it has created for hello. But when I say hello to a room full of 400 people, I say hello, but you will hear or you will listen hello, right? You understand the difference? I say hello and you hear like hello. So, you know, this power has come to my voice because of the amplifier. See, so it becomes bigger and waveform is same. So when it goes to the mic, who is making this magic happening here, guys? So this hello becomes in waveform, you will see a big hello is coming to you. But who is making this happen, my dear? Amplifier, AX. So it is called transmitter, receiver. Now, when I say hello, then loudspeaker, you think loudspeaker is doing this. No, loudspeaker is doing nothing. Loudspeaker is not making this hello bigger, right? Amplifier is doing it. What loudspeaker is doing it, loudspeaker is being connected to these two guys, it just transmits, but again convert back into your voice. That's the power it has. So guys, you cannot understand electrical signal. If I say hello and then it gets converted into electrical signal, which is this, you will say zzz, some electrical vibration will be there, but it has to get converted back to hello, but amplified hello. So this is another transducer, my dear. It converts the amplified audio signal into, again, come on, into speech signal, which is another amplified. Moving it hello, and you understand that hello is going to come out of the loudspeaker. Now understand, obviously machine is taking care of this part, but what I was trying to make a point here is that you should understand the science behind it. So when you're writing something or talking to Alexa, Alexa is doing all those things, my dear, on top of machine learning. So that's what I'm saying now. So it is combining what? It is combining linguistic, computer science, but generally people say computer science is everything, but nobody. Electrical and electronics engineering is also happening. So those who are electrical and electronics engineer in this session, they should be proud about it that computer science is nothing without us. You guys agree? As a matter of fact, when you go to MIT, there's no such different departments. In MIT, they call it computer and electrical science engineering. You know that? In India, it has different streams, right? But MIT, if you see, right, MIT says electrical and computer. So computer came later. It's electrical and computer science engineering. I don't know how many of you guys are aware of it, but there used to be like this. So MIT is all about this. Let me show you this so that you don't take me for lightly. So this is and those who want to study, obviously you will have kids, I'll have kids whenever God knows, but, right. So down the line, you should know that all these things are related. Guys, can you see this? So this is like some awareness. I'm electrical engineering, computer science, AI, decision making, all three they have combined into one department. Obviously, it's one of the top-notch colleges across the globe. So yes. So I told you NLP, NLG all are related. So NLP has this big segment, which is your natural language processing. And this has two branches to it. So one is there's no video, so we're not worried about it. So already I introduced this, but now I'm going to build on top of it. So I'll say one is your natural language understanding, NLU, natural language understanding. Which is NLU. So NLU is not something which you don't know. I just explained that, just jotting down quickly so that you are not clueless. So NLU is the process. It's not in the scope altogether. So it is the process of which you have already seen, right? Me doing analyzing and understanding. I'll just keep it short. The meaning and intent behind human language. Intent is more like your context. It focuses on comprehension, interpretation, and extracting meaning from the text or speech. So when I say speech, means you can also analyze your audio now, right? But our course is more on the text. So I'll be sharing the US sentiment, US airline data to work on it. That's what we are going to do the more like the hands-on guys. I'll just highlight here. But as a matter of fact, you can also do speech analysis. There are a few techniques which I think generally people want to get into it. So I think, so one is sentiment analysis. I think now this has become one of the biggest area within this field. Trust me, sentiment is everything, right? So if you're able to crawl data from web and read sentiments of your consumer, that can be like amazing tool in sales and marketing. Agree? I'm not able to write techniques. Even you generate feedback for me, isn't it, guys? You give me feedbacks, right? So feedbacks are so important. Feedbacks are so important that if taken in a constructive manner and given in a constructive manner and taken seriously, it can definitely change the way we work. So anything which we are generating sentiment about it. For example, movies get released, right? Isn't it people are writing about it here, there, everywhere, right? I've worked for a lot of the top retailers in the world, right? Consumers, grasping consumer sentiment is like everything. And I'm not exaggerating with my voice modulation. It's every damn thing. You can get a product fully wrong if you're not able to read your consumer mind. How will you read our consumer mind? There's nothing like you're connecting a SIM or Neuralink chip to everybody, right? So how can you do it? You have to grasp, you have to capture their sentiments across the social media platforms. As a matter of fact, now comment, feedbacks, share your thoughts is like a common feature in all the websites in the world. Trust me. So if you're able to do some real nice work on that, and that's where your data is so important, right? one way is to capture the sentiment if they are sharing, right? But before that, people used to capture the consumer behavior by looking at their buying pattern. So you remember, Srini, when I was teaching the clustering, right? I don't know, did I teach you clustering or not? Whether I came somewhere in the middle. So market basket segmentation, or finding the customer behavior, looking at the demographic data, what they are buying. There, I also talked about the Walmart beer use case, right? So the segmentation, basketing or grouping the customers on their interest, buying pattern, what they're doing within your store tells more than you know. It's just that you need a real guy who can analyze the data and make some real insights, take some real insights from there. Now there are two things. One is that buying pattern is historical, sentiment is in real time, right? And looking at the way consumer behaves today, trust me, and I'm also a consumer, I'm also a customer. I'm planning to go to Kurg and suddenly I'll go to Munnar. Who can predict this? You understand what I'm saying? It's impossible, right? So it depends on 10 different things, and it's not all everything can be programmed and put into a model. So that's why someone will do in real time, and cookies is more to blame for, right? So these guys who are running this company like MakeMyTrip, Go Ibibo, ClearTrip, and likes of those, right? They so much play with your money with respect to your flight pricing, trust me. But if you're not careful, right, you will always end up paying more. Trust me on that. You have seen that, guys, suddenly your flight price increases and you are like, what? By 800 rupees, by 1000 rupees per passenger. And you're like, what? Because they are tapping you. They know that you are looking for a flight. They also know that, right, you really need a flight. Okay. So I don't know, means tech has come so far. If I don't complete a process on one app, they will start messaging me on WhatsApp. Oh, you have left your flight, complete it. Please come complete it, right? They will even call you. So the new companies will call you and say, Akash, I think you left in the middle. I said, yes, you're charging me more, right? So the point is that now customers also know I think forget about these things. Let's talk about Rapido, Uber, Ola, right? Come on, guys. Everybody using cab. Let's not take some hi-fi example. So every day we do this where we are getting a cheaper cab. Hello, yes or no? You also book 3, they also accept 3, and then they will decide where to go, right? This is how it's working. At least in Bangalore, this is how it's working. So Rapido is like a betting system, right? So you have to bidding system, sorry, wrong word, bidding system. So if you are bidding more, they'll give you, you will get a car faster than anybody else. So suppose a normal route cost you from origin to destination 400 rupees, and you say, I'll give 500. Dude, come please sit. So if you're busy, you don't care for 100 extra bucks, you're not worried about it, pay and go. I've done it multiple times. What to do, right? Obviously, not something I would like to do, but what to do. So guys, just understand that how they're tapping the customer sentiment. So those who want to make a career in this field, they can study sales and marketing. And there's a very nice book on the marketing research, right? I'm forgetting the author's name, but in case you need to know and you're interested in that, please, this is like a very fulfilling career. But join a very good company, because sales and marketing can be very toxic job to be in. Trust me on that. Especially the sales, not the marketing. Marketing is like, okay, you can do any ad, you can do anything, but targets and all you have to meet, so it's very tricky, competitive. Okay. But by that, everything is competitive in this world. So that is something and watch out for you. And there you can use a lot of, so Salesforce is one of the biggest tool in this world, right? So I feel, if you're aware or not, Salesforce is one of the biggest platform for this. And I feel that this is the way you can learn these techniques. So coming back to our topic of interest, which is your sentiment analysis. I'll talk about in this detail what is sentiment analysis, but I given one liner for it. So you go to a movie, you watch a movie, and you share your sentiment on Book My Show or IMDb, right? So generally you write some review and then you give a rating, right? Out of 5, out of 10. So basically, this analysis, this technique is all about determining the sentiment. Now, sentiment can be positive. Positive also has a lot of levels, negative and neutral. So some of the guys in my class, learners, they'll say Akash is okay, and that's neutral. Akash is good, really good, excellent, positive. I don't think he's good, right? He's a bad trainer, negative. I'm just taking, on me. So same class, same set of learners, they will have different sentiment about a one person. Similarly for a movie, similarly for a product. Like a lot of people will be iPhone lovers, right? A lot of people will be like Samsung lovers. And that's why there is a page on Instagram where Samsung guys keep trolling iPhone guys. And trust me, even my workplace people are sharing me the links of the Instagram because I use iPhone. and they keep sharing that, see this, right? Means it's okay. But you understand, it's like a war out there. So India lost a match against New Zealand. Sentiments are pouring from all the places. Now, even government, like the political parties are using data like anything. You know that, right? I don't get political here, but I'm saying that they're also using AI. They're also understanding the people's sentiment. They are doing survey, and that's how they get the exit poll right most of the time, right? If they're not, rigging it. Good. So that's how it is. That is your sentiment analysis. Then one is like named entity recognition or entity recognition. So this came up pretty late, but this has come and revolutionized the way we look at NLP. So this is like I was talking about the other day, identifying entities like names, location, date in a sentence. So now with this, models are there which help you to understand, because if you understand that this is a name, this is the location, you can have a better contextual understanding of the sentence. Agree? And I will not deep dive on this because I had already shown you this in here. I don't know if you guys remember or not, but I'll show you that I was taking this example, Steve Jobs example, right? Did I take that Steve Jobs example? I think I did it. I did it, right, guys? I'm not able to find, but I did take the Steve Jobs example. I think I did here. See, Apple is looking at, right? So go through that. That's the same thing. Let's quickly talk about natural language generation, guys. NLG. What if you want to pursue your career in this field? But without knowing NLP, NLU, so you need to know NLU, then only can be better NLG, right? So there's no shortcut. But right, it is the process of generating, let me write quickly. Human-like text. Now, though, we are also generating speech. So I'll write it from structured data. It focuses on producing understandable and coherent text that communicates the desired information. So there's a very good company called Automated Insights. I don't know how many of you are aware. So I applied this plugin in Tableau in one of the projects. So what it does, guys, it reads the data behind the chart and give you summary. So generally we look at the chart, take a screenshot and write the summary, isn't it, guys? Come on. Right? What it does, right, it will give you a summary of the same chart for different department heads. So if there is a sales representative, it will generate chat like a summary or generate text, right? More for this guy who is viewing this chart, right? So in Tableau, you can have the role-based access, even in Power BI. So for Mr. Mitchell, Donald Mitchell, right? Donald Mitchell, you can clearly see that he's getting 61%, right? Missing on target, whatever. So it will give you the full summary of what you're doing, right? Then head of sales will see more like a summary across the different sales representative, and sales manager will be like having a different view to it. So this is interesting, guys. Do you like it? I don't know. You are also going to be taught Power BI, or you must have been taught Power BI, but I don't know if your trainer did touch upon this topic that even Power BI can do things. It can find some good, nice summary of the charts like this. So there is something called Serve Insights, right? Insight service. So generate insights for the chart. Can you see I have put a red box here? Get insight. So it says that there's a correlation between vendor and total defect reports for this category, right? So you have a filter there. So you put a filter for the category. So it's saying there's a strong correlation. I would rather say it's not that smart than this, but just just keep an eye on these things. A lot of things will come in some time. Okay. You agree with me? There are a lot of things coming down the line. So SEO is like, search engine optimization. So NLP plays a big role, a crucial role for that thing. So, you put hashtags, right? Your page has to rank to show on the top, isn't it? That's the whole point of doing SEO. Suppose I want to search data science or deep learning program. Intellipaat name has to come on the one of the top 5, right? Then only you know that Intellipaat exists, and that's business. Means if I don't come on top by hook or crook, I'll not able to sell anything. Agree or not? So be it any company, let's take Accenture. If someone is searching about something in supply chain, Accenture doesn't come, then I think they'll not know who is Accenture. So marketing is all about bringing your page, whatever I do, on the top of the things, and that's where the content writers, content influencers and all, they are doing a lot of these things. So NLP helps the search engine. So like Google, take example, Google is the giant. So Google understand the queries, right? And then it matches with the hashtag and what you have written in your blog or in your video hashtag or description of the video, right? And it tries to, see that what is the overlap. So suppose I say best smartphones for photography. There are a lot of phones coming only for photography. So NLP helps the search engine understand that user is interested in phone, right? With excellent camera, not just any smartphone. Agree or not? Come on. So if I write best smartphones for photography, so Google is going to do the intent of the search. That's number one. Number two is that that's where the semantic search, the contextual thing comes into the picture, right? So search engine use NLP to connect relative topics, right? So in this case, it will be like wide angle camera, some hashtag will be there, right? Or what kind of photo you want to do, like wildlife photography or like a movie photography or cinematic photography, right? Or video making. So those keywords which you put in the hashtag, right, when you're promoting your product, Google will understand, right? And they will rank you. Now that ranking logic is very tricky. Even I think Google only knows. We can't know that. But obviously they know that these are the levers for you to get ranked. And that's why I think Sandeep has written. So Google has to rank, but before Google can rank, Google has to understand the search intent, what is the reason behind that search, and then it does the semantic search, which is your contextual understanding. Like I want to buy a phone for photography, not any phone, then Google has to also find which pages are offering that kind of phone, isn't it, Priyank? So like let's say a company like Sony, let's say a company like, sorry, why I'm saying Sony, Samsung, Apple, take it, MI, XYZ, right? So which phones are going to be like the best one for this guy who is searching on my web, right? Google.com. So obviously they will be having some articles written, some hashtag, right? So they know that, okay, because these guys also publish a lot of, blogs, they do a lot of, paid reviews for their product. All these guys who are doing reviews every month, every week, they'll come with 10 different phones. What do you think? Right? It's not all they do genuine things. Obviously, it's a business, right? They have to give some preference, but they will also protect their credibility. They can't say that lava is the best pen in the world, right? Means nobody will, they'll stop watching those kind of, channels. If I say lava is the best phone in the world, you will say, go to hell. Who is this channel? Right? I'll block it, unsubscribe. You know what I mean? So yeah, it's a collaborative approach. And I was looking on a laptop, Asus ZenBook laptop, right? ZenBook laptop. So on their page, they have already linked a lot of bloggers, tech bloggers, reviewing their product. So I like that. They are very honest. That, okay, guys, he are our guys, they are our guys, he is our guy. Go and watch what he is talking about my laptop. Okay, so moving on. So now, guys, I'll talk about NLP pipeline, which is going to be our steps in the hands-on. This is going to be the critical steps in doing an NLP task. Okay. So maybe I'll add a page and make a sub page, right? That would be smart. So anything when you're doing with respect to NLP, you have to build a pipeline. It's very important. Guys, disclaimer, focus on the steps, not on the sequence. It's not the hard and fast, excuse me, that you have to follow exactly this. But steps are important. So credit goes to Turing website. You see a nice diagram, guys, natural language processing pipeline. We are going to talk about this. So let's take the very first step. Sentence segmentation. What do you think? What is it? Okay, so it is the very first step. Sometimes it's implicit. You don't even acknowledge that you have done it, but it is being done. It is the very first step in the NLP pipeline. So what we do here, it divides the entire paragraph into different sentences for better understanding. More like pressing enter, enter, enter. Okay, in your head, think like that. Not wording. Word we have not reached. So first you will separate the sentence. So generally we put the enter after the full stop, isn't it? So let me show you this nice example. Suppose this is a sentence for me. Come on. I'll take a screenshot. Yeah. Can you see this guy? So I have a sentence which says, so source is Wikipedia. It says London is the capital and most populous city of England and the United Kingdom, standing on the river Thames in the southeast, blah, blah, blah. But if you observe, by every full stop in the below, we have segmented it, right? So after this, then I think after this, right? See? And that's how it's done. Clear? Very easy step. And move on to the next step. We will do that when we'll build it. No, we'll do it. Okay. All these steps are not exhaustive. Means sometimes people don't do it. So don't think if I'm not doing it, we are missing a step. Again, I'm telling you. So understand the concept of each step. Word tokenization. You know this? Must have heard now. Word tokenization. Tokenization is a very famous keyword in NLP. Generally, interviewers ask, what is it? Breaking sentence in the words in the token. So it is a very crucial step. So let me write. You're right. I think people have got some idea here. So my dear, it is the process of splitting a text into individual words or token. And this token can be anything, group of character, group of words, it can be anything, by the way. So for example, if I say, I love NLP. Simple one sentence. So word tokens can be coming from this sentence is what? You know which are the words here? It will be I love, and I think acronym we will take it as a one word. Makes sense? Clear? So guys, note it. It is a crucial step. And this is just one way of showing the code tokens. It can be subword tokens. I'll come there. But it is a crucial step as it transforms text data, raw text data into a format team will let you know. Don't worry about now. That can be processed by ML algorithms. And you can also write AI. Sometimes people get, oh, AI, you are not writing. AI is like implicit. So it's very important that we are converting a raw text data into a format that machine learning or AI models can understand, right? There's a concept of subword tokens as well. Subword tokens. There are a lot of techniques in this, huh? Let me write a technique. But you're right, subword is like taking a word out of the word only. A technique to handle out of vocabulary words. By breaking them into smaller but meaningful units. Now you have to understand, when we were doing machine learning, right? Sorry, when we're doing sentiment analysis, right? For sentiment analysis, no. And I remember, when I did the first time sentiment analysis, it was year 2015. Can you believe it? 9 years before. So 2015, I did sentiment analysis. My first, you can say my first, and I still consider as like my first baby project. And it was appreciated by, a lot of people in HP. I think it was 2017, my bad. Because I was in HP in 2017 time. Okay. So the problem came, right? Someone is right. I'm not right. I'm unhappy with you. Now the problem is that if you take happy as a parameter, it shows that it's a positive sentiment, right? Because model is only pinpointing this part. Hello? Guys, understand what I'm saying? Because, I'm unhappy with you, right? So model would think happy is there means he's positively or he's happy. It's a happy sentiment, right? But is it the reality if you understand the English? Is it a happy sentiment, guys? No. So the problem was that in English, if you write un, it's like undo happy. Okay. So then the subword techniques, the subword tokens help you. What it does, it takes the words such as unhappiness, right? Unwell, and then so different versions of it. So what it does, let's focus on unhappiness. It takes and divide and break into two tokens. Very good. So I think someone also mentioned that they're taking a subword token means what? It would be, are you feeling, guys? That this is un and happiness, right? But it doesn't mean that you will divide from anywhere. So unhappiness, right? Unhappiness, it will not do this. So the models are trained to do this on their own. Make sense, guys? Come on. So this is called subword tokens. There can be also character tokens. Now this is like getting too much detail. It's like you might be needing going to the lowest level of the detail. So in some cases, tokenization is done at the characters level. Where each token is a single character. See? Very good, Sandeep. So where each token is a single character. So for example, I take a word cat. Now, if I had to ask you, what is the character token here, guys? C-A-T. Now, Gen Zs, right, the millennials and Gen Zs, right, they have a very unique way of communicating, trust me, on social media. So in Bangalore, I don't know if Francis is there or not. So in Bangalore, there's a place called Koramangala, right? Koramangala or Koramangala. So I have been visiting that place for almost a decade now, but recently I got to know the millennials and the today's generation, they call Kora. So there's a way they call this place. It's very different. So right. So Kora is the famous word for Kormangla on social media, right? Means Kormangla they'll not even know. So similarly, you might be seeing on a lot of Instagram or Facebook posts, people have written something like this. I'll show you. I don't know how many of you guys seen this TLDR. So even on LinkedIn, people write it. Do you know why do we write it? Have you seen this TLDR? To let you know directly. No, it's not to let you know directly. It's a slang. Too long, did not read. Okay. So basically, so let's talk about it. It's one of the famous thing in SEO. Too long, did not read. So some people they write a lot. So it's a shorthand way of, it's a shorthand. I'll write about it. Guys, trust me, I got to know a couple of years back only. So don't think you're missing something big in this world. So when I saw it for the first time, I Googled it. I have this, I have this habit of keep learning about new things. So I'll quickly search. So, you can look up or you can search in Google by just tapping on that word. It's a shorthand used in internet, used on the internet. To summarize long content, articles, etc., into a brief, digestible form. You will not believe, I think, I feel few years back, there was a company came and so the founder is like a Bihari. So he did found the company called InShots. I think I'm damn sure I have this app on my phone. Most of the news I get to know from that app only. InShots, you know that? So tell me, na, in short, we keep telling, na, in short. Arre chodo, in short batao. So TLDR is a way, so they will write a big article first and then they will give you a TLDR, right? So to give you a quick overview for the people, for the folks who are like busy, who don't have a lot of time or patience to go through the entire content. You understand what I'm saying? So now if NLP does not understand that TLDR is written and then the article starts, it will miss that it is already summarized, Model needs to learn, right? The TLDR after something coming, TLDR is like already compressed, summarized. So you have to tell the model, dude, this is TLDR content. Right? I think stemming, no? Yeah. Step 3, stemming. Okay. So guys, everybody knows stemming, right? Have you done stemming on a plant? Or have you seen somebody doing stemming on a plant? So to grow a plant from a plant, people do grafting and create so they take a base of a plant and they create a root from the stem, right? And then they get a new plant and that's how the plants are multiplied, correct? So that's called stemming. This is the word, source of the word, stemming. So first, obviously, you need the stem to do it, right? In NLP, if I tell you a few words, so I'm a consultant, right? So everything, if I say, consultant, consulting, consultation, you know what I mean? Consultative, At least these are the words I know from my English. But if you think something I've written wrong, right? Do you agree that all these words have a base called consultant, right? So the base word or the root word is what? Consult. So in stemming also, we say, right, find the root. So as the name suggests, stemming is a text normalization technique to reduce the words to their respective, to their base or root form. Known as stem. See? And trust me, stemming has a lot of applications, right? So next in the pipeline is, I think, lemmatization, right? Yeah, step number 4. Lemmatization. It's a very important segment. Interviewers ask connection, connecting, connected, right? All finally lands to what? The root or the base form is connect, isn't it? I think, right? Lemmatization, what is it? So I think words context such as where it appears in a sentence or within a larger document. Okay. Grow, growing, growth, grown, growth, growing, grown. Ultimately, it lands to. Okay. What is lemmatization? These are verbs form, right? But I mean to write beyond this. But okay. So what is lemmatization, guys? It is a set of. It is a text normalization technique that reduces words to their base or dictionary form, right? That reduces to that's why it's very close, they're related, base or not root, dictionary form. And to be honest, I am generally confused with these two guys, but I'll try to clarify for you. It is known as lemma, not llama, okay, lemma. Now, stemming can be cutting at a place. So suppose she saw, right, I just decided to cut after T. So I got consult, 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 right? Connection I did connect, connect, connect. Growth I did growth, grow, growing. So if I just cut here, I get grow, right? But where you find similarity, it's more like pattern finding. How is it different from stemming? So I'll write, it is unlike stemming, and I'll clarify also, unlike stemming, which often uses heuristic rules. So heuristic is like rules, right? To cut off affixes, while lemmatization involves a more sophisticated process of deriving the base form of word based on its meaning and context. Now, guys, I'll show you one example, right? So obviously what you have done is also right, but stemming and lemmatization can be tricky. Can you see this? So obviously I've taken this from a source, credit goes to the guys, but can you see, you might decide later that I want to just, cut it like stemming is like cutting, right? So you might want to decide that I'll cut it just after N. So the moment you say I'll cut after N, right, isn't it? It will give you Chang, after G. You understand? So that's a valid stemming, also technically right, but obviously meaning wise, it is nothing, right? So what to hell, let me use my agree, guys, come on. But lemmatization, if you see, which I have written on the other side, so I need to be very careful, or as a group we need to be very careful. Stemming like cutting, so that's why I focus on this part. So when you're cutting something, you can cut, But here intentionally, obviously nobody will cut like this, but it's more like cutting it. So whenever you are doing this, you have to ensure that it is following that equal length character wise. Okay. I'll give you an example, right? If you take run or someone ran, what is the base form for ran? It's run, right? What is the base form for wrote? It's write. So now we will try to cut it, right? So if someone wrote, written, writing, you know what I mean? Write up is a different thing, but you will try to cut, you can only cut WR, right? Because that's the only thing you see common. That's called stemming. But if you are bringing everything to write, this is called lemmatization. Agree? So that's the difference. Now you'll never forget this. Now look at this example, guys. This is also nice. What about this? If someone gives a number or spelling like worse, now if you take a word worse like this and you want to do stemming, you will write what? WOR, because let's say you are just selecting or cutting 3 characters, right? Okay. So you can do that. Technically it is right, but conceptually it doesn't make sense for you, right? But if you want to do lemmatization, worse becomes bad. See? Good, better becomes good, not like better become bet, right? So if you see here, ideally, I would rather put a, star and saying that if only we follow the contextual approach. If you don't do it, you just do it blindly, then you might get something else. Make sense? Clear, guys? So it's very important to say you can get to the base root form using this, but ideally, which is the preference? Lemmatization gets preferred, is the right approach because it gives you the room of error. Clear, guys? That's correct. Best also becomes good in lemmatization. That's right. Exactly, Saurabh. That's my point. You got it. Now the question comes that then why the hell I need to do stemming, right? So well, in that case, I'll write the question. Let me have Swalin and then talk. Well, in case it seems that stemming, right? That's the question and the response. The response is very simple, and that is speed and simplicity. It's not that simple, so I'll try to justify what I've written. Speed and simplicity. So what I mean by that, stemming algorithms are generally simpler and faster than lemmatization algorithms. And it's obvious, no? It's a rule-based cutting. So if you don't have a lot of computational power, you might end up doing stemming. So stemming can be less resource intensive, making it suitable for large scale application. That's where its value add is. Now you do a proper stemming, then you can still go to the root form. Hello, yes or no? But yeah, this is a little tricky than easy. So you have to do a little processing of the text. Okay. And there can be a question that where to use what, right? So let me talk about it. So it's more like a choice. So I would say choice between stemming and lemmatization. So let's talk about one problem area, classification problem. Yeah, versus lemmatization, right? So classification problems, if you talk about it. So in general, you take any classification problem, stemming is often used in classification problem. I'll explain why. So I'm giving an example as per the best practices, which can help to reduce dimensionality of text data by grouping different forms of a word together. Now, suppose in a big article, you're using different forms of the same word by doing stemming, right? You find the common word consult in all 4 or 5 words across the whole data. You are just grouping all these guys, which might have come multiple times into one group, which is consult, right? So are you not reducing, you're not grouping and consolidating your data in clusters, small groups? Exactly, right? So what they're saying that it is as good as saying that treating related words as the same feature. So you will be able to reduce dimensions, right? There's no point for having a dimension for consulting, consultation, consultant, right? Whatever, consulting, right? So 4, 5 features you would have, you could reduce it to only one. This is a good area. I know you are looking for some example. We'll come to that. It's not that straightforward, Mr. That's why I'm not giving or able to give here. But this is more like a FYI information for you that classification problem, it's a good choice. I'm not saying that. Experts are telling that. Which one is a good choice? This guy, STEM. So you might be wondering where I use lemmatization. So it is for text generation problem. Now, text generation is something more dependent on contextual thing, isn't it, guys? Come on. Rather than doing a similarity grouping. So you cannot like do stemming and take some, almost similar kind of problem here, right? Oh, these are all similar words, I'll group it. No, you need to understand each and every word so that you can generate text, which is a response, and you have to be very careful. So what I'm saying here, in general, lemmatization is typically preferred in text generation task as preserves the meaningful base form of the words. And this is very important to understand, that it preserves meaningful base form of the words. So you can't just replace it with some, segments. So what basically it says that it maintains the meaning and context of words, which eventually leads to more coherent and accurate generated text. Now, this is a good thing. Suppose when I used to teach this, let's say 3 years back, to make you guys feel this impact, it was a very abstract thing for me. It was very difficult as a trainer. Now, since everybody is using GPT, now you are asking something as a response from GPT. If it is not coherent and grammatically correct and making some sense for you, in response to your question, are you going to trust that tool? That's why I'm saying it's so important for text generation problems that we use lemmatization, not stemming, right? Because if stemming goes wrong, it will not be able to understand that word, and then it will not be able to give you the better response. Agree or not? Suppose by mistake you did a wrong stemming. It will suffer miserably in training of the model, right? Which means, guys, suppose you did a 3-character stemming, 2 words have some meaning, but the other 2 words did not have any meaning. So the model will say what's happening here, right? Because it is not able to understand. So it happens, right? You're in a meeting, sitting, discussing with your project client, offshore client, or onshore client, and then suddenly you don't understand something that person said because the network was not good, or you could not understand the English he spoke. Like he might have brought in a really difficult word to understand, right? Or you could not understand the word or set of words that guy told you or just mentioned because of the accent or any issue as such. Isn't it you have to resort to say, can you please repeat? I missed it, right? Or I could not grasp what you said, right? So it's the same thing. You know what I mean? Because the context is lost for a minute or so, then you have to repeat. That's how text generation outputs are now getting better because now model training is done solid. So But if you're asking something tricky from ChatGPT, you realize that, oh, it is still dumb, right? It keeps telling you the same. So for, I think last year when I was trying to do it, when I say last year, I think almost a year happened, right? After ChatGPT has come. It's been a year now, ChatGPT 3 and all, right? So last year, when I used to ask something, right, it was making like baby mistakes. So I was doing some calculation and it was doing this 23 minus 5 that ChatGPT is writing, that kept writing 19, 19, 19. And I was like, please fix it, it's wrong. And so is wrong your next all 10 steps, right? So then I realized that, ChatGPT mathematically is still not there. But now I feel that they have done some good improvements, and there are some updates that in a year or so, it can also solve optimization problem, which is fully mathematical, right? Fully mathematical. It can run iterations on mathematics, so it's basically can write your own algorithms. So I think the world is going to be super interesting to see what is in that, right? What is top word in NLP? Anybody knows this? Give me an example. Stop words. And the right is in, of, etc. These are called stop words. So basically words that are commonly used in a language but are often deemed irrelevant for specific NLP tasks, right? Which are not very important. That's right. So examples in English language I can give you. That's our common language here. So it can be and, a, and, the, and, or, is, in, of, to, etc. All the pronouns. So yes, continuing on this, I'm writing. The list is big. You don't need to remember this because model has already those things. So what is the primary goal of removing stop words? Is to focus on more meaningful words that carry substantial information for text analysis, such as sentiment analysis or topic modeling. By the way, right? Topic modeling is a big use case in industry, insurance industry, BFSI, banking, finance, service, insurance, right? Correct, no? So BFSI is where you have a lot of documents in place, so you'll be using it, my dear. I think financial services, right? This is a very big college, by the way. Financial services, no, I said no, financial services. So here, what are the points? What's the point? The point was that topic modeling is a big thing here. So what is topic modeling? So topic modeling is, guys, it is an NLP technique used to discover, I'll just give one liner, the underlying themes or topics within a collection of text documents. How many of you have taken a loan, mortgage loan, in India, outside India? Have you seen the pages they have? And the terms and the contracts, deeds, right? Those documents which they actually process for you as a mortgage for the loan, right? Banks. So I don't know if you have taken a home loan by now, you know it. That bank goes through a lot of documentation process. The moment you have a collection of text documents, topic modeling is your thing. Now, what do you mean by underlying themes or topics? Even media industry, they're using this a lot, right? Now, suppose I'm trying to put some detail on the website, you'll get a call from bank for their marketing they use, kind of loan requirement you might have. And this is very, this is very tricky. And you don't like at a lot of time. So you're gonna do this, that you might disconnect the call. Hey dude, I'm not looking for a loan, but how would they get to you that you need a loan? You understand what's my point here? NBFCs are not good for working as a work culture, also for taking something loan. But what happens now, not everybody is having a very good profile and not every bank will consider you. So you end up going to NBFCs right? They give you an easy loan service, but terms are very strict. Experience is not that great. Okay. And see, I'm not like some finance expert here, but I'm just telling from my experiences and others' experiences. Okay. But don't take me or take my words as like a Bible here. So Priyank, you can have a word and Srini can have a word together. Okay. I think he works, so he will be able to tell you more. Right. But Priyank, how is the work culture there? Is my understanding correct? Work culture is not that great. It's too much of, it's great. Okay. Okay. So maybe, see, I've never worked, so I don't know, but I think with my exposure and experience, right, I have felt banking and financial services. So BFSI is tricky. It's aggressive, but a lot of job opportunities are there for NLP guys. I'll just keep it to this. I'll stick to this point. See, work culture is a myth. Okay. If you are able to manage, it's good. Not, I think, can't say anything. I'll take an application to show you what we mean by topic modeling. Suppose, and you can also go to companies like Netflix, as a matter of fact. So it's not necessary that BFSI only doing topic modeling, but they are the major. See, wherever you have a lot of documents, you can do topic modeling. So content recommendation. Now this is out of the box kind of application, and it's not like something like a very common area to work in. It's a niche area, but this is something like a job. So those who are studying recommender system, right? So, content recommendation is a big thing. Okay. So it's more like, suggesting articles. And trust me, guys, in my all phones, laptops, right? Except this laptop, everything I browse in private mode, that not like I'm doing something shady. It's just that I hate it when I'm trying to browse something and the cookies. Mostly I use Mac, so I use Safari. They are more private, right? So I start getting irritated because the moment I suppose I'm trying to buy a pair of shoes, right? I'll start seeing shoes everywhere, which I don't want to see, right? On every page on Google Chrome, which I don't like. It's like it's like that. The shoe is like pursuing me that Akash, you have to buy me. There's nothing which can escape. Nobody can make you escape from here, which I feel not good. So suggesting articles or content based on the identified topics. Now, those who are, so how do you combine BFSI and this example? Have you seen a lot of products? They keep talking, keep doing ad. So ICICI Bank, I'll tell you, I'm their customers, I know. So ICICI Bank, there is a concept of OD against salary. Something they say. So I don't know how many of you guys are aware of these things, but I'm just taking an example. My bad. OD against salary. So those who are working, they might be interested in this, and that's how I got trapped. So it's not a service they give you, it's like a recommendation. And so let's say someone is searching OD, for example, anywhere in the world when I say India, and you will, so those who are working here, they will agree to me. It's a real use case example I'm taking. It's as real it can be, right? As real as it gets. So OD is overdraft, very good. So let's understand quickly what is overdraft. So overdraft is like a credit line to you, and you only get paid the moment you use that money. You have to pay interest only on the amount you're using. 100 rupees, 100 days, 100 rupees one day, doesn't matter. It's not like a loan. It's not like some EMI you have to give and pay back as soon as you can. If you don't pay, you will be keep getting charged as an interest. I never recommend anything such to any student here. Anybody who's in college or just started the job, this is for people like us who has a lot of expenses and less money, so you don't get trapped. Clear? This is the disclaimer. I'm not selling OD. Okay, I'm just explaining a use case. So I'll tell you my own experience, and when I look back, so I thought, okay, experience was not good. Why don't we use just that as a learning thing in my session? Okay, so that's what I'm doing exactly. So overdraft is like, it's like a credit line, right, for you. So it's like, suppose you get a 5 lakhs credit line, depends on a lot of factors, forget about it. So it is in your, it's like your money, but it's not your money. You know what I mean? It's not like credit card, because credit card has to be paid on the 40th days or 35th days, or they will charge you like, wow, like interest will be like 25%. So you can't afford, right? OD is like, interest will be like 11%, 12%, whatever, but it is manageable. That's why you don't get OD easily. So I was looking for an OD, just like money for the rainy time, right? Obviously, I'm not like some big shot, like a sheikh from Dubai. You know what I mean? So at times I might need some money. So rather than taking a loan or borrowing from somebody, I like to use the institution. So the moment I was searching for OD, you do a Google search and someone wrote that, sort of very good. I started getting incessant call from Bajaj Finance, right? I'm not, so again, this is like disclaimer that I'm not demeaning anybody here, so that IntelliPath doesn't get in trouble. And guys, be careful. Don't. That's why so disclaimer is that discussing these things for learning. Okay, good. This is very important. So Bajaj Finance started calling. So they are very good in their marketing. Their marketing team is good. You guys agree? So Bajaj Finance guys started calling me. Okay. So they do business on this. This is their business operating model. So guys, how many of you have experienced that? You're searching for overdraft, personal loan. Did you get any call? Suppose you're searching for loan, but Bajaj Finance guys reaches to you. They reach to you. Agree? Those are working. Those are your good civil score. Right? Mine is good. Okay. Don't ask me how much. Okay. Then obviously I had a ICICI Bank. So when I was searching for OD, I also saw there is a recommendation sponsored, you see, right? So one is recommendation, one is push. So if you know about that, so it's like SEO. So search engine optimization, obviously we'll search somewhere here and use the internet for it, and definitely we'll use cookies. Okay. So if you see SEO, right, SEO does a great job here, right? So I also got the call. Bajaj Finance always comes on the top. So came ICICI and some top banks, right? Now this content is being generated, right, on somebody's interest. It's not being generated in the real time. That's the AI will do. That's the future. So what I'm trying to say that this is for marketing, right? Suppose you search for something, you get recommendation like articles or content based on your inquiries. So you can say that it is search, but you know what? A lot of people are writing in real time, doing a topic modeling for the BFSI. Suppose I'm looking for a term insurance. So you will see that there is a blog which is being written in real time, right, with your requirements. It's like if you are writing somewhere, suppose you have written in Quora, you have written on Reddit, and there are companies, I don't have a real example, but I have a very nice and niche group where I discuss these things of, of ideas of the today's world or the tomorrow's world. What is being done, you know what? And these are being tested. Suppose you go and write something on Reddit. Reddit is an app where you can put a big detailed context, asking still more like reaching out to a community. They scrap those data, right? Web scraping, and see that if that's a common kind of query people are asking on these social media handles, be it Twitter, be it Reddit, be it Quora, right? Likes of those, and there are hundreds of them. What they do topic modeling to generate what? Articles and blog, which will be so convincing that you will think that dude, this is it. That's how I got tracked. It looks so real and so fit to your requirement because they're using your input to put a content around that requirement. It's like you want to be a data scientist. I only talk about data scientists, right? But I am from a finance guy, right? This is so lame. So that is one thing. Second thing, that why BFSI today? So remember I was telling you that if you only hinging on AI coding, right, or Python coding or Python or AI based coding or Java coding, your days are limited, So trust me, your days are limited. How many of you are coders here? Can you say hi? Or let's do a quick survey. How many of you are coders here? Literally, you are coding to make some bread and butter for your life. Just coding, nothing much, without putting a lot of brain. So you just do coding every day. You just do some code or code quality checking of the code, testing your code, creating applications. So you're coding. Building product is Raj also coding. Okay. Sales for developers. So you're coding. Okay. Architect is okay. I'm only asking who is coding to build product, to do anything like that. So if you are a technical architect, I think you're okay. You're not, you don't need to worry. So now you understand. So I'm a guy who adapts very fast. So why BFSI? BFSI has a lot of future. Trust me, a lot of future. And this is the first time plugging BFSI in NLP because I see a lot of promising career with AI because document is there, NLP is there. Those who like NLP after I complete, they can think about building a career on top of this, and domain is already there. So anybody who is from MBA, commerce, accounts, I think engineers are like omnipresent. You can think about getting into this. It's not a bad job. It's a very good job. Okay. My folks they work for Credit Suisse. They work for, Morgan Stanley, Barclays, a lot of banks. So if you can get this domain understanding and you like this field, that was the intention for bringing BFSI here suddenly. Okay, because supply chain I keep talking about. After supply chain, I feel BFSI is another top notch is pharma or life sciences or healthcare or Medicare. But in India, I think it's very limited. That's why I'm very choosy. In India, healthcare is not picking it up, but you can work for the global clients like like name it. So I think India will take another 30 years to be a great healthcare country, but healthcare here is not picking it up. But definitely, pharma is picking it up. So right, there's a difference between healthcare and pharma or life sciences. So those who are doing automation job now, and anybody who's just doing automation like RP and all, please start thinking about something alternative. Anybody who's just doing automation, like a VB automation or doing RPA, right? Please ensure that you start upskilling yourself in something totally out of the box, right? Or those who are doing those, anything which can be automated with AI very easily. So I'm also working on creating something that there is a very good page which keeps updating saying that which area, which sector, what kind of jobs you are going to lose because of this AI revolution. So I think that will give you a lot of insight and you'll be on the top of the thing. But what I'm trying to say, although we are teaching you AI only, so you guys don't need to worry. So those who are all present in my session, you are already learning something which people are going to use against you, right? So you don't need to worry, right? Yes. So I feel RP automation is something AI can do it automatically. It's like there will be a set of, so there will be like a more like an assistant, and you just tell it, make some workflows in that, and it will do it on its own. It's very highly easily going to be, scalable, and because now understand, and I had done this RPA training when I was in Genpact, my very first company. What I'm trying to say that RPA is what? You look at some boxes and, location in the document, right? Images, right, on the screen. Then you make a box there and saying that if you find this similar, right, you do some action on top of it, right? Agreed, correct now? So if you think OK is there, so you have to click OK, right? Now, you know what? I don't know. I want to show you a demo. So shall I do it? Can I take 5 minutes? Because I know almost we are done, but I'll just take 5 minutes. Are you guys ready for it? Can you see ChatGPT? So I'm using a paid version, my dear. Okay. So this is something I try to use it the most of the time. Can you see ChatGPT? Okay. See, I'm just sharing a screenshot. Where is that screenshot? So stopword analysis. Let's say step 5. Obviously, this is a handwriting. All right. Suppose I just copy paste it. Hey, come on. I paid for it, right? What's wrong? This is not done. Why the attachment is not coming? My paid account is gone or something? Seems so. Yeah. Anyways, can you interpret and give me more detailed info on this screenshot? Now just understand this. I understand. Sorry. So I have to select the right one, but just understand this. See the power it has brought in. Can you see? You understand what's happening, my dear? It is able to understand what I've written, which is not that bad. At least ChatGPT understands. You can't see, can't understand. So it understands my handwriting. It understands that it is a step 5, stopwatch analysis, right? And it gave me the detail, right? What other steps I can do in NLP? Let's see. The moment I say, obviously I'm paying for it, so it will be better than what you see in terms of output. Yeah, it is only available in paid version. So see, it's going in like, and now it will start blah, 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 blabbering. So what I'm trying to say, look at the world we are living in, my dear. You know what I mean? Now going further, there will be no need of trainers. It seems if the trainers are just doing coding and showing you coding, right? So that's how I keep, differentiating myself, saying that you have to be on top of the game, right? That's why I have to keep upskilling myself, that when I come and teach you the for loop, I am doing a better job than anybody who is a coder. And he might be a very good coder. He might be able to write all the efficient and production level coding, but with the real application, the industry exposure I have, I'll beat these guys, So now can you see when it can read handwriting like anything, then RP it can do. Yeah, I mean, you have to just tell it and train it. It will be just using its training to get trained, but I think the kind of training it has done and being done, don't think that the model we are using is not getting updated. So I'm paying it for it. So obviously I'm getting the latest model all the time, not the free versions, right? So they keep coming with new models. And I think my trained model on behind my ChatGPT is better than anybody else, because that is the latest one available to anybody in the world. So that's where I'm sure about a lot of things. But what I'm trying to make a point, domain is important. And that's where, I came up with this BFS, I think. So you got it why I'm talking about it now. Makes sense? So the world is going to be very crazy, right? In coming time. It's very crazy. Trust me, there was a time when I was writing an OCR using a Tesseract library in R. R is a programming language, and I was hardly getting a very good accuracy. And now when I look at my iPhone images, it reads my handwriting. These guys are reading my handwriting. So far, we have come in so less time. 2016, 17, I'm talking. And 8 years down the line, it is reading handwriting, that too written by a pen. Are you guys believing what's happening here? I don't know if you're able to fathom what I'm trying to raise as a point. It is moving super duper fast. Be careful with your career. Trust me, this is going incredible journey for AI, but it is going totally out of hands. I don't know, government might bring a lot of regulation, start banning these things, because I feel a lot of people will lose jobs, right? I'm not trying to create any frenzy here, any panic mode here, but I'm just trying to support you guys, saying that you have taken a big decision that you are trying to learn AI. This is the best time to be in the field, which is going to change everything. Okay, so be careful. And obviously, when you are talking to your juniors, siblings, right, younger brother, sister, pass on my message. Obviously, I am not like some big shot that if I go on a podcast and tell everybody will follow me, I'm nobody, right? Nobody knows me. Only you guys know that who am I. So please, whatever the mode is, but try to pass on to the next few guys so that they're aware of these things. It should not be like after 5 years they are waking up and saying, dude, I need to do something about my career. It will not work for them. Okay. Step number 6, dependency parsing. So you know what? Dependency parsing is very important for grammar. Okay. So let's talk about grammar a bit. I'm going to show you a nice diagram, guys, and you will see this. So if I say London is the capital, right? London is the capital and most populous city. Can you see? This is the sentence. Now, even you have done this in the grammar, right? In the grammar courses, that if you look at the sentence, you know that what is what. So you know that how quickly to understand the whole tree, that London is a proper noun, is coming from B and B is a verb, D is the determiner, right? A and D. D is the determiner, A and D the article. Capital is like a noun and is conjunction here, right? Most is adverb. It's trying to saying that most populous is like adverb. Populous is adjective. Or anything which bumps up the or pushes the adjective, that is your adverb, and city is a noun. So if you are aware, this is your parts of speech. Very good. Period, right? So under this topic, there is something called syntactic analysis, also called parsing, syntactic. Okay. So guys, syntactic analysis is crucial for understanding the grammatical structure, which I just explained quickly. See, for a human being, it's easy because you have learned the rules of grammar. You know that. Understanding the grammatical structure of sentences and how words relate to each other, right? Now, if you understand, right, look at the relationship here. So London, right? So if you see has a predecessor, which is saying London, and also has a successor which says capital. So London is the capital, right? So I'll come to that, how to understand this chart, right? But what I'm trying to say that there is a relationship between from, to, and then we have the determiners. Okay, so I'll come to that. But let me just complete my notes or pointers so that I'm not lost. So syntactic analysis, someone can ask, so we have already explained the objective, but what is it? It is the process of analyzing a sentence to determine its grammatical structure. So that's the technique or the concept. And then I mentioned dependency parsing. So once you understand, so once we have identified the grammatical relationships between words, dependency parsing constructs a dependency tree or graph, which you just saw, that shows how words in a sentence depend on each other. And once the models were able to do this, the understanding of each and every line has become. So it has not been done, or it was not done in a day. It took its own time, right? So NLP is here for the last 10 years almost, I would say. I can be wrong also, but this is how it is. So you need to understand that the kind of relationship you are seeing here. So London is the capital and most populous city, right? You can quickly find out the grammatical relationship, right? But just imagine that there is no human behind it. There's no human behind it. Model is telling that relationship. So this tree, I'll get into more details now since I've completed it. So this tree is known as dependency parse tree. Okay. Just imagine that for each and every line you've written in that article, models fully understand the relationship. So London is the capital. So what is the line? I'll write it somewhere here. So London is the capital. So I'm saying London in the Hindi, but I can't say pronounce in the in British accent. British accent is the capital and most populous city. Right? This is a sentence, guys. Come on. So we are saying that London is the, so you see, right? Let's start here. So obviously root is the, this is your root. Okay. So don't miss that. Root is this, but you also know that London, which is the proper noun, what is the relationship, guys? You know that, right? If you have done a little bit of grammar, my God, those were the days in school. I remember, and my teacher used to beat with a rod. I'm talking about school days. I'm not bashing the teacher. Don't worry, I'll not tell the name. But he used to beat with a rod, a circular rod. and very difficult grammar question. I used to get nightmares. Okay, because without understanding, if you try to cram it, just cram it, remember everything. It's very tough. So London is the subject of the sentence. Okay, and it's connected to the root verb is, right? So I'll also write it, and it's connected to the. So my teacher would have been proud. Now he is teaching grammar in grammar in AI, right? He must be proud about it. I'm not doing anything. The models are doing anything. Sometimes I feel, why we did so much of, so much of excellence, pursuing an excellence. Now model will take over. Okay, anyways, just kidding. Subject, predicate, remember all those things? Complement is the predicate. So I'm going to be grammatical here. So see guys, my starting was in Hindi medium, so I'm not too good at it. So forgive me if I'm saying something wrong, but at least my notes can't be wrong, so don't worry about it. What is capital, my dear? Capital is the complement, or also called predicate. Remember predicate noun, right? So can you see very smartly, I have told you that the root is attached to this guy, subject, follow this yellow color, and also attached to this guy, which is your capital. Hello, everybody. So subject, London is the capital. Okay, fine. D is determiner. Okay, very good. Thank you. But I can still stop it, right? London is the capital. This is your determiner. Very good. See the linkage, right? The relationship, subject and predicate. D is your determiner. Now, most populous city, you can put it into like a phrase. That, dude, this is a phrase. Most populous city, I can take it as a phrase. And that is being connected using this conjunction called and. Interesting. So what we're trying to do, the model, I'm telling to the model that, dude, understand, London is not only the capital, but also most populous city. So model saying, okay, boss, I got it. What are you trying to say? Are you feeling it? That's how human knows, right? That's how human knows. If I tell you, Masrat, that London is the capital and most populous city, you know, right? He means that it's not only the capital, it's also the most populous city, right? Very, very good. But model goes one step more. It also tries to understand that maybe that's the reason because it's the capital, because model totally understands capital is like some major cities, right? Because if you're doing like a ChatGPT kind of thing, it has got a lot of contextual learning. They know that top cities by population, London will be there. Why London is so important? Everybody's flying to London. Something is good. So they might have the flight data. That might be the reason that a lot of people are coming. The ChatGPT can also go and find you reason that why it is most populous city, right? You want to try this with me, guys? Come on. So I'm just putting a command or prompt saying that London is the capital and most populous city and asking why, right? See, I was right. How good it can be, guys. My God. Look at this. Can you see that, guys? Obviously, I'm not trying to teach you with ChatGPT. I'm just saying that here ChatGPT should be used if you have a license, my fellow trainers. So see, London is the capital and most populous city. I ask why. It's a factual statement. So it's thinking like a human. Dude, you're right. It's a factual statement. It's correct. It looks correct. Why? Because it is a capital first, meaning it has all the political, cultural center of the country. See, it understand that why a city becomes capital. You understand? So when it has the center for the administrative, political, and cultural center, generally that becomes the center. Look at the training it has been gone through. Then it is explaining what you mean by capital, right? Then most populous city because, right, London's role as economic, cultural, and educational hub, attracting people from all over the country and the world. Isn't it just now? I just mentioned that maybe 2 minutes back before ChatGPT spit it out in a very one-liner. So do you think that the ideologies or the kind of, that look at the beauty of these things, that it is trying to reason out that these two rows is the reason that sentence highlights both characteristics, and that is the reason that make London most important, which is capital and populous city. So what it has done in its honest way, Mr. ChatGPT 4a 4o responds to why. Do you think if I don't tell you that it is being written by ChatGPT, you might think that someone has written who has good knowledge, right? A very good, well-read person has written this. You understand why I'm saying this? Because this is going to be much better down the line. And it's getting better and better, I can see. So that's all from my side, guys. On the NLP, you can keep trying to make India more proud, Priyank and Srini. One guy can try to think about bringing the wealth back, you know, and one guy can think about, making the India independent, which I like. Okay, there's one more thing which is important, which is your step 7, POS tagging, which is similar to what we're discussing, called parts of speech tagging. So POS, which is parts of speech tagging. So POS, parts of speech tags, contains quite a lot of things: verbs, adverbs, nouns, pronouns, adjectives, right? That help. I'm not reading everything. That help the meaning of words, help to understand. Sorry, I lost my thought. That help to understand the meaning of words in a grammatically correct way in a sentence. So guys, trust me, it has a big list. So I'll give you this one. See here. So nouns, right? So if it is a noun which is coming like singular or mass, it will be NN. Plural will be NNS. Proper noun will NNP. P stands for proper. Proper noun, plural will be NNPS, right? Like London's, Smith's, right? Similarly, so it's a big list and you don't need to remember this. Don't worry about it at all. Model will take care of it for us. It will have this list as a more like a dictionary. You don't need to worry unless until you're trying to make your own. So this is like exhaustive list of everything. So that's all from my side on the pipeline, guys. As I mentioned earlier, and I'm repeating myself again, this is not the end, or this is not the exhaustive, or this is not like everything we have to do in every data and every project, but it's a good starting point for all of us, and you can build on top of it on your knowledge. So I want to show the data first, then I load it, right? So if you see, right, these are your IDs. I think it must be a text. So I'll say general, right? So these are the columns, guys. Airline sentiment. So it's already being captured that, sentiment, confidence, negative reason, confidence, which are the airlines. I think it's a US Airlines, you have American, Delta, Southwest, right? I think this is mostly blank, not much blank, but yeah. Name, negative, reason, gold, retweet count, text. I think this is where I'm interested in, right? It looks like a real test. Can you see that? Read @Virgin America. Okay. So it's saying, seriously, would pay $30 a flight for seats that did not have this plane. So, obviously people have written a lot. Okay. So this is the data we are going to consume in our analysis, guys. Okay. With me here so far. So this is the screenshot of the data, guys. So what is our objective here? To classify the sentiment of tweets into one of the 3 categories. And you saw, right, what were the categories? It was positive, negative. Cool, guys? Make sense? Data description. Someone would be interested in knowing data description a bit more. So let's write it. So obviously source is Twitter, no brainer. Coming from a project on Kaggle. Okay, Z. Description, high level description, guys. Passengers tweets about airline performance, having sentiments about their journey. See, I could do this on Colab, but the problem is that Colab is really slow and time is less. You have seen, right, Priyank? So it takes time to react to what I'm writing. That's why I'm not much happy with that. That's the whole point. Anyway, you're not going to code with me, you just have to see on the screen. So let us do that. Idea is not to code with me. Okay. Now, what we are going to do, what are the learning outcomes, guys? So number one, we are going to do the, quickly text-based EDA kind of stuff. Then try to give you the basic understanding of text pre-processing. Then we will talk about after text pre-processing, which is like backup words and tensor vector IDF and other stuff. Then we build the classification model, tune it and plot it, right? So I've already written for you guys so that I don't waste time on this. So these are the learning outcomes I'm going to try to give you. Those who have not installed this, so we have to install certain library. If you're doing for the first time, pip install contractions. I think I have it. Let me see that if I have it or not. If it says requirement already satisfied, I'm good, which it did, right? So guys, we are going to take a lot of libraries here. The idea is to use and then understand rather than detailing only on the libraries doesn't make sense, right? This is a good set of starting point, but don't worry, I'll explain each of these when I'm going to use it. So don't worry. Okay, I'll come back and say, oh, I'm using this, I'm using this, I'm using that. Make sense? That's a promise. So it's not like a copy pasting the codes. It's just that I don't want to get into detailing out the libraries. There's no point. Okay. But since we have to do some detailing out later, we will do it. And I'll make a point where I'll come back and do it. So number one, I think you need to load the data into PD's data frame. No brainer. It's a CSV file. You saw that, right? I think, I don't know, did I import OS or not? So I need to see what is my current working directory and I'll keep the file there. Okay, so this is your batch, right? So I have to take tweets. The same file, I'll copy and paste it there also, which I did it for the some other batch. Done. So let's load the data. So it will be pd.read CSV. The beauty of this is good. Okay, let's do some sampling. So this is the reason that I'm doing here. How fast I'm able to code here. So see the data loads nicely, right? You have the tweet ID. Basically, it will be the passenger. I think Srini were asking, right, that how do they collect data, right? So it's coming from Twitter. So for every person, there is an ID. Okay. So for every, I think, person tweet, it's an ID. And then airline sentiment. So few things are blank, you can clearly see, right? But we have to just worry that we have everything which we want to have it, right? So let's understand this data a little more. Obviously, we will start identifying the missing values and see that if that's a concern for us. How do we do it, guys? So we'll say data is null. You have seen me doing it earlier, and you do sum. So it will give you that how many guys are missing, and you can also do a percentage split. Okay, so you can say take this bunch and divide by the length of your data, right? So you know that you have some real stuff missing. 37% is your negative reason. Airline sentiment gold is like fully missing, right? Tweet. But one thing which I see that text is like fully there, right? That's what counts for us. For us, text is important, right? See that? So none of the tweet is blank. Can't be possible, right? How can you have a tweet without anything, right? You can't put just some 00, right? You understand? It can't be null. It cannot be an empty tweet. That's how they have designed it. Let us do some amazing EA. And this is not like what I'm doing is enough. You can always build on top of it. So I'll do some EDA. As simple as that. EDA, you know, right? Exploratory data analysis. Okay, let me write. So what I'm saying, guys, let's find percentage of tweets by airline companies, right? Nobody goes there and they tweet. Generally, people also tweet positive things, feedback they give. But have you ever gone there and tweeted something about because you liked it the most or you loved it, you did not like it the most? Tell me, where do you tweet more? I think I have only tweeted whenever I felt real harassment from the companies. Okay. So percentage of tweet will tell you that if someone is harassing someone, right? That someone is like company. So in US, Twitter is really famous. People tweet and almost everything there. I'm feeling it is hot. Let me switch on the AC. Or no, let me switch on the fan only. Import C1 as SNS, right? Let's take a canvas, count plot, data equal to data, X equal to airline. What is the column name? Yeah, airline. Palette, paired. This you have done multiple times, right, guys? So you can clearly see that of all the tweets, how many tweets you have, by the way? 14,640. That's your total tweets, right? So you can say print total number of tweets is how much? 14,640. Out of that, who is having the highest? United Airlines, right? Some generally people ask me, Akash, this is so fine. Can you show some percentage on top of it here only? I know a lot of people thinking about it. Guys, can you show me percentage also on this chart only? You can do it, but it is a little tricky, not that easy. But at least, see guys, we will not be able to spend more time on these kind of requests. But yeah, we can clearly see that. Yeah, this is an older data only. It's a very famous data set. I think if date is there, I would have told you what data is this one. But there's no date, location, time zone. No. Yeah, but it's not like a recent data. Don't worry. I'm not saying that also. So what I'm saying, guys, we can see the percentage of tweets for United Airlines has the highest number of tweets, approximately 26%, followed by, I've done this maths outside, don't worry, by US Airways, which is 20%. Good. So at least you know that who are the airlines which is getting a lot of tweets. You can clearly see United Airlines is topping it, followed US Airways, and then American. Okay. I'm not saying that they have more issues. Don't jump to conclusion. I'm just saying that they have highest number of tweets. And you can do some pandas data aggregation technique to get percentage and all. What is the distribution of sentiments across all tweets? Right? Someone can ask me this question also. Like now, since it's interesting, right? So plt.subplots fixed size, exactly my point, Masud. Our focus is more on to get into the NLP task rather than visualizing a lot. So as far as we are able to get a sense of the data, we are good here, right? And I know you can do much more on top of it, but that's your work. So data equal to data. Now, what is that X where the sentiment is? I think airline sentiment, right? This column. And airline sentiment is not having nulls, so we are good. So we'll write airline sentiment. Perfect. Palette, again, paired. Perfect. plt.show. Now you will see the reality of the tweets. So it's a human behavior, right? If you're not feeling happy, you'll go and tweet. Even Americans do that. Can you see it? It has to be high now. Let us see some negative comments randomly. How will you do it? Only filter for negative. Select negative equal to data. You know this, right? Slicing. Airline sentiment equal to negative, right? And then you will say data, use this masking and do some sampling, right? Show some sample of 5. See? And only we have to print the text. Not everything. I don't need everything. I just need the text. So now obviously we are not able to see everything. So we do this list and then see if it happens, right? Amazing. Python is so happening here, you see? Yes, but should be able to get a push notification via the app if I'm logged in and on a trip. Email or text is so 2010. So this guy is telling it's very old. United Airlines, once again, your lack of customer centricity is astounding. It's a sarcasm. Wow. Why so expensive to go to Vegas with the stops in late flight zone as I can get non-stop for same on competition. See, just flew to do this, paid from a third suitcase, who did not even make it on the plane, besides for the impolite service. See, Americans, right? They have a way of telling things. इधर तो गालियां लिखने लग जाते हैं, right? Okay, cluster continues still on connecting instead of direct. Back charge sits not together. So understand this is for the same one, right? And if you keep doing this, you'll keep seeing something. I'm at 4 or 5 morning. Will be nasty in Boston. Have Fabling driving 90 minutes to pick me up from everything flight. What if cancelled flight? I don't know, something they're writing. But why they know that it's negative? Because in the same data, hold on. In the same data, you don't do this, you will see that they have a category, no? See, negative, 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 negative. There's a reason also, customer service issue. Can't tell. So must be like a filter, right? Select, can't tell. Cancel flight, customer service issue, right? So as a matter of fact, for negative reason, right, you have some missing data, right? But similarly, you have for positive reason also, I think you have some missing data, I realized. No, only for negative reason they have this category. But anyways, we know that there are negative tweets. Let's see if it is, what about positive tweets? Let's see that. So आपको कुछ नहीं करना, you have to just go there. So I'm speaking Hindi. My bad. Say that, select positive, change this to positive, and just see this. Now, everyone has been so nice and helpful. Looks like positive, right? I'm already a card member as well. Enjoy flying with you guys. Wow. Thank you. Simple, positive. Thank you means positive. Thank you, positive, right? Let's see neutral. I would love to see neutral. So let's do any it. See, this is so fastly we are trying to get into it, right? You like my way of slicing and dicing the data, guys? I have a way of getting into the data. Now, if you're not good at basics, you will struggle. I recently moved and got a new license, and when I booked my flight a month ago, I used my own license. Do I need to change that? Obviously, it's more like a query. So it's not like DM these nuts. I sent you a DM. Can you please help? Obviously, neutral. Look into better service. More like a suggestion, right? So obviously, somebody is tweeting and they are categorizing. I don't know what is they're doing to categorize. I am not sure, but this is the data we have. Makes sense so far with me? I had written this code for you because I don't want to waste time, but I want to show you that there is a way of someone asking me, right, can you also show percentage? One of the learners did it. I realized that I have it in my other notebook. So I just source the code and it's on the same data frame, so it works. Data, right? See, 62% of the total tweets are negative. 21% is like positive, neutral, and then the rest of the 16% is positive. So as you can see, guys, you need to do some annotation, right? So Srini, you were right about it. So I think you have to spend some time on understanding this code. It's very easy. So what are our some key observation, my dear? Number one. So majority of tweets are negative as expected. We expected it, no, before we started on it, which stands at 63%. Followed by, that's how you have to give summary to your client also. Followed by neutral tweets. But this is very basic insights. I don't write these insights. I write insights which will take at least 10 minutes to understand. That's how you get valued, you know. If you write these statistical insights, they'll say, what is in it? Even I can do it, right? So you have to write something like you have to make a statement. And then they'll say, what? Then you prove that statement with your data analysis, which you have already done. That's how you win your clients, okay? Can you show me distribution of, this is a very interesting chart. Distribution of sentiments of tweets for each airline. Now this is interesting, right? So you are telling total, no? So total is negative, but for which it is negative? I think we have to do some data preparation for this. So understand, I want to know distribution of sentiments for each airline. I have to group by airline and airline sentiment, right? Guys, pandas aggregation, you know this, right? We can call it a multitasking ability. I also have some abilities. Count, and then I think I need to unstack so that I can show you this. Now, yeah, it worked. See, this is interesting, guys, right? So now it gives you that by different sentiments for each of these. Interesting, no? Now, the good thing that Panda says, I can only plot. Why you want to go to? And that's why I love some of Panda's plot. Although people bash it, it's very it's very basic. Baba, but if you want to get something nice and fast, right? Pandas is good here. See, you don't need to do anything. See, interesting. So at least know that United Airlines is not having the highest. It is also having the highest bar in the negative. So is for US Airways, right? So it looks like it's already much in the line with what you would expect. So we identified top three guys, these ones, right? US United Airlines, followed by US Airways and American, right? Remember that? Same guys are coming here also. So you can do some sorting and all, and then the chart will look more better. So it's very evident. So what is our plot the stack bar, right? Stack bar chart showing percentage split of sentiment for each airline. So there is another way to show the same chart. That's what I'm trying to do as a task. So rather than showing three, can you see 3 bars for each airline? What I'm saying, my dear, take this guy, take only US Airways and show like percentage split. You know what I mean? So basically we'll see only 5 bars, but showing percentage of these guys, right? That will be interesting to see if you can do it. Okay, I can do it in a matter of 5 minutes, but that's something. So it is evident from the output that for almost none of the guys, only Virgin America, I think they don't have, right? Virgin America, they don't have enough. So it's like I'm equal in all three. Can you see that? So he's saying that doesn't matter, dude. I'm neutral, I'm positive, I'm negative, I'm everything. So Virgin America is like, okay, I don't have any idea what I'm doing. Obviously, it's insignificant business, right? But anyway, anybody would talk to you, any company, big company, during these meetings that, okay, talk about top three or bottom three. So it is evident from the output that for almost all the airlines, let me write, the majority of the tweets are negative, right? Followed by neutral and positive tweets. Virgin America airline, right, is probably the only airline where the ratio of the three sentiments group is somewhat similar. See, so as a matter of fact, right, you have to highlight it in your insights. Okay, good. Someone can also say, okay, I also want to see, okay, now I'm not worried about positive, I'm not worried about negative. Someone can say, dude, let us deep dive only on the negative reasons. So let us plot it. I'm just being selfish. PLT.subplots 8,6. You know what I'm doing, right? Count plot data equal to data, x equal to negative reason. I'm plotting the negative reason distribution, palette equal to paired. Wow, it's so messy. Yeah. How we will fix it, guys? We'll do some rotation. Right? You can rotate plt.xticks. There's a parameter called rotation. See, not round. You can do by 90 degree. Interesting. Customer service issue followed by late flight. Okay. A lot of people are ranting, but they're not sure. So they can't tell, right? Lost luggage is also there, huh? Cancel flight. But the biggest thing is your customer service, right? Can you see that? So let's write it, guys. It's an insight, right? Customer service is the top reason for negative sentiments. Okay, this is good. Now, guys, let us do some NLP work. So let us start with word cloud. You know word cloud? It's an EDA thing only for negative tweets. It's a visual way of seeing that what is impacting us the most, right? So we'll call from word cloud. So this library helps you for plotting the word cloud, and you have to also take stopwords. So guys, I'll create a data frame which is only filtered on negative tweets, right guys? Which is airline sentiment equal to negative. I have just created a new one. I could have used the older one. So this is like filtered for negative sentiments. Now guys, I'll do a join with a space, negative df and text. So what it does guys, so you know, right? It filters for the negative sentiment, and then what we're doing here, combines all the tweets, which are basically what? Stored in the column text now, guys. Stored in the column text, not text, text, into a single string where each tweet is gonna be separated by a space. So powerful techniques, huh? By space. As a matter of fact, you can put anything there. You can put APC also, huh? Let's see it works. Now see the words. So the whole, all the tweets have been combined into a big thing like an article, okay? No need to do for loop and all. Sometimes people start thinking about for loop. Why for loop for everything, right? With me so far? Now we have to do some cleaning of the combined string. So obviously I need a clean text. So I'll say join. Now guys understand. And I'll explain also, don't worry about it. I'll take word for word in words dot split. How many of you are able to guess this? What I've written? This is something you should know. It's coming from basic Python. So you're writing for loop in one line. Split the text into words. How will you do it? What is this line of the code is doing, guys? Come on. Oh, let me also complete first, because I think I'm asking question in the middle. Hold on. If so, split, and that's a problem with the commentary. I'll come to the commentary later, guys. Hold on. Then my block goes disturbed. Okay. If I think let's take away HTTP, not in word, and not word dot starts with, you know what, every tweet is gonna start with @, so I have to take care of it also. And word is not equal to right retweet, so it will be exclamation. Now what I'm doing here, anybody got an idea? Now you look at it. So number one step I'm doing, splitting. Come here now, splitting the word. Which word? This is the word, no? Okay, let me write words. So this is the words, right? All these are words, right? Take a look. Okay. So I'm splitting the words string into individual words based on white space. How do you know that? Because I've written this now, white space is there. Okay. Now I am going into the next, and this is called list comprehension. So this is what we are doing, guys. Okay, maybe I'll write here. So this is something leveraging, I don't know how many guys remember this, it must have been taught, leveraging list comprehension. If not, we can discuss also this. I'm saying we'll discuss, but I don't know I'll get time or not. Now I'm saying if HTTP not in word, what it means that exclude any word that contains HTTP, right? So generally social media will have HTTP, HTTPS, and you can improvise on this, right? So that's not like a hard and fast rule. Then what you're doing, you are excluding now anything. Exclude words which start with, not like any word just @, any words start with @. Then what? Retweet you don't want to use. So this removes the term retweet, right? what I did. There's some shortcut which works on this machine, which is in overlap with Jupyter. I have to rewrite word not equal to retweet. So I'll say exclude RT term. Okay. And then I have to do this so that it runs. Okay, it ran, guys. Let's see what it did. See. Now if you observe, right, do you see any at the rate? Let's see this. So very first line was at the rate, right, guys? Come on. The very first word was at the rate. So at the rate Virgin America is gone. See, it's starting from it's really aggressive to blast obnoxious entertainment in your guest. Okay, very good. Then what we excluded? We excluded anything HTTP. I don't see, so I'm not able to. Any retweet you're seeing somewhere, it should be also gone. But yeah, we will not definitely go and check. Okay, agree? So this has done all these steps which I mentioned, but obviously we are not able to validate. It's a big thing, so I can't go and pinpoint. But yeah. Now the other thing, if you see, right, we need to remove stop words, right? So for the word cloud, I'm gonna use word cloud without stop words. So stop words is a list which is gonna be there, and it is stop words. So guys, this is already there. Background, you can say, you have to give some color. You can say black is much preferred. Width can be, you can say 3000, and height can be maybe 2500. Just start with something. And okay, then I'm saying that generate clean text. So guys, it will exclude common stop words. But if you have some laundry list, did I miss something? Background, color, okay. Now, the moment you give stop words equal to stop word, it will exclude. Default is to exclude, not the other way around. It is taking some time because loading a lot of data must. So when you write stop word equal to stop word, it will do the job. So even my machine is like saying brute. Fan is like, so it's done. We have to just print it. So obviously the word, it's run, it's run. So let me plot it. plt.subplots, fixed size. I'm ready. 18 by 18. I am show word cloud plt.access off plt.show. Interesting. See guys, I can make it more tiny so that everything can be, width can be 12. This can be 9. See. Oh, sorry, I did ulta. Height can be 6 and now see. But you can clearly see, I think we have to generally go to the square thing, but you can open the image in a new tab and see, right? So obviously people are talking about flight. So someone can say, right, why don't you remove flight first? Okay, and then do this. But you can clearly see that a lot of things has to do with bag. So you know that people are losing bag or something with respect to bag. Hour, time, right? Help. So they're looking for help. Customer service is also coming, see? So as bigger is the size, that means that that's what being come. It's like frequency, right? So if your font size is bigger, that word is existing or repeating more and more and more. That's the reason that we already removed the common word, because everybody will write English with the help of those common stop words, right? So I don't want to show is, he, she, I am fed up, what are you doing, right? I don't want to show those, are you an idiot, right? So those things we don't want to show that. Are, I don't want to show. Is, I don't want to show. That's why I removed the common and stop words. But even if you see bag is there, I think help is there, hour and time is there. So it gives a good feeling, right? Cancel flight is also coming if you're able to see this, right? On the vertical. I think this is the way it automatically handles. Some words are like vertical, some words are like, it takes random approach to it. Obviously, I have not written this library, so I can't be commenting on that. But you can clearly see that hour and time is to like superbly coming. Customer service is on top of it. Hold, something is coming as a hold. Can you see that? I don't know. Did I choose the right color combination? Guys, I'm really bad with colors. Yeah. So see. So gray is definitely not. It's a turn off. I think you might be looking for white. You can give some hex code also. It's a big hands-on, guys. It will take another an hour. So this is how it looks like, guys. So you'll see now it has slightly changed, but flight is still the bigger, then followed by the positioning will keep changing every time. It's like a random. So hour and time was somewhere in the top, right? Remember? Now it has shifted slightly. So guys, this is all from my side on this. So I think black was better, so you can keep black. I'll save this image in the Google Drive so that you have it, you don't lose it. You love the black, it seems. So I have put it there, saying it as word cloud, negative sentiments. But same thing you can do for the positive also. I think we have a lot of things to do. Why U is highlighted? Where you see U is highlighted? Yeah, because a lot of people start writing you have done this. So we need to take care of it. This is what you have to do, handle this in WU as a stop word, right? So generally in our normal dictionary, nobody writes you, right? This is like a slang chatting language. So sometimes you have to use, there are a lot of library as well. So you means your you, right? So we write, no, you are like you means you, right? YOU. So people write you, like let is also there, into is there, info. So we can take care of this. So we can further clean it up, but that's something we have to handle at our end. Yeah, someone can, or WTF they can write. So Americans say what, what the WTF a lot of times. So if you if you don't do a proper cleaning, that might pop up here. So you have to be very careful before presenting to everybody. Okay, so this is just the beginning. I think I need another an hour on this, and then I'll be able to complete this whole hands-on. But this is just the warm-up I have done for the day, guys. I hope you liked it. So this is interesting. People are finding a lot of things, right? I think we can take away. So a lot of things we can do on top of it. I've just used the library. So you remember stopwords is coming from here. So if you see the library, right, we have the stopword. See, NLTK download stop. So NLTK natural language, kit. It's a library. It's a big one. People have been using this. So let me share this link. Natural language toolkit. So trust me, it's like a ocean in itself. So I'm sharing the link here. Beautiful soup is what? It will come later, Shalja. So I can't jump there, but I'll come to that. We have just used stopwords from here. Okay. So if you see here, the word cloud, I'm using the word stopwords, right? So that's something you can see.
Just a quick info, guys. Intelepath offers artificial intelligence course training, which will enable you to learn skills like neural networks, focusing on CNNs, RNNs, and their application in AI, natural language processing, computer vision, and generative AI. Through this course, you will also master deep learning concepts, AI model building with TensorFlow, transformers, BERT, GPT, LangChain, and NLP pipelines with advanced techniques like image recognition, chatbot development, and much more, all taught by top 1% experts and IIT faculty. And with this course, we have already helped thousands of professionals make successful career transitions in AI and data science. You can check out the testimonials on our Achievers channel. The link is in the description below. And without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take your first step towards the dream career growth in the field of artificial intelligence.
Keeping up with the AI advancements can be exhausting. One day it's a new chatbot that can write poetry, and the next it's a model predicting stock trends. According to a report from the World Economic Forum, 85 million jobs are going to be replaced by AI by 2025, but at the same time, 97 million new roles will be created in areas like AI development, data science, and human AI collaboration. So how do you stay ahead in this rapidly changing data-driven world? By building real hands-on AI projects. Working on projects not only helps you understand AI concepts better, but also prepares you for real-world challenges. It's the best way to learn, grow, and make your skills future-proof. In this video, I'm sharing 10 AI project ideas, 5 for beginners and 5 for advanced, designed to give you the practical experience you need. Whether you're just starting or ready to tackle the big stuff, these projects will help you build something meaningful while also making your resume stand out in this competitive field. So the very first project idea that we'll be discussing is the product recommendation system. This is a system used by companies like Amazon, Netflix, and Spotify to suggest products, movies, or songs based on what users like. A product recommendation system is an algorithm that analyzes user behavior to suggest products that they might like. For example, the system or the algorithm might recommend phone cases or screen protectors if someone buys a phone.
This makes shopping more personalized and engaging. An interesting fact before you dive into this project: Amazon's 35% of sales come through product recommendation engine itself. This tells you how valuable this project would be if you were to make a career in any e-commerce company. The first step in this project is to gather and pre-process data such as user ratings, browser history, or product descriptions. You can find a sample data at Kaggle or UCI repository. You'll then use machine learning techniques to develop the recommendation model. Popular methods would include collaborative filtering, where you recommend items based on what similar users have liked, or content-based filtering, where you recommend items similar to what a user has shown interest in before. Now, the tech stack for this project would include Python as the main programming language, with libraries like Pandas for data handling, scikit-learn for building machine learning models, KNN for collaborative filtering, or decision trees for content-based filtering. You can also use Flask for building a simple web app to display the recommendations to users. Completing this project will give you hands-on experience in machine learning, data manipulation, and web development. From a resume perspective, this project is a great addition because product recommendation systems are widely used in many industries like e-commerce, entertainment like Netflix or Spotify, and online services. Now, the second AI project idea is cancer disease detection. This project uses artificial intelligence to help detect cancer at an early stage, which can be crucial for saving lives. Now, in order to get started, you will need a dataset that contains labeled medical images of cancerous and non-cancerous cells. There are several datasets available online like the Cancer Image Archive, TCIA, that can help you with this. Once you have your data, the next step is to pre-process it. For medical images, this might involve converting them into numerical arrays or normalizing them to ensure consistency. For the tech stack, you will be using a combination of Python and deep learning libraries. The most popular deep learning framework is TensorFlow or PyTorch. Now, these libraries are great for building and training machine learning models. You will also work with CNNs, which are specifically designed for image recognition tasks like this one. CNNs analyze patterns in the medical images and then classify them as either cancerous or not. Now, to handle the data, you can use Pandas and NumPy. You can also use Flask or Streamlit to create simple web app for your algorithm. This way, doctors can upload images and your AI system will analyze them and give predictions on whether the image shows signs of cancer or not. Now, what's the benefit of working on this project? By working with the real-world medical data and applying deep learning techniques, you'll develop technical skills in AI, machine learning, and data processing. Now, this can prove to be highly valuable for your resume. Completing this project will demonstrate that you can work with large data sets, develop models, and even deploy AI systems, which are skills in high demand. Now, moving ahead to the third project idea. Businesses and consumers rely heavily on online reviews to make decisions. However, reading through thousands of reviews to understand customer opinions can be time-consuming. This is where sentiment analysis comes in. It's a technique in artificial intelligence that can automatically determine whether a review is positive, negative, or neutral. Through this, businesses are able to quickly gain valuable insights into customer feedback. The project will begin with collecting product review data, which is publicly available from sources like Amazon or Yelp, and then pre-process it. For the model, we will use machine learning techniques, specifically natural language processing, to understand and analyze the text. Initially, a simple model using techniques like bag of words or TF-IDF combined with a classifier like logistic regression can be implemented. Later, you can enhance the model using deep learning with RNNs or LSTM, which is long short-term memory, for better accuracy, especially for complex sentences. On completing this project, you will not only boost your understanding of NLP and machine learning techniques, but also make your resume stand out. This project will demonstrate your ability to handle both data pre-processing and model building, skills that are highly sought after in AI and data science roles. Additionally, it's a great way to get hands-on experience with Python and machine learning frameworks, both of which are valuable in the tech industry. Moving on to the fourth project idea. Job seekers today face a major challenge: getting their resumes noted by recruiters. Many companies use an applicant tracking system or ATS to filter resumes before they even reach a human recruiter. These systems scan resumes with specific keywords, job titles, skills, and qualifications. If a resume doesn't match these criteria, it may never get seen by a hiring manager. Now, the goal of this project is to build a system that can automatically pass and extract important information from resumes. This makes it easier for ATS to process resumes and for recruiters to find the most qualified candidates. The resume parser should be able to extract details such as the candidate's name, contact information, skills, education, work experience, and certifications from various resume formats like PDF, docx, and plain text. It will also analyze and categorize this information, helping job seekers optimize their resumes for ATS. In order to get started with this project, we'll use natural language processing or NLP to extract and understand the content of resumes. For parsing different formats, you can go ahead and use libraries like PDF, Miner, or docx in Python. You can then employ machine learning models for keyword extraction, entity recognition, and classification to identify and organize this information. There are also libraries such as Spacy or NLTK that can be used for text processing. Once that is done, we might also want to integrate a simple scoring system that ranks resumes based on the match to a job description. Completing this project adds immense value to your resume and skill set. You'll gain hands-on experience in working with text data using libraries and tools commonly used in industry for NLP tasks. You'll also understand how ATS systems work and learn about their role in modern hiring processes. This project will strengthen your proficiency in Python, machine learning, and NLP, making you a more attractive candidate for roles in data science, AI, and software development. Plus, it will give you a practical project to showcase, demonstrating your ability to solve real-world problems and adding a highly relevant skill to your resume. Moving on to the fifth project idea. This project focuses on a world where machines can see and interpret the environment just like humans. Real-time object detection is all about teaching computers to identify and track objects in live video feeds, such as recognizing a car, a pedestrian, or even a stray animal crossing the road. The problem this project addresses is simple yet impactful. In many industries, from autonomous driving to security systems, there's a need for technology that can detect and respond to objects in real time. Without it, processes remain slow and manual, and in some cases, this delay could even lead to accidents or inefficiencies. This project allows you to bridge that gap by creating a system capable of detecting objects instantly, enhancing safety and efficiency. You'll begin by collecting a dataset of images with labeled objects such as COCO or Pascal VOC. These labels help train your model to recognize different items. Then you can go ahead and use a pre-trained deep learning model like YOLO, You Only Look Once, or SSD, Single Shot Detector, which are designed for speed and accuracy. With frameworks like TensorFlow or PyTorch, you will fine-tune the model, feeding it data and teaching it to detect objects in real-time video streams from a webcam or CCTV camera. Finally, you'll integrate OpenCV for video processing and visualization. The tech stack includes Python for coding, TensorFlow or PyTorch for building the AI model, and OpenCV for handling video feeds and a GPU to process the data quickly. You'll also use libraries like NumPy and Pandas to manage the data. For your resume, this project will showcase your expertise in computer vision, machine learning, and handling real-time data, which are sought-after skills in the AI job market. On the other hand, for organizations, the benefit is enormous, whether it's enhancing surveillance systems, improving vehicle automation, or optimizing industrial workflows. Moving on to the sixth project idea. For a business that receives customer queries day and night, hiring people to answer these questions 24/7 can prove to be expensive and sometimes inefficient. This is where chatbots can help. A chatbot is an AI-powered assistant that can understand customer questions and provide instant answers, saving time and money while improving customer satisfaction. To build this project, you'll start by defining the purpose of your chatbot. Will it assist with customer support, book appointments, or maybe help users navigate a website? Once you figure out the main category of support, you'll need to gather or create a dataset of common questions and answers related to your topic. Next, you'll use tools like Python and frameworks like Flask or Fast API to create a conversational interface. For the AI brain, you can use pre-trained models from libraries like Hugging Face, which help the chatbot understand and respond to text. The backend might use an NLP model like BERT or GPT. These models analyze the input text, understand its meaning, and generate appropriate replies. If you're making a more advanced chatbot, you could connect it to a database or APIs to retrieve specific information like product availability or order status. Once the chatbot is built, you can again deploy it on website or messaging platform using tools like Heroku or AWS. This project is a fantastic addition to your resume. It shows your ability to solve real-world problems using AI to automate processes and build systems that improve user experience. By completing this project, you'll demonstrate your skills in Python, NLP, and deploying AI systems, which are in high demand. Plus, it gives you a practical example to discuss during interviews and sets you apart from problem solvers ready to tackle real business challenges. Moving on to the 7th project idea. Now, if you're a developer working on a large project with multiple team members, understanding someone else's code is like solving a puzzle, especially when the code lacks clear documentation. Writing documentation is tedious and time consuming, which is why most of the coders neglect it. This is a common problem, often leading to miscommunication, bugs, and slower onboarding of new developers. Code Document Generator is an algorithm designed to bridge this gap. This project aims to automate the processing of creating detailed and accurate code documentation. You will build an algorithm that will analyze the structure, functions, and logic of the code base and generate human-readable explanations for each part. To build this project, you can use technologies like Python and Hugging Face transformers. A model like GPT-4 can be fine-tuned to understand code and generate meaningful descriptions. You'll also work with frameworks like LangChain for chaining tasks and FastAPI to deploy the tool as a web service. You can also go ahead and add a front-end interface using Streamlit that will make the algorithm user-friendly and visually appealing. By completing this project, you'll gain hands-on experience with advanced AI concepts like working with large language models and deploying them in real-world applications, while also highlighting your understanding of generative AI. The next project idea that I'll be talking about has been inspired by Google's revolutionary Cotton Ace project, Pest Monitoring Application. This is basically an AI application that helps farmers protect their crops by guiding them on aspects like the best time to spray pesticides. Pests are a huge challenge for farmers. They damage crops, lower yields, and increase the cost of farming due to the needs of pesticides. Many farmers don't realize there's an infestation until it's too late, leading to significant financial losses. This is where technology, especially AI, that can step up and make a big difference. The application will use image recognition to identify and track pest infestations in real time. Farmers can upload photos of their crops, and the app will analyze the images to detect pests, classify them, and provide actionable recommendations such as whether to use pesticides or take other measures. To get started, you'll need a dataset of pest images and healthy crop photos. Then you will need to train a machine learning model like CNN using frameworks like TensorFlow or PyTorch. Then you can go ahead and add a user-friendly interface, perhaps a mobile app where farmers can upload their images and receive instant feedback. You can even incorporate weather data or other regional trends to make the app more accurate. For this project, you'll use tools like TensorFlow or PyTorch for the AI model, OpenCV for image processing, and a cloud platform like AWS or Google Cloud for deployment. The mobile app can be built using Flutter or React Native to ensure it works on multiple devices. You could also add APIs for weather forecasting to give farmers extra insights. This project is a great addition to your resume. Employers value candidates who can demonstrate technical skills with practical applications, something that brings a change in the everyday lives of the people. Now moving on to the 9th project idea. Consider a situation where a marketing manager needs to come up with engaging content for products in an organization. Every campaign is going to require hours of brainstorming, research, and editing to create creative emails, blog posts, or social media captions. This is where an AI-powered marketing content generator can make life easier. Repetitive content creation takes up time and resources that could be better spent on creative ideas and connecting with customers. By building an AI marketing content creator, you can automate the task, making it faster and more efficient while still maintaining quality and personalization. To develop this project, you would start by training a generative language model like OpenAI's GPT or Hugging Face transformers to create different types of marketing content. You can feed it examples of blogs, email campaigns, or social media posts to fine-tune the model for specific industries. Adding features like customizable tone, keywords, or target audience will make the tool more versatile. You can also integrate a user-friendly interface using tools like Streamlit or FastAPI so marketers can simply input a prompt and get ready to use content instantly. The tech stack will include Python as the primary programming language, libraries like TensorFlow or PyTorch for deep learning, and LangChain for chaining tasks like summarization and editing. Hugging Face can provide pre-trained models, while Pinecone or a similar vector database can store embeddings for fetching quick text. To deploy the app, you can use cloud platforms like AWS or Google Cloud. Completing this project will add immense value to your resume. It showcases your expertise in generative AI, NLP, and creating end-to-end solutions for real-world problems. By building a marketing content generator, you will not just be solving a technical problem, but you will be creating something that directly drives business growth, improves efficiency, and demonstrates the power of AI in everyday tasks. Here comes the last project idea for this particular video. Managing finances today can be complex and overwhelming for many people. Financial advice are often expensive, and individuals with limited resources may not have access to professional guidance. This is where a generative AI-powered chatbot can bridge the gap by offering personalized, real-time financial advice. To build this project, you would create a conversational AI model capable of understanding user inputs such as financial goals or challenges and provide tailored recommendations. The chatbot would use natural language processing to understand queries, retrieve the relevant data, and then generate meaningful responses. For example, if someone asks, "How can I save for retirement?" the chatbot could analyze the user's income, expense, and investment options to provide advice. The tech stack for this project includes Hugging Face transformers to build and fine-tune the conversational model, then LangChain for integrating multiple knowledge sources, and Pinecone or Waviate for storing and retrieving user data efficiently. Tools like Fast API can be used to deploy the chatbot, and a user-friendly interface can be created using Streamlit or React. Security protocols like OAuth can be added to ensure user data privacy. Completing this project will be a big win for both the individual and the organization. For you, it would demonstrate your ability to work on real-world AI problems using advanced tools and showcase your skills in generative AI and multimodal data integration. It's a standout addition to your resume, especially for fintech.
Recently, from Reddit threads to Twitter storms, one phrase keeps echoing: MCP servers are changing everything. Or the next big thing in AI is MCP servers. Some call it the future of AI, others say it's the missing piece we have been waiting for. But what exactly are MCP servers, and why is the entire AI world suddenly obsessed with it? Are they really worth the hype? Let's see it in detail. Before getting started, let's consider a scenario here. Suppose you're building an AI app and the things are going smoothly until it needs to connect with Gmail, Notion, or some API and database. Now you're stuck reading docs and building yet another custom connector for every tool separately. Sounding familiar, right? And that's what most devs face when working with AI. Until now. Of course, AI has come a long way. Large language models like GPT-4, Claude, Gemini are incredibly smart. They can write emails, generate code, and explain quantum physics, right? But here's the thing, they still can't send the email via Gmail or edit your UI directly in the Figma. Why? Because these models don't directly talk to the external systems or tools. To make that possible, they will need a middle layer, something like a translator or a bridge, that can help them communicate with the external tools like web servers, APIs, code editors, platforms, etc. And that bridge is the MCP servers. MCP stands for Model Context Protocol, a game-changing innovation introduced by Anthropic, the company behind Claude, one of the most efficient and high-performing LLMs. It's already being hailed as the next big thing in AI. And when even Google adopted this new thing so quickly, it became crystal clear that this thing is the future. MCP solves a fundamental problem in AI automation and evolution. That is, how to connect smart models with real-world tools without writing endless custom and fragmented integration codes. It works like a universal adapter, letting any AI model connect to any tool or service in a standardized way. Think of MCP like a USB charger, but for an AI. Just like USB-C replaced all those old, confusing chargers with one simple plug that works with everything smoothly, like phones, laptops, and monitors. MCP does the same for AI models. Instead of building a custom connection every time your AI needs to talk to Gmail, Figma, or a database, MCP provides a universal way to plug into any tool like a plug-and-play system. One protocol supports endless connections in a simple, clean, and scalable way. But why MCP is needed? You might got an idea until now, but let's see in details. So yes, AI is smart, but in the fast-moving world, being smart isn't just enough. AI needs context tools and real world awareness to truly become powerful. And that's where MCP becomes the hero, bridging the gap between what AI can say and what it can actually do. Now, before we jump into what MCP servers are, how they work, now let's see how MCP servers rose to fame and why it's making headlines and how it's quietly becoming the backbone of modern AI automation. Considering now we know that even the smartest LLMs can't act on your behalf. They can suggest, explain, even write the code, but they can't execute them, fetch the latest stock price, or move a Figma frame. And right there, Anthropic's MCP, that is Model Context Protocol, emerges as a pivotal solution to these challenges. MCP provides AI models the power to interact with the world beyond their own minds. It defines a set of standardized rules, specifically a protocol that external applications and tools can use to give context to an AI model. This context can be data, capabilities, or even actions that can be performed. And because the system is standard, any tool can plug in, any model can understand, and everything just works. Now that you already got an understanding of what MCPs are, so let's see how do they work. MCPs operate on a client-server model. Imagine it like a team working together with the three main players like the host, the MCP client, and the MCP server. First, let's talk about the host process. This is the heart of AI-powered application, whether it's an app like Claude or a plugin in an IDE. The host is the part you interact with directly, and it's where AI agents live. It's responsible for processing the requests, initiating their actions, and giving responses to the user. Think of the host as the brain of the operation. Next, we have the MCP client, which acts as a bridge or a middleman. The MCP client takes the request made by the AI, the host, and forwards it to the appropriate MCP server. It's kind of like a messenger, ensuring the request reaches the server directly, securely, and efficiently. Each MCP client is designed to handle one specific server at a time, which also helps maintain security and keep things isolated and simple. Finally, the MCP server, that's where your tasks are performed. The MCP server is usually external to the AI model. It's a plugin or a tool that implements the MCP standard, offering a set of specific capabilities. The server is responsible for processing the request it gets from the MCP client and then providing back the information or performing the actions that are needed. The server might interface with the databases, an API, a cloud service, or any other tool in the real world that you want to communicate with. So let's break it down with a simple real-life example to make it more clear. Let's say the AI, the host, wants to know today's weather in Bengaluru. The AI sends out the request, "Hey, what's the weather today in Bengaluru?" The MCP client steps in, takes the request and forwards it to the MCP server. Then the MCP server, let's say, connects and communicates to a weather API to get real-time data. After that, the server gets that data, formats it in a way that AI can understand and sends it back to the MCP client. Lastly, the MCP client then passes that information to the host, and now the AI can respond with something like, "Hey, the weather in Bengaluru today is sunny with a high of 30 degrees Celsius temperature." And just like that, the AI has real-time external information and can give a detailed and interactive answers. And this is how all it works. Thanks to the client-server architecture of MCP server, that it provides live external knowledge and capabilities, which makes the AI feel much more intelligent and responsive. So instead of the AI relying solely on the internal knowledge base, the server acts as an additional brain, providing external insights and executing actions on behalf of the AI. It's like adding a whole new layer of intelligence to the system, making it far more interactive and capable. Now let's see how does this all happen internally and behind the scenes. So the communication between MCP clients and MCP servers typically happens using the JSON RPC, which is a lightweight standard protocol for remote procedure calls. This allows messages to be passed back and forth in a clear and a structured way. Now MCP supports different ways of sending and receiving the messages. For local processes, it uses STDIO, that is standard input output, which is perfect for processes running on the same machine. For remote communication, it uses HTTP with server sent events, that is SSE, which is a way of sending real-time updates from the server to the cloud over the web. A big part of MCP design focuses on security and controlled access. The host is in charge of managing the clients and approving which servers they can connect to. This means users and organizations have full control over what their AI assistants are allowed to access, ensuring everything is tightly secured, which is really crucial when it comes to open source intelligence. Now let's see what is the real life impact of MCPs worldwide. The true power of MCP, Model Context Protocol, becomes clear when we look at how it's being applied across real world tools and platforms. MCP is already powering some pretty impressive tools across development, enterprise, and data analysis. In the dev world, tools like SourceGraph Codey and Z Editor uses MCP to give AI assistants access to large code bases and dev resources, making code suggestions smarter and more context-driven. While in enterprise settings, Block uses MCP to securely connect AI with internal data. Then comes Apollo, which links AI tools to CRM systems, improving the decision-making and client interactions. Even for the data querying, apps like AI to SQL let users generate SQL queries using natural language, all made possible through MCP. Claude Desktop is another great example. It uses MCP to access local files and apps securely, so it can offer highly relevant real-time help on your machine. Beyond that, platforms like Replit, Codium, and Appify are integrating MCP to let AI agents automate web searches, extract data, and even review the GitHub PRs with full context. From coding to workflows, MCP is becoming the go-to standard for connecting AI with the real-world tools securely and at scale. But the potential doesn't just stop here. Imagine a personal AI assistant with the deep access to our local apps, files, workflows, or even complex workflows orchestrated across multiple systems. Thanks to the MCP standardized, secure, and scalable approach, all of this is possible now. The goal for MCP servers is to become a standardized method for integrating AI tools and services across the web. With this approach, as new AI models and tools are created, they will seamlessly connect through MCP servers, allowing a far more interconnected and efficient AI ecosystem.